Creating an open world is no easy task, but in this video I'll show you how to build a powerful landscape AutoMaterial from scratch. In the next 6 hours I'll guide you step by step and teach you everything you need to create the landscape material of your dreams. This material works automatically. It blends textures based on height and slope. It can spawn foliage and 3D objects per layer. Every layer, texture and settings is fully customizable. Once you master it, you can build any biome: deserts, snow peaks, tropical islands, dense forests, all with the same material. Just plug it into your landscape slot and watch it go to work. If you don't have time to watch the full tutorial or just want to start creating right away, the finished AutoMaterial is already available on my Fab page. You'll also find my interactive water system and interactive foliage system there. Combine all three and you get the ultimate landscape building bundle for Unreal Engine. Also on my Patreon, you can grab the same bundle and gain access to an ever-growing library of game dev tools, premium tutorials and exclusive systems I've built to speed up your workflow. It is also a great way to support the channel if you find these videos useful. Alright, let's jump in and build the ultimate landscape AutoMaterial. In this part we're going to talk about Gaea, how to utilize and how to use Gaea in order for you to create those beautiful and highly detailed landscapes that later on we're going to import in Unreal Engine and use it for creating our AutoMaterial. So let's just straight jump to it. So when we talk about open world massive landscapes and games that has this, the first question that came to my mind is how you can create those landscapes. And yes, of course, you can create them by firing the landscape in Unreal Engine and start drawing with the brush, but I highly recommend to use an external software. The software of my choice is called Gaea 2.0 and it is created by QuadSpinner. So if you go to quadspinner.com, Gaea 2.0 is now available for everyone, so you can download Gaea and start working with it. The one catch is that when you start exporting your Heightmap from Gaea to Unreal Engine, the only limitation is that you can export 1K texture, but this is more than enough for you to test out if Gaea is your software, and later on you can buy a license from Gaea and export textures up to 8K for Unreal Engine. So why is Gaea the choice for me to use it and create those open worlds that I'm working on? The first thing is that it has a node-based system just like the material editor in Unreal Engine, and it is non-destructible. So everything that you put in the node is tweakable and it will change everything in the chain. And as you can see here, we have pretty high control and very sophisticated node-based system that can create those realistic terrains. The next reason that I'm using Gaea is the studios that use Gaea. So for example, if we take a look here, we know that God of War Ragnarok was using Gaea, Baldur's Gate, Alan Wake, Halo, and also Weta Effects are using it for advertisement and film production. Stopping on the studios, you can see that PUBG is using it, Blizzard, Respawn Entertainment, Square Enix, which I think they also use Gaea in Tomb Raider, Ubisoft on their new Assassin's Creed, Weta Effects, Remedy, etc. Gaea is the perfect software to simulate reality and integrate it in Unreal Engine and have your landscape look pretty realistic. You have the next-gen erosion, you have cover erosion, and over here, of course, you can add snow and dusting to your landscape, and this is how it will look inside your game. Pretty realistic and pretty accurate to the real world out there. The great thing about it is that you can pretty quickly prototype realistic terrains and iterate with the non-destructive workflow. The idea that Gaea has a plugin, Gaea to Unreal Engine, which you can connect, and with just one click you can go back and forward between Gaea. So for example, if I start making tweaks on this terrain, it will be accounted in Unreal Engine, and the workflow and pipeline is super fast between Gaea and Unreal Engine. You can see over here how realistic the surface can be. Also, you can combine different shapes with the transpose node and they will blend together. So here is the reference, here is the source, and combining the reference and source by using the transpose, you're gonna have this final effect over here. There are a huge amount of tools like the transform tool, which you can start and moving mountains. here rock tool. With this rock tool you can paint different sections of your landscape where you want to have different kind of rocks, maybe cliffs, maybe those sharp rocks, etc. The other great tool that I highly recommend that you use in Gaea is the draw terrains. So by using a brush over here, you can start drawing by hand terrains, and on the left side here, you can see how the terrain is shaping by using real weather effects for erosion, for creating canyons, etc. But using this brush, you can shape the exact terrain that you want to be inside your game. Also, like I said, you can use a paint effects to paint different rocks onto your terrain in certain areas that you want. Here is how a final landscape could look like inside Gaea. As you can see here, everything is super detailed and super realistic. You have the snow line, you have simulated the lakes over here, you have the rocks, you have the forest. You can also, of course, simulate vegetation. And this is a great example how you can create different regions inside your landscape. Here the artist created a large mountains, the pit over here which is going under the sea level, and here is your city of your game, for example. Keep in mind that Gaea has this plugin, like I said, Gaea to Unreal. It is also PCG friendly and support PBR maps. And for those people who are worried about meshes and want to have a budget in the polygons, Gaea has adaptive meshes. So if you want this super high fidelity over here on the left, you can see that it has more meshes on the slopes and in the mountains. On the right side, you have this clean mesh that you can use inside your games or maybe inside something else that you're creating with, maybe an architecture visualization or some flyover video, etc. So Gaea support this adaptive mesh to help you out with the performance of your game or with your video or whatever you're creating there. Also, a shortcode plus chain creation is great, so you can type the different nodes that you want, one after another, separated by a comma, and they will instantly connect to each other. So if you have a certain pattern that you always start with, this is an easy way how you can save a lot of time. Of course, everything is tweakable. It is just like the material node editor in Unreal Engine. Everything is super flexible. Everything is non-destructible, and you can, change it in real time and it will affect everything on the chain. So just click on download and click the installer exe and then install Gaea. So let's go to Gaea and start creating a very simple world that will be the base of our AutoMaterial. So here I'm going to explain just the basics of the interface so you're not lost, but I'm not going to create something very detailed, as the idea of this video is to create the landscape AutoMaterial inside Unreal. But in order for us to have a world, we need to create something with Gaea. So here on the left is your tool palette. So if you go to primitives, you have different primitives. If you go to the terrain, you have different kind of landscapes. So if I place canyon over here, it will start generating a canyon for me. And the settings that you can tweak, you need first to left click on your canyon. And here you can use the different sliders in order for you to start tweaking the canyon. One hint that I want to show you is if your PC is kind of, not so powerful, over here you can go and change the preview resolution to 500 by 500, and it will load up the changes pretty fast. So if you go with tweaking the surroundings, you can see how fast it loads up the changes. If I go and let's say 2K, the preview will be more detailed, but it will take more time for me to work on. So when you start creating your first landscape, try to keep it on 500. Make different iterations, just work on the big shapes. And after you work out the big shapes, then you can switch to 1K and start working on the small details over here. That is one thing that I highly suggest, because this will speed up your workflow by a lot. So here are your primitives. Here you can tweak everything per block that you add. If I delete it and if I right click, I can access a quick search menu. So if I search for erosion, you can see here that we have all the erosions over here. And if I click erosion number 2, I'm going to have this erosion and all the settings over here. And from here, you can access different settings, but I'm not going to cover them. We're just going to straight go and create a landscape that we are going to use in Unreal Engine. The first thing that I need is mountain range. So I'm going to right click and I'm going to search for mountain range. So this one. And here I have a settings that I've already set up, but just dragging the scale, it will start scaling up your mountain range. This will scale it up in height, but I'm going to put 0.8 over here. Let's try 0.8. And for the height, I'm going to put 1.99294, something like this. So I'm just going to keep the bulk to low and the style will be eroded. All right. I'm just going to play a little bit with the seed just to test out what I want. By playing with the seed, it will generate a different terrain each time. So I'm just playing with the seed and you can see that it's generating different kind of terrain for me. All right. That's pretty good. So moving further, what I need to do is I need to add a little erosion to this terrain. So what we need to do is we're just gonna right click and we're gonna add erosion 2, which is the new erosion supported in Gaea 2.0. And after we add it, we need to connect the mountain range to the erosion. So let's connect it. And how to preview the different nodes. If I left click on the mountain range, you can now preview only this node. And if I left click on the erosion, you can see that we have erosion starting to form here. I'm going to start tweaking the duration and I'm going to put maybe something like 30. This says how much in time the erosion spends to deform this landscape. I'm going to do the downcutting to 0.35. You can see that this is starts to cut the terrain itself. If we go up to too high, you can see that a lot of cuts are done on our terrain, but I'm just gonna do 35, something like this. Okay, something like this is good. Then you can do erosion scale. You can play with the seed. I'm just gonna play a little bit with the seed to find something that I like. Let's try 34, 35, 36. All right, this is the seed that I want. This is something that I like. If you want to add a little bit more definition and randomness in your sediments, you can start randomizing the suspended angle. Right, so I'm just gonna randomize it a little bit, 22.41. Okay, so now I'm just gonna go back to my landscape and I'm just gonna tweak a little bit the seed to the height. Something like this. I want a little, meadows over here, not to have super high mountains, but I want to have also peaks where I want to see the snow from my material that we're gonna create. So let's tweak a little bit more to find that great middle ground. So I think this is good. We have mountain range over here and we have flat surface. And right now I'm just previewing the mountain range, clicking on erosion, we add the erosion. The next thing that I want is I want to add river. And for the rivers, my idea is to use my water and ocean plugin, and Gaea will just guide me where I want to place the rivers and the ocean. So I'm going to search for rivers. I'm going to add this node, and from the output, I'm going to connect it to the input. And right now it will start creating rivers. And as you can see here, it is defining where the rivers are onto my landscape. And by having this definition, I will simply follow it along in Unreal Engine and create the interactive water and river based on my system that I provide in Patreon and Fab. This will act as a guide for my system. I'm just gonna play around with the settings a little bit. I'm gonna try a little bit of the down cutting. So I want to cut a little bit in the landscape. Let's do 70. Right now I'm just cutting inside the landscape so it can have a little, edge over here. And this will be easier for me to follow along in Unreal Engine and create the interactive water and river system. Let me just tweak a little bit the depth. And you can tweak the width of the river itself. You can see that it's getting wider and wider. Keep in mind that the aspect here is pretty huge. Don't be fooled that it looks, you know, small. And I'm gonna do around 80, I think. 78, 70, 77. All right, this looks pretty good. So rivers will be guiding me where I need to place the interactive water and river system so we can have those interactions in our landscape and game. And after we created this is super simple landscape. You can go a lot crazier. Just go to Quad Spinner, just go back into my YouTube channel and watch more videos that I share about Gaea. Go to the forums of Gaea, and there's a lot of tricks and in-depth videos on the forums, also on the YouTube channel of Quad Spinner, and you can learn more about Gaea. This video is about how we can create the landscape AutoMaterial, but this is a crucial part in order for us to have this very detailed landscape that we can work on. The final step after you've done this is to create an export node that we're gonna export to Unreal. So I'm gonna search for Unreal, I'm gonna select it, and I'm gonna connect the output to the input over here. And from the right panel over here, you can select the target size, what we want to export to Unreal. If you're working on a free version, you will have only 1K available, but I'm going to export 2K. The next thing that you want to choose is the format. You can either export PNG or R16. I'm just gonna export right now PNG so we can preview the final result. Now how to export it, go to Project, Build Settings, go to Build, and under Build Destination, I'm gonna hit the three dots. I'm gonna select my folder and click Select Folder. I also want to open the folder after the build is finished, and I'm gonna click Close. Now let's go back to Project, click Build and Export, and click Start Build. It will start building your terrain, but first you need to save your project, so I'm gonna save it under MM1. And now it will start building your project. After your project is built, you're gonna have this Heightmap, which is called right now HRiver output. And you're gonna see all the height detailed that we've created. This height map will be loaded up in Unreal Engine and it will create the terrain that we want. Also, Unreal Engine can read an R16 file, so either choose a PNG or R16 for your export. And now let's go to Unreal Engine and import our height map. So once we've created the landscape in Gaea, we need a plugin so we can seamlessly work between Gaea and Unreal Engine. So the plugin is called Gaea to Unreal Engine and the plugin is open sourced. The plugin supports Unreal Engine 5.3, 5.4 and 5.5. As the plugin is open sourced, it is uploaded at GitHub so you can directly download the source code and modify it yourself. Link to the blog post and to the GitHub you can find in the description of this video. So by going here, you can just click download zip file and you're gonna download the entire source code so you can start modifying it. But if you scroll down, let's scroll all the way down, here you have a download section where the compiled versions of the plugin can be found. Just click on the releases. And here under releases, you already have compiled plugin for Unreal Engine 5.5, Unreal Engine 5.4, Unreal Engine 5.3. And of course, if you want to download the source code in zip format, you can download it from here. I'm just gonna click on Guide to Unreal Engine and download the 5.5 version. After you export the Guide to Unreal Engine for 5.5, you're gonna have those three files. You need to copy the entire folder, which is Gaea Unreal Tools, right click, select copy, and you need to locate where you installed your Unreal Engine. Right now, here under Epic Games, I have Unreal Engine 5.5, 5.4, and 3. I'm gonna open Unreal Engine 5.5, go under Engine, search for plugins, and here in the plugins folder, I'm gonna right click and paste it. So we've already exported this landscape, so you can go to project settings, build settings, again, define the folder that you want to export it, select the overwrite in the file overwrite mode and click execute build. After you build your landscape, you're gonna have this R16 file, which we will load in Unreal Engine. Let's go to Unreal Engine and show you how you can load up the Gaea to Unreal Engine plugin. So here we have a fresh new project. I'm gonna right click and I'm gonna create a new folder and I'm gonna name it scenes. I'm gonna go to file, create a new level, and I'm gonna select basic, hit create. And here in this basic level, I'm gonna select this floor, I'm gonna delete it, I'm gonna select file, and I'm gonna save all. Right now, I'm just gonna select here scenes, and I'm gonna select AM2, which stands for AutoMaterial 2. And right now, the plugin is not enabled in Unreal Engine, and we should go to Edit, Plugins, search for Gaea, and here you need to check this box. I'm gonna check the box, click yes, and you need to restart your Unreal Engine. Now, when you enable the plugin, it should look like that. I'm just gonna hit X to close it, and you're gonna have a new button over here. I'm gonna open my scene, which is AM2, and from this button, you have the hotkey Control Alt and P. You can open the Gaea Landscape Importer, or you can just click it over here. So right now, what you need to do is simply click Import Heightmap, and then you select your R16 file, click Open, and right now we loaded the Heightmap file name data and the JSON data. Here, what you can do is you can also enable world partition grid size. You can adjust it to have bigger grid size in the world partition. You can flip it on the y-axis. You can select a material for the landscape if you want straight ahead to import it. Also, it can hold layer info folders, which mean you can create paint layers. But this is something that is not a topic of this video. If you want to know more about Gaea, just go back into my channel and watch the other videos about Gaea. So right now, what you need to do is click on Create Landscape. And now your Heightmap is imported into Unreal Engine. But the best thing is that you are working with non-destructive workflow, which means that when I go back to Gaea and start making some changes over here, let me go to the mountain range and I'm gonna play just with the seed. Let's say I put a different seed and it will turn my mountain into a different one. And now this landscape looks a little bit different compared to this one in Unreal Engine. We've made some changes, but the cool thing is that we can import the new one with just 2 clicks. So go to Project, Build Settings, Execute Build, and start building. And once the build is ready, you just go back to Unreal, select the landscape, right-click on it, Gaea Landscape Actions, and just refresh the landscape in place. And once you refresh the landscape, you can see that it is completely different landscape. The idea here is that you can go back to Gaea, create different shapes, upgrade your landscape, something that you want to change, etc. And just export it again, load it up into Unreal Engine and refresh it. So that's the non-destructive workflow and how it works. And this is pretty huge and pretty important workflow in order for you to define your landscape and the shape that you want. This is again non-destructive, and that's the power working with Gaea and Unreal Engine through the Gaea to Unreal Engine plugin. So we've created the landscape in Gaea, we've imported it into Unreal Engine, and I showed you how you can work with this non-destructive workflow between Gaea and Unreal Engine in order for you to modify everything. So the step to create the landscape and show you how to work with Gaea and Unreal Engine is done, and let's move further with the next topic. In the old AutoMaterial video, a lot of people ask how you can create the MoCap textures. Texted me in Discord. So right now I'm going to show you how you can easily create those MoCap textures. Those textures are just there so we can create the material and later on you can substitute them with real textures. So I'm going to show you how you can create the albedo, the normal, and the RDAO MoCap. Right now I'm using Photoshop. You can use even Paint or GIMP, whatever. It is super simple. I'm just going to go to the text over here. and I'm just gonna put a text albedo. I'm gonna select the text and I'm gonna make it red. All right, I'm gonna center it like that. And I'm gonna select the text, the background, hit V on my keyboard and just align it in the center. So this is my albedo texture, super simple. I'm gonna go to File, go to Save As, and I'm gonna select PNG. And then I'm gonna name this albedo MoCap. I'm gonna hit Save, I'm gonna click OK, and this is our albedo texture. For the creation, to create the normal texture, just change the text, normal, select the text, change the color to blue, something like this. And again, go to Save, Save As, select the PNG, and name this as normal mockup. Hit OK. We've created the normal. And finally, we need the RDAO. Select it, select the color, go to the AO, select the AO, and then do the same. File, Save, and then we go to the PNG and name this RDAO mocap. Save it. Click OK. And right now we have those three textures that we will use as placeholders to design our AutoMaterial version 2. Drag and drop them into Unreal Engine. But first we need to create some folders. So right click here, create a new folder and call it Landscape AutoMaterial version 2. And here I'm going to create a new folder. I'm going to call it Textures. And in this texture folder, I'm going to create a new one, which I'm going to call Placeholders. All right. Then I'm just going to drag and drop them into Unreal. And our mocap textures are there. Then I'm going to open the normal mocap. And here right now, it is not flagged as a normal map. So I'm going to go here and select normal map. And I'm going to save it. And right now, this texture simulating a normal map. So when we start connecting in our material graph, we don't have SM6 errors for the compression settings, that this is not flagged as normal map, but it is a default map. The next texture that we need is the landscape variation. This landscape variation is exported from Gaea, and I'm going to provide this for free. So go into the link of this video and download this texture. The other textures that you will need for this project is the landscape variation, which is created through Gaea. And this is showing some patterns of the landscape. Then I exported a normal map from Gaea, also connected with the landscape variation. The next one is the noise mask. The noise mask is created from different kind of clouds. So in the blue channel, I've put those clouds. In the green channel, we have different pattern of a cloud. Then in the red channel, another pattern of a cloud. And when you combine this, you have this kind of a noise mask. In order to create the clouds, you can go to Filter, you can go to Render, and you can click on Clouds. And you start creating different kind of clouds. Of course, you can go to Google and just download 3 different textures of that kind and just place them in the different channels. To place them in the different channels, go to Channels, select the blue channel and paste the texture that you've downloaded from Google. Then select the green channel, then select the red channel and just paste your textures there. And if you want to use the Photoshop, in the blue channel we have this cloud, then in the green channel I'm going to go to Filter, I'm going to Render, I'm going to create different clouds, I'm going to go to my red channel, Filter, Render, and I'm going to create a different cloud. And let's go to the blue channel and just create another different cloud like that. And we end up with this noise texture. So this is how easily you can create the noise texture. It is nothing special. And you can start tweaking the values. For example, I'm just going to tweak a little bit more the whites here. So I have pattern like this. Let's say I'm going to tweak here a little bit more. Let me tweak it like that. And you end up with that kind of texture. Of course, as I said, those are textures downloaded from Google, and I've combined them to their RGB channels. Then the next one is a water normal map, which is kind of a wavy normal map, which I also gathered from CG Textures. So this is a texture that we will use later on. And the final one is this texture, which is created through Photoshop. And let me show you how you can create it. You can go to Filters, Filter Gallery. And then here under Textures, you have this stained glass. And from here, you can start tweaking the texture parameters. About the border thickness, something like this, about the cell size and the white intensity. So you can make it like plain like that, and after that you can, for example, start boosting the light, so brightness, and I can boost the brightness. And if I open the texture, it has those, patterns. However, all those textures, all those 5 textures are available for free download. So check the link in the description and you can get them and you can save some time of creating them. All right, then I just imported the textures over here and let's save the project. The next step is to get textures from Quixel. I already selected textures for all my layers from layer 1 to layer 5. And here are the textures that I've selected. I also have this snow over here. And the important thing here is that I've created ORD and ORM textures based on the downloads from Quixel. Those textures are also included with the texture pack in the description below, but let me show you how you can create the ORD and ORM if you're downloading textures from Quixel. So when you download the textures from Quixel, you have all these textures. And the first one that we are going to create is ORD. So this ORD textures stands for Occlusion, Roughness, and Displacement. And what we need to do is just drag our ambient occlusion into Photoshop. And in our red channel, as you can see here, we have the occlusion map. If we go back to the Photoshop, in our channels, right now we have in all the channels our occlusion map. The next step is to drag and drop our roughness map into our Photoshop on a separate file. And I'm going to select with Control A, and I'm going to select and I'm going to hit Control C to copy it. Then I'm going to go back to my original texture, go into the green channel and select everything and hit Control V. So right now what we are doing is in our red channel, we have our occlusion. In our green channel, we have our roughness. So we've created right now OR. And the next step is to place the displacement in our blue channel. So I'm going to drag here in Photoshop. I'm going to select this, Control C, then go back here, blue channel, Control V. And right now we've created our ORD texture. Then you go to File, Save As, and select PNG and save it. This is how we can create our ORD texture. The next texture is ORM texture. So instead of having the displacement channel here in the blue channel, and in the blue channel we need to place a metallic texture, but those rocks doesn't have any metalness in them. So what we need to do is we need to select the black color and fill up the entire blue channel. Because we don't want to have any metallic onto this texture. But if you have, for example, some kind of a metal that you want to have metallic, you just need to place the metallic texture here in the blue channel as we did with the displacement. And here in Unreal Engine, you can see that in our blue channel, we have nothing. In our green channel, we have our roughness. And in our red channel, we have our occlusion. So those are the two types of textures that we are going to use later on in our material. And again, everything is available for download in the description of this video. Then what you need to do in your project, just create Quixel texture folder. And after that, create 6 folders, layer 01, layer 02, 03, 04, 05, and layer snow. And place the textures like that. Here, I'm going to have the rocks layer. Here I have the cliff. And in layer 3, I have the mossy grass over here. And then in layer 4, I'm having this also rocky texture. In layer 5, I have this rocky ground with some pebbles. And at layer snow, I have the snow. So download the textures. You already know how to create ORD or M if you want to use your personal custom textures, and place them like that into the folders. So the next folder that we want to create is RVT, new folder, RVT. And here we're going to store our RVT. But for that, we need to enable the virtual texture in our project. So go to Edit, go to Project Settings, search for Virtual. And here under virtual textures, enable virtual texture support. Check it on. And then what we need to do is we need to restart our Unreal Engine. And after we reset the Unreal Engine, we need to create an RVT base. So I'm going to right click here in the search. I'm going to search for virtual. And I'm going to create this runtime virtual texture. And I'm going to call it RVT underscore base. Enter. Then I'm going to open it. And for the size of virtual texture in the tiles, I'm going to put 10. And for the size of each virtual texture tile, I'm going to put 4. Then I'm going to save it and keep the rest like that. Then I'm going to create one more virtual texture. And I'm going to call it RVT height. And this will be responsible for the height of our virtual texture. Later on, you're going to see when we start connecting it. So I'm going to open. And just the virtual texture content, we're going to change to world height. So from this virtual texture content, world height, we're going to take in consideration the world height for our RVT. Then I'm going to save. So in this chapter, we're going to focus on creating the color correction panel. And here in this color correction, we're going to have a lot of different settings that we can tweak and modify the texture itself. I'm just going to show you pretty quickly how this works. Right here, we have a color correction, which controls the tint. And if I go here and place a red, we're going to add a red tint color to our texture. So we're going to create here a tint effect. And if I go with Control Z, we're going to have this little greenish effect. And I've added intentionally this green effect. So it looks like more of a yellowish grass, but when we apply tint, we've created this green grassland. So we have this tint control that we're going to cover. We have also controls like brightness. So we can tune up the brightness, or we can turn it down, something like this, or 0.1, a little bit darker. We can control the contrast from here, maybe 0.3. You get this dark contrast in it, 0.22. So with all those controls, you can modify the look of your textures. And this is super powerful because this is per texture. Here we can control the grass texture. We also have the same settings here in the rock texture, and you can match your environment and make fixes to those textures in real time. And here you have also an option to desaturate if you want, or just use the saturation. You can control the black power, the white power, etc. All right, so let's deep dive and create the material function color variation. Now we're going to start creating the material functions, but first we need to create the folder. So I'm going to right click on my landscape AutoMaterial, and I'm going to create the folder material. And in this folder material, I'm going to create a new folder and call it material functions. And the first material function that we are going to create is material function color variations. So right click, search for material, and select this material function. I'm going to name it material function color variation. Now let's open it. So this particular material function will control the color variation into our textures. The first block that we need is we need to control the color contrast. So imagine that right now we're in Photoshop and we have this brightness and contrast. Through the contrast slider, we can control the entire contrast of the image over here. It doesn't matter if it's, colorful, white and black, whatever. For example, if we start controlling white and black texture, you can see how we can pop up a lot more the detail. Right now is washed up, and if we tweak it like that, we have this control. So this is what I want to make here in Unreal Engine. We want to have control on the contrast of our textures onto our landscape. So what we need to create is a power function. Then we need to right click and create a function input. So this will input in the expression a function. And what we need to have is a scalar. Scalar is a parameter that we can tweak like a number from 0 to 100, something like this. It is not a vector 2 or vector 3. It's just a simple one value parameter. I'm gonna name this contrast, and I'm gonna put it into my exposure over here. And right now, let me show you what power is doing. So let me connect power here to the output and let's disconnect this one. So right now, let me just quickly show you what power will do. So I'm just gonna go to my textures and let's use this texture. I'm gonna drag and drop it over here. This is just to explain how this works. I'm gonna connect the RGB over here and I'm gonna connect it to my output. And right now in my output, we are previewing the material and this is how the material looks like. If we start tweaking the exposure to 0, right now we don't have any details. This means that we start washing out our material. So let's try 0.5. And you see how we have some washed up, but the details are start to losing out. This is the same when we start dragging the contrast like that, we start washing out all the details. But if we go into the positive side, let's say 5, you can see that right now we started popping out the details over here. Let's try with 4, 3. So we start defining more and more the details on our texture over here and just softening out the rest. So this is what power do. So power is similar to the contrast over here that we control in Photoshop. So right now I'm gonna delete this texture. I'm gonna connect my scour parameter here to the power and I'm gonna save. Right now we have an error because we are missing a base input. In this block will control our color contrast. So I'm gonna select it, click C on my keyboard and I'm gonna name it color contrast. So this block right here will control the contrast of our colors. Let's create the next block. In this block, we're gonna control the color brightness and we're gonna use the multiply node. So I'm gonna search for multiply and we're gonna use this math multiply. And let's talk about the multiply node. So if I hold Control and Alt, we will have the description of it. So the multiply expression takes two inputs, multiplies them together, and outputs the result. Similar to the Photoshop multiply layer blend. The multiplication happens per channel, meaning that the R channel of the first is multiplied by the second, the green channel of the first is multiplied by the second, and so on. Both inputs must have the same number of values unless one of the values is a single float value. So the multiply node works like the multiply in Photoshop. And here's a quick example. We have here two textures. And if I select this one and select multiply, you can see that the second texture is getting details of the first one and we are darkening it a little bit, multiplying the colors together. And if we start tweaking with the contrast that we've created, you can start having here mossy rocks, for example. Let me just turn this off, turn this on. And also we're going to control the brightness and you have a complete different type of texture by multiplying it. So normal rocks, here you have this kind of a mossy, more yellowish rocks. So this is what multiply does. It takes two textures and start multiplying it. And here, this multiply node, we're gonna control with the brightness scour. So I'm gonna select this scour, I'm gonna hit Control and C, and I'm gonna hit Control and V, just to duplicate it. And now I'm gonna connect it to B, all right? I'm gonna rename this to brightness, and this will control my brightness. The idea here is that in A input, we're gonna input a texture, and through the scour parameter, we're just gonna boost up the brightness of this texture by using the multiply node. And the multiply node will connect here at the base of the contrast. Let me just put it like that. In this block, I'm gonna name color brightness. So this will control the brightness of my colors. Also, when you're zooming out, right now I cannot read the text. You can select the block over here and just click show bubble when zoomed. And when we start zooming out, you can see that this block is for the color brightness. I'm just gonna do the same for the color contrast. So it's way more clean. And let's continue with the next one. The next one, we'll start doing color corrections and we are going to use a vector tree. So I'm just gonna duplicate this multiply, Control and C, Control and V. And I'm gonna add one more. And what we will need here is to connect both multiplies, because into this multiply, we're gonna create a white and black balance and levels like in Photoshop. So we're creating the brightness and contrast levels and white and black balance right now into Unreal Engine. So we don't need to go back into Photoshop and tweak the textures manually. So right now we have those multiply nodes, and I'm just going to connect the second multiply to my color brightness, and I'm going to copy this color parameter, paste it, and here I'm going to connect it to B, and this time I'm going to name this color correction. So this color correction will be used to add additional color on top of our textures. So for example, here in the Photoshop, the color correction will work like a tint. So if we create another layer over here, and let's say put a little red and put red over here, the color correction will work just like the overlay here. So we are just adding additional color to our rocks. So if I turn this off, something like this is going to happen. If we select the green and add it like that, we're going to add green to our rocks. But this is too hard, so we're going to have control how hard it is. And we can, for example, create something like this in Unreal Engine. So if you want to tweak some colors from your base textures, you can do this by using the color correction. So let's get back to Unreal. So in order to input a color here to the scalar parameter, this should not be a scalar parameter first of all. It should be a vector tree. So I'm going to select the vector tree. Then I'm going to right click and search for constant tree vector. All right. And I'm going to connect the RGB over here into the preview. I'm going to hit Q to online, and I'm going to select white for this color. So here we have this vector tree input function. From this function, we can control what kind of color we need to select in order to overlay and add a tint to our textures. So this block will control our color correction. So I'm going to select it, click C on my keyboard and name it color correction. I'm going to click show bubble when zoomed out. And right now we have color brightness, color contrast, and color correction. I showed you the references in Photoshop and how they will affect your textures inside Unreal Engine. And this setup is very important later on because having control over those little tweaks will make your scene to look AAA. The next function that we want to create is how we can control the black and the whites. So before we create the black and white power, I just want to show you off how this works. So right now we have this green grassland and we have some details here which is into the black section, and this is more into the white section. And we can start, exaggerating this. So here from the black power, if I put 0.1, you can see that we add more black spots over here and we are just exaggerating the black part. If I do 0.5, you see that everything goes to black and we have the white spots only here because that's too much. Let's try 0.05. So now we've added a little detail. Let me just turn it on and off. You see how we added a little extra detail. Let's point 0.9, 0.2. You can see the difference. So those are the black spots that we exaggerate. So I think 0.09 is good for me. And we have this extra detail. We can do the same for the white power. If I do here 1, you can see that we are adding a lot of power to the whites. And if I do 0.4, let's try 0.5, 0.6, 0.85. All right, 0.85 start popping out. That's a little bit too much. 82, 81. So you get the idea. From here, you can exaggerate your texture and play with the settings of the black and the whites. And with the combination with contrast and the brightness, you can get kind of different effects here. If we tune up the contrast a little bit, you can see that we can get a little darker grass, 25. Let's do 22. Let's do a brightness of 0.2. Let's try with 1. And you can have completely different setup here by controlling them. Let's try 0.3, and here let's put something like this. So yeah, just controlling the whites and the blacks, you're adding additional details to your texture, and this works great for stuff like rocks and cliffs. All right, so let's continue on and create those controls. Here, again in Photoshop, for example, if you go to black and whites, we can start tweaking up the black and whites controls over here from this preset. Like you can see here, per channel, we can start controlling and tweaking all the levels. And this is what we want to have in Unreal Engine, not to go back here in Photoshop and start tweaking all textures separately. So let's go back to Unreal and create this logic. So here we have two multiplies. I'm going to create one more multiply. And this multiply, I'm going to connect it to the first one and to the second one. And let me explain why I'm doing this. It is because I want my black and white controls first to apply to this color correction. For example, if we are using color correction, I want the black and whites to go here to apply to the color correction before we start multiplying with the same black and whites corrections. So the first we apply to the color correction, then we apply it again to the multiplication of the color correction and of the black and whites. In this way, we keep the black and white correction also included in the color correction here into the tint. So let's continue on. This is the first block that will connect to the rest of it. So let's copy this vector tree, Control and C, Control and V. So this will be responsible for the albedo texture. And from here, we're going to start creating the logic. The first thing is to desaturate the image. So I'm going to right click, desaturate, and under color, desaturate. And why we are creating the desaturation? Because when we go to our Photoshop and enable the black and whites, you can see that Photoshop instantly desaturate your image so you can start working with the black and whites and start tweaking them up. And that logic we need to recreate in Unreal Engine. So I have this desaturate and I'm going to duplicate it one more time over here. And the first input that we need is the saturation. How much we want to desaturate this texture image, this albedo texture image. So I'm going to connect it over here to the desaturation. And I'm going to copy this scour over here. I'm going to paste it. Let me move it like that. And I'm going to connect it to the fraction. So through this scour value, we're going to say how much it will desaturate this albedo texture. And I'm going to name this desaturation. Now I'm going to connect also the albedo texture over here to the desaturation. And I'm just going to feed the path over here. So we are desaturating one more time, but here we are just using the base values of the desaturation node. The next blocks that we want to add is cheap contrast. So I'm going to right click and I'm going to select this cheap contrast. So by adding this cheap contrast, we can control the power of the black in the image and the white in the image. So what we need to do over here is connect the desaturation to the in and copy this color parameter and connect it to the contrast over here. And here I'm going to name it black power. So through this scour parameter, we can bump up the desaturated texture, only the black parts of it. This is ideal because you will have full control over the image black and white. And what we need to do next is we need to create another multiply node. And the idea here with this multiply node is to connect the cheap contrast to A and connect the desaturation to B. Let me just fix the rerouting here. And I'm just going to explain why I'm doing that. All right, we start here with the texture. We go here and desaturate the texture. We tell how much we want to desaturate. Then we add a cheap contrast. The idea is that the cheap contrast should multiply with desaturation separately. And then we start combining them here at the multiply node. This will give a great effect over the control of the black values of the image. So you just need to multiply the cheap contrast that we've made on the desaturation texture and add the texture itself, and we will have this nice and soft control over through the black values in our image. Of course, we need to do that for the white values of our texture. So I'm going to copy this cheap contrast and black power scour, paste it over here, and I'm going to name this white power. Through this, we're going to control the white power. And I'm going to connect again the desaturation over here into in. And then I'm going to right click and search for add. And I'm going to connect the multiply to B and the cheap contrast to A. So right now, what we are doing with this add node, we are adding both corrections here, the black and the white, and we are adding all together and outputting a final texture. And this final texture, we're going to connect to B output over here. But we have one mistake over here, because when we control the contrast over here, we have the black power, which is working with the contrast. But in order to work onto the white values, we need to reverse this. We need to reverse the scalar parameter. So we're going to use 1 minus, and I'm going to connect this to 1 minus, and then I'm going to connect to contrast. So right here, we're controlling the black values. And if we want to use the same logic, we just need to reverse the scalar parameter in order for us to start controlling the white values. So we're ready with this block. I'm gonna select them, create a comment by clicking C on my keyboard and call it white and black color controls. And also I'm gonna click show bubble when zoomed. The next control that we are going to create is levels, and this is my favorite thing because I spent a lot of time thinking how I can export levels controls from Photoshop into Unreal Engine, and finally when I did it and when I start tweaking the levels inside Unreal Engine, everything looks pretty great. The most important thing is to tweak the levels gamma, as this is giving the power of the other. So if I put here 2, you can see that we have this texture like a snow. But stay with me, if I go with the levels input white, you start tweaking the whites, you can get different kind of textures by controlling the levels. And then if I go and tweak the input black, let's say to 0.35, we can get here a little bit out of the whites. And if we start controlling the output white and the output black, we are controlling the outputs, let's say 0.2, 0.1, you can see that we get this kind of effect. And if we start tweaking up the brightness, let's say 0.2, 0.2, we have complete different picture over here. And if we start tweaking the level gamma, you can see how we are exaggerating all the elements behind the level gamma. So the level gamma is like the master control of everything here, of the levels input, white and blacks, and the levels output, white and blacks. So controlling the level gamma and then into the other settings, you can get pretty much very good results. And you can break down and break up a lot of the patterns in your textures by just tweaking those values. So after we tweak all the settings, we can see here that we have different variety in our grass texture. It's kind of more detailed just by tweaking those settings. And we have a lot more settings over here. So let's start and create the levels controls. One more function from Photoshop that I think will be very useful in Unreal is how to control the levels. So here in Photoshop we have 3 sliders, and by sliding those 3 sliders we are controlling the levels of the image. So we can make it like that, the more bright parts, and then we can boost it up like that. So we want to have the same control in Unreal Engine, controlling the levels. And this is a little bit more complicated. It took me a while to test and try and create the exact material block, but I have it done. So let's go back to Unreal and create this level function from Photoshop to Unreal Engine. So the first thing that we need is a starting value. So I'm going to hold 1 on my keyboard and I'm going to use a starting value as 0. This will be my starting value. So I'm going to start subtract. So let me explain what this subtract node does. The subtract node takes in 2 inputs and it subtracts the second input from the first and outputs the difference. The subtraction happens per channel, meaning that the red channel of each input gets subtracted from the first, etc. So what I'm doing is I'm going to select the albedo texture, connect it to A here, and I'm going to subtract the value of 0. This is in order for me to create the first slider. And what I need to do is I will need another subtract over here. And I'm going to copy those values, the scalar parameter, just to use it. I'm going to put it like that. And the first will be my levels input white. Levels input white. So this will be the input for the white values of the texture. And then I'm going to duplicate this and I'm going to call it levels input black. And this will be the input for my black values. And I'm gonna subtract the white and the blacks. And then I'm gonna need another node, which is divide. And divide will divide the result of the first by the second. I'm just subtracting the texture from a neutral value of 0, and I'm gonna plug this in A, and we are dividing this to the subtraction of the white and the black inputs. All right. Moving next, I'm gonna do a power. All right, I'm gonna connect over here. And right now we want to give a little levels gamma. So we want to play with the gamma. I'm gonna select this one, copy and paste it, connect to the exposure. And from here, we're gonna control the gamma. So levels gamma. Here we input the white and the blacks, we subtract both of each other, and then we divide from the albedo texture. And then after that, we add a gamma, so we're boosting up the values. And finally, this is the right slider, which will be my output black and whites. So imagine this. Here is my input. Let me just scroll them. This is my input. So imagine this. This slider, this handle here is my input black and whites. This one is the gamma. So we control the gamma from here. And this one is the output of the black and whites. So by tweaking those sliders, we can control and create similar effect in Unreal like the gamma. So right now we have the left slider and the middle one, which controls the gamma. And finally, what we need to do is we need to create the output blacks and output whites. So I'm just gonna copy this one and put a name of levels output black. I'm gonna duplicate this and levels output white. And in order to connect everything, we will need to use another function, which is called lerp. So I'm gonna use lerp, which is linear interpolation. So the idea of the lerp is to connect A and B over here and says how to lerp it, how much to lerp it through the alpha. If I hold Control and Alt, you can see that the linear interpolation expression blends between two input values based on a third input value used as a mask. So we are just lerping between A and B, and alpha is working like a mask. So in general, if the alpha is 0, the first input is used. If the alpha is 1, the second one is used. And if the alpha is between them, you will blend between the two inputs. So also keep in mind that this is per channel. So the R channel of the A input is blending with the R channel of the B input. And what we need to do is we need to connect the output blacks to A, output whites to B, and we're going to use all this logic as a mask to lerp. And finally, we need to connect our lerp to our multiply over here so we can multiply with the white and black color controls. All right, so this is our levels in Photoshop created in Unreal Engine. I'm going to select them, comment, and I'm going to name them levels controls like in Photoshop. And I'm going to hit show bubble when zoomed. All right. So we are ready with our MF color variation. I'm going to save it. And right now we have full color control over our texture in our material. So by finishing with this material function will have the power to create full color controls over our textures in the landscape. And the final thing that we want to create here is to set the priority, how they will be aligned. So the first one I want to show is the albedo texture. Then we can go and control the color contrast will be 1. Then I'm going to go to the brightness will be 2, because those are the most important. Color correction will be 3. Then let's go to the desaturation will be 4. Black power will be 5. White power will be 6. Then continue on with the levels. Levels input white 7. In blacks will be 8. The gamma will be 9. The output blacks will be 10. And the output whites color will be 11. Now I'm going to save this. And why we did that sorting, I'm just going to quickly show you. If I create a material, and let's say this is my master material, and I drag and drop this function, we can see that everything is ordered correctly. Albedo texture, contrast, brightness, color correction, desaturation, black power, white power, everything is ordered as I said it should be. So that is why we set up here the set priority. It starts from the top and it moves to the bottom, but this way it keeps very organized my material function. So keep that in mind. So right now we have the MF color variation, which will help us to control the color variation into our landscape textures. So right now here we can take a look at those rocks. They look a little bit 3D-ish because we are using displacement here in our material. But when we add displacement and normal map mixed together, this is what will happen. So right now you can see how they look. They look kind of 3D, but they're a little bit flat. And I want to add more details to them by combining the normal map and the displacement. So when I turn the normal intensity, you can see that we are giving them extra volume. So if I put 0.5, not to be so dramatic, and by start tweaking those values here, like 1 or 2, we are just softening them a little bit. So by tweaking those values, you can give extra details to your rocks here. You can see how we get those rocks to pop out, and they feel a lot more like it's part of the environment. It's like a mesh object. So this is what we are going to do in this chapter. So if I turn them off, they still look good, but they lack this extra detail that we can get out with the normal map that we already have. So when I turn it on, you can see that we have this extra detail and those rocks are popping out a lot more. So let's start creating the material function normal. The next one is we need to control a function in order to control the normal maps. So I'm going to right click, search for material, and I'm going to create another material function and I'm going to name it mf normal. All right, so let's open it. Let's start creating the normal controls. The first thing is we need the function input, and this should be a vector tree because we are using a normal map which contains R, G, and B, which means it is a vector. So I'm going to name this as normal. And here this input will input the normal texture, all right? So if we start observing a normal map texture, this is a normal map texture that I opened from layer 01. Here we have the R, G, and B channel, but here the B channel is this value. So what we need to do is we need to mask each channel and control the normals in order for us to control the intensity. So from the normal, we need to mask the R and G channel. So I'm going to drag here and search for mask, and I'm going to use component mask. So the channels that we are going to manipulate is the R and G channels, because those two channels, the R and G, are the foundation of how this texture is creating and affecting the normals onto the landscape. So we're masking the R and G. I'm just going to copy and paste this. Second time, and I'm going to connect it over here. What we're going to do is we're going to create a switch parameter. So I'm going to right click and I'm going to search for static switch parameter. And this static switch parameter I'm going to call invert normal. The idea of this is, do we want this normal texture to be inverted or not? Let me show you how this parameter will work in Photoshop. So right now, this is the normal texture that we have over here in Unreal and in Photoshop. If you want to invert it, for any reason we want to invert it, I'm going to select everything and click Control Invert. And I'm just inverting it. So everything here, like those craters, will go inwards, all right? Those will go inwards, those values. So for any reason that you want to change the relief of this normal texture, I'm gonna create a control in Unreal Engine so you can invert it through Unreal Engine and not go here in Photoshop in order to invert the normals. So right now everything is facing upwards, but if we invert it, everything will be inwards, like those rocks are a little bit inside, if you can see the difference in the shade. All right. So if this is something that you need, we are creating this control later on so we can have full control over our normal texture. So through this static switch parameter, if in the material we check it as true, we're going to invert. But right now we are masking the RNG. We are masking those two channels and we are masking it 2 times. If it's false, the inverted normal, we're just gonna keep this RNG how they are right now. But if the switch parameter inverted normal is true, I'm gonna 1 minus, and 1 minus will invert the RNG channel. So we're gonna do the same thing as we here did in Photoshop. We're gonna do that. So this static switch parameter, for any reason, if you want to invert the normal map, we included it, and you can just use it by clicking this check like that in the material, and your normal map will invert automatically. No need to go in Photoshop, etc. The next thing that we want to create is how we can control the intensity of normal map. For example, here in Photoshop, if we go into the brightness and color, if we do something like this, we are tweaking the intensity of the normal map. We're making it to pop out a little bit more. So that is what I want to do. And I'm going to copy this vector, paste it, and I'm going to use a scalar parameter. I'm going to name the scalar parameter normal intensity. And I'm going to multiply this scalar parameter through the invert normal. So I'm going to hold M on my keyboard to pop out a multiply and left mouse button. This is the hotkey for multiply. And right now I'm going to select my invert normal and I'm going to multiply it by the intensity. So depending on what we did choose here, are we inverting the mask or not, we will apply a normal intensity. So we are boosting up the normal map. Then right here, what we need to do is we need to append. And we need to choose append vector under map over here. I'm going to connect the multiply to A. And I'm going to connect this to the output result. And what we need here at the B is to connect the input normal vector 3. But we need to mask the B channel. So I'm going to copy the mask RG, paste it over here. And we need to select B channel, connect it here, and connect it to the append. And right now I'm going to explain what we are doing over here. So let's arrange it like this. So what we are doing right now here, we have R and G over here. We do some logic, invert normals, intensity, input intensity, all right? And in order for us to construct the vector tree, because this is a texture, it uses the R, G, and B channel. We are not controlling the B channel as this is a default B channel and we don't want to control it at all. And in order for us to construct again the entire texture and have the 3 channels and don't have errors, we need to append. So the append is combining the R and G channels with the B channel. So here at the append, we can click on the toggle command bubble and I can say boosting up the normal and recreating the vector again. So we are just recreating the normal texture by appending here. And this is what append tool will do in this case. We are reconstructing this vector tree. So here with this logic, we are creating different modification to our texture. And then we append with the blue channel and we are recreating a final normal texture with the adjustments that we've added. Also, I want to include normal power so we can have control over the power of the normal map, not only the intensity. So I'm going to copy and paste this intensity and I'm going to name this normal power. And I'm going to use the power node. I already show you what the power node does. So I'm just going to use power and let's connect it multiply to the power, power to the append and scalar to the exposure of the power. And right now we have a fully customizable normal map controls. And let's summarize. We have the vector here. We export the R and G channels over here in order for us to boost the intensity or the power. And we also included a switch parameter that will invert the normal. And in order for us to invert the normal, we used 1- and set it up to true. All right. So this is pretty much about MF normal. And of course, what I forgot is to set up the set priority. So let's do that. Set priority is 0. The normal intensity is 1. And the normal power is 2. Let's save again. And now let's continue on. So let me show you how the roughness affect our meshes so you can see what the material function roughness will be. So here we have this section roughness and specular, and I need to enable the roughness and the specular intensity. And if I start tweaking up, so let's start with the specular intensity, you can see that our rocks right now looks a little wet. And when I start tweaking up the roughness, we start tweaking up the places where our rocks are more rough and not so specular. And if I do here also 0.1 and here let's do 0.2, you can see how we start tweaking up together the roughness channel and the specular. and we have all the information from the roughness texture, and you can see how our rocks are start shining. Let's say this is a rainy weather and our rocks are getting wet. You can also control this through a weather system. If you have created in Unreal Engine, you can set up different values and set up the different wetness per object, or here per texture, and your weather system will start making the rocks wet. And if we start tweaking, let's say 0.5 or just 0.1, you can see that we've created some kind of wetness. And if we tune down the specularity, let's say 0.2, you can see that we're getting out of the specular highlights. If we go with 1, we have these specular highlights. You can also control the roughness power, how this will affect. If we do 2, you have it a little bit more smooth and a little bit more shiny. The next step is that you can use a specular texture. You can also invert the specular. So if we click invert, you can see that right now we've inverted everything and the specular is the other way around. So it's looked like a plastic or something, and then we can revert it. And we're going to have the specular. Also, you can use Fresnel specular. So if I turn this on, you can see how the edges are start to fading out because of the camera angle. Let me just turn it off. You can see how the specular is going all the way around, and if we turn the Fresnel, it will be camera based. So it depending on how the camera is taking out and looking at the specular surface, you're gonna have this highlight more realistic if you use Fresnel. So this is about the specular and roughness intensity and what we are going to do in this chapter. All right, so let's deep dive and create the material function roughness, and later on we're gonna create the material function specular. All right. So for a start, we have the color variation and the MF normal. Let's create the material function for our roughness. So I'm gonna right click and search for material, and I'm gonna select material function. I'm gonna name it MF roughness, and let's start creating the tweaks for our roughness textures. And our roughness textures will be easy, so we're gonna search for function input. This will be an easy one. Again, vector tree. Here we're gonna input our roughness texture, all right? And then we're gonna do the same invert roughness as we did for the normal map. So again, here in Photoshop, I'm going to show you what we're going to do with the invert. So if we select this roughness texture and I'm going to hit Control I, we're just going to invert it over here and we're going to have roughness only onto these rocks in this style. So if you want this, we're going to enable this through Unreal Engine. So let's go back and create this. So the logic is the same. We're going to export a mask, but first we will need to know in which channel our roughness is stored. So right now we have ORD and ORM. Where is the roughness stored? The roughness is stored in the green channel over here. So O means the red channel, which is the occlusion. The R means the green channel, and the D means the blue channel. So right now what we are aiming for is the green channel. So like before, we're gonna use a mask here, a component mask, and we know that the roughness in our ORD or ORM textures is always in the green channel. So I'm gonna exclude the other channels and only contain the green channel. So we're gonna create another static switch parameter. From the parameters, static switch parameter, and I'm gonna name this invert roughness. All right, we're gonna do just the same. If we don't want to invert, we're gonna use the same green channel. If we want to invert, I'm gonna copy this green channel, connect it over here, and what we're gonna do, guys, again, 1 minus to invert it. I'm gonna connect it to true pretty easily. So right now we have the static switch parameter to invert our roughness if we want to. And the next two values that we want is the same, roughness intensity and roughness power. And we're gonna do it just like in the normal map. So one multiply node, connect it here pretty easily, copy this vector tree, paste it, create a scour parameter, and we're gonna name this roughness intensity. All right. I'm gonna copy and paste it. This will be my roughness power. Pretty straightforward, nothing too complex. I'm gonna connect my roughness intensity to the multiply. So we are getting the roughness from the green channel. We are saying, are we inverting or are we keeping the original one? Then we start multiplying through with the intensity in order for us if we want to boost up the intensity. And the next one is to control the power, and we're gonna control it through a power node. So I'm gonna connect it here, and I'm gonna connect it to the exposure. So I think this is pretty straightforward. We already talked about multiply, power. If you have some doubts of what this does, go to the Unreal documentation and read a little bit more about that. I show you a few examples. I hope that you get it. And then we connect it to the output result. And let's align everything by selecting and clicking Q on my keyboard. And I have here a clean graph, and we have material function roughness. Let's summarize what we did. We have the roughness vector 3. This is our texture. We export the G channel, as the G channel is responsible for the roughness here. You can see O means occlusion, and it is responsible for the first channel. That is how the naming goes. R is roughness. We put it in the green channel, and D is displacement into the blue channel. All right, guys. So the second one is the roughness on the ORM texture is the same, as M stands for metallic. So we have here in the blue channel metallic if we are working with the ORM workflow. Later on, we're going to include a boolean which can switch between those two modes. All right. And after we did that, we have the invert roughness. Is it true? We're going to use the inverted. Is it false? We're going to use this one. Then with the value, we can boost the intensity and boost the power. And again here, set priority 0. This will be 1, and this will be 2. All right. So we are pretty much ready with this one too. And I'm going to save it. When we talk about depth of our objects into the game and shadows, contact shadows, we always refer to ambient occlusion. And those settings that we have here that we are going to create with the material function ambient occlusion are super important, and they give extra realism to everything that you do. And right now, everything by default is 1, and we have very good control over our ambient occlusion texture. So right now, I'm going to show you how this rock can turn into way more realistic rock depending on your weather conditions and light. But for example, if we go with the AO black of 0 and AO black intensity of 0, then we put for the AO black power 4 and for the AO gray 0.2, we start getting out those details in the rock, and we get a little bit depth in the rock depending on the ambient occlusion. Then let's go further. I'm going to put 0.4 here. By putting 0.4, we are adding extra shadows here in the holes between the rocks. And then if we do 0.6, we are just lighting it up a little bit more, so we soft up the shadow here. It's way more realistic this way. Then we do the AO white, because primarily this ambient occlusion is most in white. So I'm going to do 1.5, and we get those rocks to pop out a little bit. Then we do 0.7 here to even out the color, so it's not so obvious and not so, unrealistic. And I'm going to do for AI power -6, and we even them more. And you can see that we've created a completely different texture with this one. Let me just turn everything off to show you. Here we fix the shadows. Here we fix the shading. We added extra depth to the shading. Here we fix the other kind of shades. Here, which are the gray shades. And from here, we tweak up the AO. As you can see here, those are the white spots that we've tweaked. And here we tweaked the AO power. And if I go back, you can see that it's way more different. Also, it is a possibility to enable few of the settings and just exclude some of the other settings. Maybe you don't want to control the AO white power, you just turn it off and it will work. Maybe you want something like this to pop out those shadows only. No problem, just disable those functions and it will work. So let's go and create the material function ambient occlusion. All right, everybody, you're moving just great. Now let's continue on with our next function, which will be controlling the ambient occlusion. So right click, search for material function, and create the next material function. We're gonna name it mf ambient occlusion. And in this material function, let's open it. We're gonna control the ambient occlusion levels. Let me first explain what ambient occlusion levels has. Right now, what we have in this texture, let me select a brush. We have dark spots, so we have the blacks over here. We have white spots and we have gray spots. I want to control each value with separate scour parameters, so you can have these very fine-tuned controls over the white, gray, and black. So let's go and start creating this material function. It will be very interesting. So like always, we need to start with ambient occlusion, but this time we're gonna use a scour parameter. So I'm gonna create a function input, and this one will be a scour, and I'm gonna name this ambient occlusion. And I'm gonna use a function that is already created in Unreal Engine, which is called 3-point levels. I'm gonna right click 3-point levels. This is for image adjustment, and this image adjustment control the values that we want: black, mid values, white values. So those are the 3 values that you want to control. As I've explained here, we need to control the black, the white, and the mid values. So perfect, we already have a function over here, and we need to create some logic in order to control the black, the middle, and the white. So let's connect the result here at the output, because we're gonna have this as a result. And let's start creating our first scour parameters. I'm gonna connect the ambient occlusion scour to the texture. Here the texture requires a scour parameter, not vector tree. So keep that in mind. S means scour. So I'm gonna queue and align them. The next one that I want to create is I'm gonna copy and paste 2 times those. And I'm gonna name this AO black. And then I'm gonna name the second one AO black intensity. All right, I'm gonna align them and move them like that. AO stands for ambient occlusion, and here we're gonna control the black values. I'm gonna multiply and connect the multiply nodes. So we're multiplying the black value with the black intensity. Then what we need to do next, let me just move this like that. What we need to do next is we need to have a power option to control the black power. So I'm gonna select the black intensity, copy and paste it, and I'm gonna name it black power. All right, and I'm gonna use a power node. Select it like that, connect the multiply to the base, and I'm gonna connect my black power to the power settings here. So what we have is ambient occlusion, the black values. We have black values intensity, and we are multiplying it. Then we have a power node, and we are tweaking the power node by using this scour parameter, which is responsible for our AO blacks. And then let's say we want to invert only the black channel. What we do is static switch parameter, this one, move it like that. And let's say in any case, for example, you want to invert AO blacks. So in this texture, let's say we want to invert this black to be the opposite, to be white. So we have this option through a static switch parameter. For any artistic reason that you want to do, we've included that in the shader. We are creating this shader to be as flexible as possible, not to do any work outside of Unreal Engine, and to have all the tools inside the material itself. So how to do this? Pretty easy. Connect the normal status to false. And what we need to do to invert it, just 1-, and connect the same to 1-, connect it to true. And our logic to control the black values are done. Let's summarize again. We input the black values here as scour parameter, we get the black intensity, and we multiply together. Then after this, we use a black power and a power node to boost it up, or to bring it down. And here to the invert static switch parameter, we are just inverting the result over here, or we are keeping the result. Then we just need to connect to the black values. And now in order to do the same for the middle and the white values, I'll just duplicate this block. So I'm gonna Control C, Control V. And here I'm just gonna start changing names. So from invert black will be invert gray, and I'm just gonna copy gray. And here AO black power, AO gray power. The same will go to the AO black intensity, AO gray intensity. AO black will be AO gray. And we just use the same logic like the previous one, like the black one, and we connect it to the middle values, which will be my gray values. I'm gonna copy this once more. I'm gonna paste it over here, select those, hit Q, and this will be my white values. White. So we are inverting the whites, powering the white, white intensity, and white input. So next, let's fix the sorting priority. So this is 0, this will be 1, this will be 2, this will be 3, this one 4, 5, 6, 7, 8, 9. Then for the static switch parameters, here under group, I'm gonna create a new group called utilities. And I'm gonna set the priority here 0. From the second one, utilities, priority 1. And the third one, utilities, priority 2. So right now I'm just grouping those invert parameters under utility. And finally, we need to connect the white over here to the white and click save. And this is pretty much it about ambient occlusion. Also, as we've created a new group utilities, open the MF normal and select the invert normal. And here under groups, add utilities and set the priority of 0. And then go and save it. And the next Leo fix that we need to do is add utilities also to the roughness. So I'm going to add group utilities and set priority to 0 under the MF roughness. Save it. And we've made the fixes to all our material functions. The next material function that we will going to create is the Specular. So I'm going to search for material function. And I'm going to create this MF Specular. So we can control through a material function our Specular highlights. So I'm going to open it. And we're going to start with a vector tree. So I'm going to search for function input because we're going to input here a vector tree. And I'm going to name this Specular texture. Okay. And from the Specular texture, we're going to mask the red channel. If you go here into a Specular texture, we can see that we have the Specular texture in all of the channels. So I'm just going to mask the red channel over here. And let's go back to Unreal. Let's drag here, component mask. And we're going to manipulate and adjust only the red channel. Now, I want to create invert Specular switch parameter. So I'm going to search for static switch parameter, just like that, and invert Specular. Okay. Then this invert Specular, if it's false, we're going to use the plain texture. And if we want to invert it, 1 minus, and I'm just going to invert the entire texture because maybe we can have something different in the green and blue channel, but otherwise we're going to keep it through the red channel. Now the next step is that we want to control the intensity of the specular just like the other things that we've created so far. So I'm going to copy and paste this one. Scour specular intensity. All right. I'm going to close it, move it like that. And here I'm going to use multiply node again. And I'm going to multiply the result from the inversion. Are we having inverted or not? And then I'm going to connect to B over here. Okay. Now for the next part, we want to control the Fresnel angle. And let me explain to those who don't know what Fresnel is. So for example, if we have this scene over here with this character, and let's say this is a water surface beneath. If our character is watching through a higher angle over here, we're going to see weaker reflection. The more sharp the angle is, the more stronger reflection we're gonna have. And if the character, let's say the point of view of our character is 90 degrees from here, going straight down, we're gonna have 0% for now. So this is another great example. If you observe a table which is, polished and have reflections, if the angle is steep, you're gonna have weaker reflection. The highlight reflections of the table will be weaker. If we go down, squat a little bit, you're gonna have a strong reflections. And this is called the Fresnel effect. You can go ahead and try it out maybe with a water surface or with your, shiny table, and you're gonna see and understand what Fresnel actually is. So in order to simulate Fresnel and to control it, what we need to do is we already have in Unreal Fresnel logic. So I'm gonna search for Fresnel and it is under utility. And here you have the exponent, which is 5, and the base reflect fraction, which is 0.04. And now we need to do some calculations here. So first we're gonna lerp everything over here. So in A, I'm gonna put the output of our specular texture of the invert and the intensity. And next we're gonna add an option to control the Fresnel intensity. So I'm gonna copy and paste my specular intensity, and I'm gonna name this Fresnel intensity. And through here, I'm just gonna multiply, and I'm gonna use the base here with the specular and put it and connect it to my multiply node. And for the intensity of the Fresnel, I'm just gonna revert it because inverting the Fresnel scour will actually boost it up. So I'm gonna do 1 minus. I'm gonna connect it here and connect it to B. Okay, so far so good. And I'm gonna connect the multiply over here to the lerp of the B. And then from the Fresnel, I'm just gonna reverse. So 1 minus. I'm reversing the effect. And I'm using this reverse of the Fresnel node as an alpha. So this will be output the blending between A and B, where B is controlling the Fresnel intensity. And the next thing that we are going to add is, do we need to use Fresnel, or we are just gonna rely on the specular texture? So I'm gonna copy this static switch parameter and I'm gonna name it use Fresnel specular. And now what we need to do is, if we want to use Fresnel specular, we go to true. Otherwise, if we don't use it, we go to false over here. And then the final thing is to connect it to my output node. And this is the basic logic between the specular. Now let's put a group onto the invert specular. Here I'm gonna create a new group, and this group will be named LYR for layer /01/roughness and specular. I'm gonna enter it, because this will hold the definition for my roughness and specular. I'm gonna select the next one, and I'm gonna add it to the same layer. And for the sort priority, this will be 6, and this will be 5. And for the input specular texture, I'm gonna put here 2. I'm gonna put here under specular intensity 3. And for the Fresnel intensity, I'm gonna put here 5. Then I'm gonna save it, and we are ready with our MF specular. All right. So we have created 5 functions so far. The next one will be very interesting. We're gonna create an MF function, which is a triplanar. So right click and search for material. And under material function, call it MF triplanar. But before we start creating the function itself, let me explain what triplanar is in detail so you can get the idea why we are creating this function. In general, when we have 3D models, we rely the texture to be applied on them through UV mapping. UV mapping is like a 2D projection of this 3D object, as you can see over here. If I start moving it, you can see how the texture is moving it. So a triplanar basically is needed in environment and especially in landscape, because when we start scoping a landscape, for example, we start scope this one, you can see how the sides of the texture itself start to stretch. And this is because we rely on UVs. And if you want not to be stretched, you need also to stretch the UVs like that. And this one is rotated, so you need also to rotate this UV. stretch it in this direction and keep the width the same. So this is an operation that you can do in Unreal Engine, but it's very complicated, and that's why we use Triplanar. Here is an example how when you start sculpting, a landscape, it starts stretching out the texture on the sides because it doesn't have information how to, place the texture. And this is how it looks when we use Triplanar. On this side, we have a homogeneous texture which is scaled appropriately. And let me show you the final material. So I just sculpted out here a huge mountain. And as you can see on the side, here we have stretched texture. In general, this texture should look like that. But when we go to the sides, it is stretched because we rely on UVs. And the Triplanar function will discard the reliance on the UVs and will project and map the texture in runtime in Unreal Engine onto the shader. So right now in our shader, if I just turn on the Triplanar, you can see the big difference. Right now, everything is laid out properly and it's styled properly and you don't have any stretching. If I turn it off, you see the stretch appears. All right, so let's get back to Unreal and let's start creating the Triplanar function. The first thing and the first block that we need to use is we need to get the absolute world position. So in order to create this Triplanar projection, we need an absolute world position. And a quick visual note how the projection is working. For example, if I do here an automatic projection, you can see that it starts snapping and creating UVs from all the sides of the 3D geometry. And right now we are just going to do that, but in real time in Unreal Engine. So the first block, right click and search for absolute world position. I'm going to search for world position, and select it. And once we create this block, what we need to change is the shader offset. Right now we include the material shader offset. We just need to exclude it. So select this one. And this is the first step to get the absolute world position. So with this block, we are getting the world position of the object that we are sculpting onto the landscape. The next thing is we need a function input. So I'm going to search for function. And this function input should be a vector tree. And I'm going to name this world position. I'm going to check use preview value as default. And for the preview value, we are going to hook up the world position that we got. So we are feeding the X, Y, and Z, which is the three-dimensional coordinate system, and we are hooking it into the preview section over here. And let's just set the sort priority of this one, which will be 2. So right now we are getting the world position, and we are putting the world position into our vector tree. So the next block is we need another function input which will represent the texture size. So I'm going to right click, I'm going to search for function input. And here in the input name, I'm going to put texture size. Then for the description, I'm going to add a description. So if anybody starts modifying my material, would know why this texture is there. So this texture is the size of the texture in the world space units. Size of the texture in world space units. So for example, let's say my texture size is 64 by 64 by 64 and I have for the preview value 6. And also I use this check use preview value as default. So depending on the size of the texture in world space, you can modify the values over here. And let's put the sort priority here of 1. And the next thing that we need to do is we need to get the absolute value of the texture size. So right click and let's search for ABS. And let's add the ABS node. What this ABS node is getting the absolute value from a texture. And essentially this means it turns negative numbers into positive numbers by dropping the minus sign. So this is what we are doing here. If we have any negative values, we're just gonna drop the negative sign and reverse it. After this node, we need a multiply node. So I'm going to hold M on my keyboard and we're going to connect the absolute value to the multiply node. And right now I'm just going to multiply by -1. Okay. And then we start dividing by absolute world position through the texture size. So I'm going to search for divide. And we're going to divide the vector tree of the absolute world position to the texture size. So right now we're doing a divide calculation. We're getting from the absolute world position and we are dividing the texture size. After that, what we need to do is we need to separate the channels. So as I showed you before, how to separate the channels, we can use mask. So drag here, component mask, and select component mask. So the first channels that we want to extract is the green and the blue channel. I'm going to duplicate this one. And the next extraction will be my red and blue channel. Red and blue channel. And I'm going to duplicate one more time. And the next will be red and green channel. So I'm going to use the red and green channel. In order for us to create this triplanar texturing, we need to create another function input. So I'm going to create another function input, and this will be additional UV. So additional UV. And this will serve me as additional UVs per channel in real time. So what I'm going to do here, this will be a vector 2. So UVs tends to work in vector 2. Why am I selecting vector 2? I select vector 2 because UVs normally works in two-dimensional coordinate system. So this is X and Y. And we want to recreate additional UVs, and that's why we need a two-dimensional coordinate system. And what I'm going to use this one is I'm going to add those additional UVs to each mask channel. So I'm going to right click and search for add function. And I'm going to add the additional UVs per channel. So we start tiling it up. So let me add it over here. I'm going to Control C, Control V, create this one, connect it, Control C, Control V, create this one, connect it. All right. And let's connect the additional UVs to each extraction of the channels. The next thing that we want is a texture object. So we need to hook a texture object over here. So I'm going to right click texture object, and I'm going to use this texture object. So for the texture object, I'm going to choose the default diffuse texture, but I'm going to choose this one, the second one. The first one is RVT. So you don't need the RVT one. So select the default diffuse, and the sample type will be color. Now we need to create another function input which can get the data from this texture object. So I'm going to right click function input, and this function input, from the input type, I'm going to select function input texture 2D. And right now this function can get the 2D texture from the texture object information. And now I will connect the texture object to the input texture here. And for the input additional UVs, what I need to do here is I need to set the sort priority to 3. And this sort priority will be 0. The input name texture object. The next step, as we are creating vector 3, we need to create 3 separate texture samples, and then we need to combine them together. So I'm going to move this over here, the result. And let's create the first texture sample, texture sample, select it. And for the sample source, we're going to select the shared to be wrap. And now what we need to get is we're going to get the UVs, as here we are creating a fake UVs and we are getting the world position. We're creating this texture size, doing the calculations and adding those fake UVs so we can start tiling it up and look good. Let me just arrange this. So getting the UVs over here and connecting it to the first texture sample. And then from the input texture object, the texture that we input onto the landscape that we want, to be working with Triplanar, we're going to connect here to the texture. I'm going to Control C and Control V, and we're going to do the same for the RB and connect the texture over here. I'm going to Control C, Control V, and I'm going to do the same for the mask RG. Let me connect it here to the UVs and connect the texture over here. All right, so far so good. And right now what we need to do is we need to combine them together in order for us to get one result. And combining them together, we're going to use 2 lerp nodes. So I'm going to use lerp, which is linear interpolation. And I'm going to select first the RB, which is the red and blue channel, and extract the RGB over here into A. And then I'm going to select this one, the green and the blue channel, and we're going to select it to B. I'm gonna duplicate this once more, the warp, and I'm gonna connect it here to the output. And this one will go into A, and the last one, that last, will go to B. And right now what we are missing is how this will start blending. And see here how the Triplanar is working. If you can see here on the shades, how it starts, creating this stylable texture from all the angles. And we don't have any kind of stretching onto the sphere over here. See how the lines are connected? And the final thing that we are missing here is the blending between the repetitiveness of this texture. But right now it looks good, but we still need to start blending the sides to the top. So imagine when we start projecting here from the left, from the top, from the bottom, and what you're gonna project is the texture onto each side of this pillar. But the idea is that when you project here onto this surface, for example, if it's smooth like that, it will need to blend in order to look good in the game. So right now we are missing just the blending. And the blending will happen here in the lerp section into the alpha, because here the lerp says how you can blend A with the B and how we blend this lerp with this third one, which connects to the R and G. And in order for us to blend pretty good, we will need to use the vertex normals. So right click and search for vertex normals, and select the vertex normals VS under coordinates. Right now we have vertex normals and they work in 3 vectors. So they work on X, Y, and Z. And what we need to do is we need to input it as a normal. So let me just put it like that. And we need to create a function input. And this function input should be vector3 because we are exporting X, Y, and Z. And this should be exported as a normal. All right. And the priority I'm going to set up to 4. And let's use the preview values as default. All right. So let's connect the vertex normal to the input normal. And as you can see here in the preview, we already start exporting the vertex normal information into our function input. And right now from the normal, we need to mask the red and the blue channel. So let me just go here, component mask. And here we're going to extract the red. And the next channel, I'm just going to copy paste it and we're going to extract the blue channel. Let me connect it over here. And right now for the vertex normal VS, we're just exporting from the information here only the red and the blue channel. And just like here, where we do an absolute because we don't want to have negative values, we're going to do absolute over here too. So let me do absolute. And same for the blue channel. All right. And the next thing that I want to do is I want to filter it to a cheap contrast because I want to boost a little bit more the contrast. This will add additional polishing to the blending. So search for cheap contrast. This is under image adjustment. And just for the input, connect the absolute value. And again, duplicate this one, Control C, Control V, and just connect it to the input values over here. And as we're exporting here to the alpha, we will only need one channel. And let me just move it like that. And for the bolt mask, we're just gonna export the red channel. So I'm gonna select this one, which is the red channel. I'm gonna put it over here. And I'm gonna export from this one only the red channel also. So I'm gonna align this. And I'm gonna start connecting. So this red channel, I'm gonna connect to my first lerp. So connect it here over to the alpha. And for my second one, I'm gonna connect it here to the second lerp and the second alpha. Let's move this a little bit like that, so it can be way more cleaner to read, something like this. And if we observe right now into the material preview, let me just scale it up a little bit. You can see how the blending starts to execute way better. And if you see material from far, you can see that all the blending is working great right now. So this is the final Triplanar function that we're gonna use. And finally, for the output here, I'm just gonna rename the result to XYZ texture, because we're gonna output the XYZ texture and I'm gonna put the sort priority to 1. Let's go ahead, just save this, and we're finished with the material function Triplanar. Right now, we're fixing textures and how they repeat onto the landscape. The next function that we want to create before creating the distance styling is we need to create a cell bombing. So right click, search for the material function. And under material function, I'm gonna name this MF cell bombing. And before we start, connecting nodes, I need to explain what cell bombing is. So in general, when we start repeating a texture onto landscape, we have a result like this one. And it is super obvious that we are repeating the texture. If you follow this line, and if you see here, those rocks, and it's pretty obvious that it's repeating. But when we do a cell bombing, we get a result like this. And it looks like it's not repeating itself, but it is repeating itself. Because we are projecting this texture. For example, in this particular case, we are just tiling the texture, let's say 100 times. And here we are tiling the texture 100 times, but each texture square, we are just rotating it and placing it onto a different rotation angle and bombing the original texture. Here is a good example of how the bombing looks like without a texture. You can see that on the base, we have the texture itself laid out, and on top of it, we are just bombing with the same texture and creating a patches onto it. And this is called cell bombing, and it's fixing the default tiling. And here you can see super obvious that it is repeating itself. And on the left, you can see the result with self-bombing. You'll never say that this texture is repeating itself. So let's go ahead and create the material function. So in order to create a cell bombing material function, it is super easy, nothing complex in it. The first thing that we need to do is we need to get the absolute world position on X and Y. So I'm going to search for world position. And under coordinates, I'm going to use world position. Now this time, here in the shader offset, we need to select including material shader offset. As I'm going to set, we're going to bump our current texture. What we need to do to bump it is we need to get X and Y. Because we are not working in 3D space, we are just bumping it from the top and from the side. So what I need to do is I'm going to add a divide node. And I'm going to connect it over here. And I'm going to create another node, which is a function input scour, where we can control the scale of how we're going to bomb it. So you can create, bigger patches or smaller patches, depending on how it will work and how do you want to look the bombing onto your texture. So let me create a function input. And this function input, I'm going to select scour parameter and I'm going to name it scale. For the sorting priority, I'm going to put 0, left it like that, and connect it to B. So we're dividing the scale through the X and Y absolute world position. The next one is we need a texture sample. I'm going to right click, texture sample. And in this texture sample, I'm going to connect the divide into the UVs. I'm going to go to my placeholders and I'm going to select my texture cell bombing 2K. I'm going to place it over here. For the cover, you're going to use linear cover. And this texture is just a sample of different kinds, of shapes and forms. This can easily be created in Photoshop. There's a lot of textures in this kind. If you just search for cell bombing on Google and just download one, or just go into the description of this video and just download my textures. So right now, this is working with our cell bombing texture. And the next thing that we need to do is we need to output the alpha and the green channel in order for us to work. So here in this result, I'm going to output and name this alpha. So this will output the alpha from the texture and connect it like that. And I'm going to use one more output. So I'm going to Control C, Control V, and this output will be my additional UVs. So from this texture sample, we're going to get the green channel and we're going to create additional UVs in order for us to work with them and bomb the original texture. And then the sort priority for this one, for the additional UVs, will stay as 0. And for the output alpha, I'm just going to put 1. And finally, if you want to, have a preview of it, just here in the preview value, put 12,000. and hit save. And right now you can see into the output alpha how it will work the cell bombing. Because right now we just give it a value for the preview. So we're ready with the cell bombing material function. Now for the material function, what we need to create is distance fading. Right now, when our camera is closer to this pillar over here that I sculpted, you can see the texture like that. But if I start moving out, you can see that we are scanning it a little bit more. And the idea of this is when you're here on the ground and you see, this rock, you can have bigger detail, more defined detail, and you can see that this rock is like having deformation, having details onto it. And if it was, too repetitive, it will wash out the details. And when we get closer, like that, you can see that it starts gradually fading out and getting the details. So when you're close to the pillar, you have all the details, and where you're getting far from the pillar, you still have a lot of details to see from the distance. So this is what we're gonna create right now, and we're gonna create the material function distance fade. So let's start, right click, go to the material, and select material function, mf distance fade. And let's open the function. And first thing that we need to get is we need to get an absolute world position. So search for world position. And from here, we need to get X and Y because we want our texture to blend all in the 3 dimensions. So I'm just gonna create a distance. And under utility, I'm gonna select distance. And the distance node expression computes the distance between 2 points, colors, positions, vectors, and output the result. So we want to get the distance between X and Y and Z from our absolute world position, and we're gonna compute the distance between the world position and our camera position. As you already saw, when we move with the camera, we're just changing the fade distance blending. So I'm gonna right click and search for camera position, and I'm gonna select the coordinates camera position VS. And now we're gonna connect our camera position to B in order for us to calculate the distance between the absolute world position and the camera position. We need from this distance to subtract. So I'm gonna subtract and connect the subtraction to A. And now in the subtract, we need to create a scalar parameter, not a function input. So right click, scalar parameter, and I'm gonna name this end fade distance. This parameter will define the end fade distance. And here in the default value, I'm gonna put 4500. Under group, I'm gonna name this distance blending. And we're gonna group all those values under the distance blending group. And for the priority, I'm gonna put 0. Let's also add a description what this will do. This will define where the blend fading ends. So define where the blend fading ends. So through this parameter, we can control where the fade and distance blending ends. So I'm gonna connect it to B over here. And let's create one more of these. I'm gonna Control C, Control V. And this one will be the fade length. So between what range it will be fading the length. So I'm gonna put fade length. And for the default value, I'm gonna put 1500. It will be also under distance blending and the sort priority will be 1. And let's give it a description. So if anyone is touching this material, he will know what this does. So I'm gonna name it like that, defining what is the length of the blending fade. Defining what is the length of the blending fade. And I'm just gonna put a description that lower values means sharper blending. This is like, for example, telling how soft and how sharp it will blend. I'm just gonna show you in seconds. So let me put here lower values means sharper blending. All right. So for the fade length, right now I've put 0 and you can see that it is super sharp blending. All right. So this is how you can control it. But let's put like 2000. See how the blending is more smooth, 1000, start blending. And if I put 0, super sharp. Depending on what you need, you can test out here in real time. 200, 300, you can see, start smoothing out. But this is too visible, that's why I'm using like higher values, because it's way more not visible. And keep in mind that right now I don't have like distance fog in order for this to cover it up a little bit more. But this is what fade length does. And the ending fade distance, if I put 3000, you can see how it starts to fade out here at this distance. So this is my end distance. If I put 2000, you can see that my end distance is way more closer to the camera. If I start moving, you can see here into the pebbles how it starts fading. If I put 1000, it will be even closer to my camera. So this is what end fade distance does. So if I put like 5000, it will fade way more in the distance. So let's connect the fade distance. We need to connect it to a divide node because we are dividing the end fade distance with the subtract, and we are dividing the subtract. So I'm gonna search for divide, and I'm gonna have the end distance, and we are subtracting and dividing with the fade length. And on top of that, we're gonna use a power node in order for us to blend even more and smooth the blending. So I'm gonna use a power node over here and connect this divide to the base. And for the exposure, we're gonna copy this fade length, paste it over here, and rename this as blending distance. And I'm gonna put a default value of 1. Under distance blending group, sort priority number 2. And here I'm gonna put as a description, use lower values for smooth blending. Use lower values for smooth blending. And I'm gonna connect this to the exposure. So now when we start tweaking the blending distance, this is by default and it is 1. You can see how it starts blending with this pillar. But if you put 5, for example, you can see that the blending starts way more smoother. So we are fading the edges of the blending. So let me do fade length of 1. You can see how this is blending. So right now, if we are using for the blending distance 0, just observe here the hard edge of the blending between the zones. All right. So right now you can see that the blending is super hard between the start position, the middle, and the end position. But by using this blend distance, if we put 3, you can see that it starts blending softer with everything. And if we put 15, it will start even a little bit more softer. So just tweak those values between, let's say, 1, 2, 4, 5, something like this works great. Let me just try with 2. Just to soften out the blending while you're moving. Let me just see on this pillar. So let's finish up the blending distance, and this is what it's supposed to be doing. So we've created a parameter, we've given a default value of 1, sort priority 2, distance blending group, we've put the description, and we've connected it to a power. The next thing that I want to do is I need to saturate everything to give it a little bit more contrast of the blending. And then the next step is to use also the RVT function, because we need to blend with RVT textures. So I'm going to search for runtime virtual texture replace. And here under virtual texture, I'm going to choose this runtime virtual texture replace. So for the default value, I'm going to replace with everything that we've created here for our distance fade. And for the virtual texture output, I'm just going to put a value of 0. So hold 1 on your keyboard, left click, and you're going to have this value of 0 and connect it over here. And the next final step is to connect it to the output result and save the function. The distance fade material function is ready. The next function that we want to create is we want to have variation into our distance. So here under this tab, distance variation, what you can do is we're going to create a mask scour. And right now I've set up 10,000. But the idea is that when you can see your landscape from far, we have a color intensity and we can tweak the color intensity. Let me show you 0.8. And we add this variation into the landscape from far. And the idea of this is to break up the repetitiveness in the details. So if I put 0.4, you can see that we have here some dark spots. And when we go here, it starts blending. But that's too much. If I put 0.2, we still have the dark spots, but it's not so visible. And we're breaking up the repetitiveness in the texture. The other thing that we're going to add is normal intensity. So what we can do with normal intensity is we can boost up and hook up a normal texture. So if I put 3, you can see how we have normal here, faking some relief and some details onto our far background. And this is very nice because this is adding an extra layer of depth to our landscape, and having this extra layer of depth, you have like a lot of details far ahead. So if I put 1, let's put 0.2, you can see that it's a little bit softening it up. And also we're going to include a normal variation texture, so you can hook up here any texture that you want to simulate over the distance. And through the mask scale, you can control the scale of the repetitiveness over here. So if I put 10,000, for example, like that, it will be way more natural. But if you want something like this, you can do it. It will be way more, saturated. But the idea of this is to break up everything in your landscape and faking those nice details from far. All right, so let's get started and create this material function. So let's create a new material function. So search for material and go to material function, nf distance variation, and let's open it. This will be a little bit more complex function, but stay with me. I'm going to explain all the steps. And the first thing that we need to do is we need to get material attributes, and we need to get the base color and the normal, because we're going to adjust the base color and the normal. How we can do that? We're going to create a function input, expand here, and under input type, we're going to search for material attributes. And here from this input, we can get the attributes from a current material. So right here, I'm going to drag and I'm going to get material attributes. So we are just extracting information from the material. And here I'm going to say what information I want to extract from this material. So I'm going to add 1, and I want to extract the base color. And the next one that we need to extract is the normal, as we are just modifying the base color and the normal. And here under material attributes, I'm not going to connect right now anything, but from the base color, I'm going to search for reroute, and I'm going to add named reroute decoration node. And I'm going to name this base color, because we're going to use the reroute not to have a spaghetti over here. I'm just going to copy, and I'm just going to copy and paste this one and rename it to normal. So this will be extract the information from the material for the base color and for the normal. And after that, we're going to set the material attribute, set material attributes. And here, this is for the final node. After we make some of the calculations, create the, the distance variation, we're going to assemble again the material. And we're going to assemble the base color and the normal. So base color and normal. Here, by setting the material attribute, here we are deconstructing it, the base color and the normal. We're going to make some logic over here, and we start assembling it together again, and we connect to the output result. So imagine it just like something like a Lego, where you deconstruct and then construct it. Now, let's start creating some other blocks. First, we need the absolute world position. So world position. We use that node a lot, but it's one of the most useful nodes in Unreal Engine for getting information from the world. And now we're going to get the X and Y, and we're going to divide. And let me connect X and Y to the divide node. And we're going to divide with the variation mask scale. So as I showed you, we want to have a control over the scale. So I'm going to create a scalar parameter under scalar parameters, and I'm going to name this variation mask scale. Mask scale. So through this parameter, we're going to control the variation. And for the default value, I'm going to put 10,000. And for the group, I'm creating new group only for this material function. So this will be called distance variation. And the priority for this one will be 0. This one will be the first node to pop out. I'm just going to connect it to divide node over here. And from the exit here, I'm going to search for reroute. And I'm going to name this as UV. Because this one will act as a UV. When we start scaling up, we're going to scale up like modifying the UVs onto our landscape just to get this mask scale and variation. So the next step is to use the distance fade material function that we've created. So let me just drag the distance fade over here. And this distance fade block, we already create the function and we can use the distance fade, logic. And this is why we are creating different material functions, because they can be reused in other functions. And everything connected later on will be outputted into one giant material. So here we're going to use another reroute node, and I'm going to name this distance fade. And for those, I'm just going to color code them with yellow. So I'm just going to select this one because I want to keep those nodes with the same colors, as those are output nodes. All right, the next step is we need to create a variation mask, which variation mask is a 2D texture, so function input. And here I'm gonna select a 2D texture. So this can be our variation texture. Let's set the sort priority to 1. And now we need to create a texture sampler just to hold up the texture 2D that we've created through the function input. So texture sample. And again, for this texture sample, we're gonna wrap because it is a repetitive thing. And under the texture here, we're gonna search for our noise mask that we've created. So noise mask, and it will be as a mask. Now, let's connect the texture over here. And as we've created here the UVs, we need to hook them up here for UVs and connect them here. And the idea is that when we connect the UVs over here to the texture sampler, any change here in the mask's color that we make, it will also apply to the texture sample. So we can control the base color repetitiveness with the texture mask scale and also the normal variation. Okay, so the next step is to get the base color. So here I'm gonna get the base color from the reroute that we've created from here. And this base color I'm gonna multiply. And I'm gonna multiply the base color with the red channel of the texture variation. All right. Then we're gonna have a distance fade. So we're gonna hook up the distance fade in order for us to create the fading of the distance. So distance fade, reroute. Right now we are using the distance fade also into the distance variation, so we can avoid those sharp fading into the distance. And this distance fade I'm gonna multiply over here, and I'm gonna multiply it by color intensity. Because we want to give intense color or less intense color into the variation of the color, as I showed you. So this one will be also a parameter. I'm just copying this one and pasting it over here. And this one will hold the color intensity. And by default, it will be 1. It will be under distance variation, and this will be 1, as this is my first variation mask's color parameter. Just connecting it over here. So through this color intensity and distance fade, we're gonna fade pretty good the input mask that we are putting over here, and we can boost up the color intensity as I showed you previously. And what we want over here is to lerp, to connect everything together. So I'm gonna right click, warp, linear interpolated, and this modification of the mask variation through the red channel, I'm gonna connect it here onto the B. So we are mixing this one, and we want to mix it with the base color, with the exact base color, and connect it to A. So right now what we are getting is we are getting the base color, connecting it to this lerp, and we are mixing it with the input variation mask, the texture sample we are getting only from the red channel, and mixing it with that. And also we are controlling the UV's repetitiveness with the variation mask scale. And here in the lerp node, not to have, sharp blending, we are using the distance fade, and we also boost with color intensity. So let me connect it to alpha, and this is done. So this is pretty much, responsible for our base color. So let me connect to the base color. And for the material attributes, what we need is we need to connect the other material attributes over here and just align it like that. So let me explain it once more, because that was not so easy. Here we are getting the material attributes. From here we are exporting the base color and the normal. It's like deconstructing a material. Here we are constructing the material again. What we are doing here is we are getting the absolute world position, and we are using the mask scale. And as I showed you from here, when we use the material mask scale, let me just boost up the color intensity. You can see how this mask is scaling, all right? So this is what we are doing with the mask scale over there. So let me put 15,000. All right, so we are using this mask scale, and we are hooking up the mask scale into the variation mask. And for the variation mask, we hard-coded this texture. So this noise texture is used to create this, kind of shades over here. You can, expose the texture or just change the texture, whatever you want over there. And we are getting from this texture only the R channel. So from this texture, we are getting only the R channel. So right now we are getting this, shades. But if you want to get the green channel, you can switch, or the blue channel. You can pretty easily switch. If, for example, if we connect the green channel over here and save it, you'll get the information from the green channel, and this is how you're going to create the shades. And then we're going to use the distance fade in order for us to blend, and the color intensity, which is, I already show you what the color intensity is doing. Create the intensity into the texture itself to break up the far silhouette of the landscape. And then we combine everything together. We combine the base color, we connect the modification of the base color that we are doing through the texture and to the UV mask. And we're hooking up here the color intensity and the distance fade to the alpha, so they can blend seamlessly together. Then we reconstruct the set material attribute under base color, and we output the result. Now for the normal map, we're going to do almost the same. So I'm going to copy this texture sample. I'm going to put it over here, and everything will be exactly the same, because we want to apply the normal map onto the same texture, not to a different one, because we want to have the color controlled and the normal map at the same place. And then I'm going to get the UV reroute. So I'm going to get the UV reroute, and I'm going to connect it to the UVs over here. Then I'm going to duplicate this texture sample. I'm going to right click and convert to parameter. And converting it to parameter will expose the texture, so I can hook up anything to it. So name this as normal variation texture, normal variation texture. And under the group, I'm going to name this as distance variation, as I already using this distance variation. And this will be my last note, as if you want to hook up here a different normal texture to expose there, just for the detailing. And as a placeholder, I'm going to use my water normal texture, and the sample type should be normal. All right, but we also need to apply the UVs over here to this texture. So apply the UVs. So every change here in the mask scale will apply also to the normal textures. And then for the mask texture, I'm going to need to get here and connect to the texture sample. Then the next thing that we need to do is we need to blend angled corrected normals. So I'm going to search for this node, blend angled corrected normals. And we need to get the base normals. The base normals we've set up here from deconstructing the get material. So I'm going to get the normal from here, and I'm going to connect to the base normal. So from this new normal variation texture, we're going to connect the new texture that we've hooked up to the additional normal. So this one will blend together this normal and the new normal with a corrected normals. And after that, of course, we want to lerp everything together, lerp. And how do we lerp it? Just like we did here with the base color. What we need here is we need to expose the normal that we get here from the disassemble and put it under A. The modified normal, of course, will go into the B. And the alpha, which will the blending, we're gonna get from the green channel over here. So connect the green channel to the alpha. All right, so far so good, but we also have one more variable to tweak the distance fade and the normal intensity. As right here, we tweak the color intensity, but we need the same to tweak the normal intensity. So what I'm going to do is I'm gonna copy this one. I'm gonna paste it over here just to modify it pretty fast. And I'm gonna select this color intensity, paste it here, and name this color intensity as normal intensity. And here I'm gonna also use the distance variation group. And for normal intensity, I'm gonna put set priority to 2. Then I'm gonna connect to multiply. And then I'm gonna lerp again. So search for lerp. And this lerp, I'm gonna use the modified normal maps here that we've created and lerp together and connect it to B. And here, because we are tweaking the intensity of the normal map, I'm gonna tweak here the alpha. This will control the alpha of it. And for A, I'm just gonna use the normal reroute. So under name reroutes, choose the normal and connect it to A. So this entire block is modifying the normals and adding an additional normal texture that you can place on in order for you to break up this distance variation. And then the lerp node should go to the normal and we reconstruct the material itself. Now this was a little bit more complex, but I hope it's clear enough with all the explanation that I did. And now we just need to save it. The next material function that we're going to create is the near distance tiling and the far distance tiling. So what this function will do is right now we have parameters into this layer and we have tiling in each layer that we are composing here onto the landscape. So the near size right now is 2000, but if I put 20, you can see how we are changing the tiling. And this is controlled with a distance variation. And for example, our far size, the tiling of our far texture is 1. But if I put 2000, you can see how it changes here at the background. So let's reverse this. I'm going to put 2000 here. You can see that we are changing the tiling, maybe 1000. And this is per texture. So each texture that you have here onto your landscape, you can control through these tiling settings. And if I put for my far 1, just to have better visuals, and if I start moving, you can see that we are changing the tiling. If I put here 20, let's say 2000, you can see how we are changing it again. So you can control how the tiling affects at far and at near at the camera. So if I go and zoom in, we get the near tiling. Right now we are getting the far size tiling. The idea of this is just to tile your texture from far and from near, how you want them to be, and create this nice repetitive effect at the foreground and at the background in order for you to get this realism into your landscape. So let's get started and create the next material function, which will control the tiling. All right, so right click and let's create a material function. And I'm gonna name this material function MF distance based tiling. Let's open it. And this one will be a little more complex. And first we will start with a texture object that will hold our albedo texture. So right click, texture object. And in this texture object, we're gonna use our albedo MoCap, this one, and it will stay as a color. So this texture object will hold our albedo, and that's why we've created those placeholders just to put here a visual information of the texture. The next thing is to create a function input. And this function input, I'm gonna name texture slot because we're gonna connect this texture to the function input so we can change and hook up any textures that we want. So I'm gonna name this texture slot. And this one should be a 2D texture. This one, texture 2D. And I'm going to select use preview value as default. And I'm going to connect those two. Then the next thing that we want to create is the near tiling and the far tiling as a scour parameter. So we can control through a scour parameter, the near and the far tiling. So I'm just going to copy this function input and I'm going to change it input type to scour. And this one will be my near tiling. All right. I'm going to set the sort priority of 2. I'm just going to close this one. And then I'm going to duplicate it, Control C, Control V. And what we're going to create is our far tiling. And the sort priority will be 3 over here. Now, the next step, what we want to do is we want to divide from the far tiling through the near tiling and then multiply it to a value in order for us to get that, effect and blending. So I'm going to divide here and I'm going to divide my near tiling will go into the B section and my far tiling will go into A section. So we are dividing from far tiling the near tiling. Then I'm just going to multiply this one, connect it over here. And I'm going to give a base value of 4000. So holding 1 on my keyboard and left clicking, I'm creating a constant material expression. And this value will be 4000. I'm going to hook it up here at the multiply. So we are multiplying by this value. And the next thing that we need to add here is our cell bombing and our triplanar texture. So I'm just going to minimize this. And the functions of cell bombing I'm adding here. And the next one of the triplanar we're adding here. So the logic that we've created with the cell bombing not to have repetitiveness in our tiling, we're going to use here. And also to fix the tiling when we add height to our landscape, we're going to fix through the triplanar. That's why we're creating those as material functions, because later on in the other material functions, those will be very useful. So the value of 4000 will connect to our cell bombing. And then let's work with our triplanar. And for the triplanar, our texture object over here, I'm going to reroute and I'm going to name this r texture slot. And we're going to use this reroute to connect to our triplanar over here, not to create some spaghetti. So let's find the reroute and let's connect it to our texture object over here. Then I'm just going to do a reroute from the near tiling. Add name reroute near tiling. And I'm going to do the same from the far tiling. So I'm just going to copy this one. Control C, Control V, just to have the same colors. And I'm going to name this reroute far tiling. All right. Connect it over here. And right now we have those reroutes. For the first texture triplanar, we're going to use the near tiling. So name reroute near tiling, connect to my texture size, because we're controlling the texture size through the near tiling for this first block of triplanar. Then I'm going to add another triplanar over here. So drag and drop it. And I'm going to reroute and connect again the texture slot and right click and connect the near tiling to the texture size, texture slot to the texture object. Now the connection from the cell bombing here at the near tiling multiply, we want to connect to the additional UVs, the cell bombing that we've made, just to fix the repetitiveness in the tiling. So connect the additional UVs to the additional UVs of the second triplanar. And then what we will do is we're gonna lerp those two. So right click, lerp, linear interpolation, and we're gonna mix them. So I'm hooking up the first triplanar, the second one with the fix of the cell bombing, and from the alpha I'm gonna hook up the alpha from the cell bombing over here. So the cell bombing alpha goes here, and the first go in A and the second go in B. Keep in mind to always fix and clean your path connections, because it will look way better and way readable. So let me fix this one too, to have clean path connections. The next step, what we need to do is we need to add the world absolute positions. Right click, world position, and we're going to use the world position. And this time for the shader offset, we're going to exclude the material shader offset. And then what we need to do is we need to divide the near tiling through the X and Y of the world position. So divide, and for A, I'm gonna hook up X and Y. And for the B, we're dividing through the near tiling, and I'm gonna use the reroute. So near tiling goes into my B. Then the next step is to create two texture samples. So right click, texture sample. And we need to change the sample source to wrap and leave this as color and none. For the first one, we're gonna connect the divide to the UVs. And then for the texture, we're gonna connect the texture slot. So here, the reroute of texture slot connected over here. And I'm gonna duplicate this texture sample one more time, Control C, Control V, put it underneath. It will have the same settings, sample source to wrap, automatically view the MIP bias, and leave the sample type to color. Then for the texture, again, I'm gonna use the reroute, which is our texture slot. And for the UVs, we're just gonna add up the cell bombing and the divide. So right click, add. And we are adding the cell bombing fixing. So from the cell bombing here, we're gonna connect it to B. And our divide, we're gonna connect it to A. And I'm just gonna clean up the connection so it's way more visible like that. Let me just do one connection over here. Like that, and move all the blocks a little bit forward so it's way more readable like that. And let me just put this connection like this. And right now it's way more readable. And I'm gonna connect the add node to the UVs. So we've created two textures. The first one is using the near tiling and dividing from the world position with the near tiling and just feeding this texture sampler. And then we are adding also the cell bombing in order for us to fix the tiling and doesn't have this repetitiveness when you look at the landscape. And those two will also go into a lerp. So I'm just gonna move this lerp over here. And right now, a new lerp, linear interpolation. We're gonna connect the first one from the RGB to A, the second one from the RGB to B. Just gonna align to the first one, and let's align it to the other lerp. And we're using again the cell bombing in order for us to control the alpha. So I'm gonna connect the alpha here. And right now everything looks way more cleaner when you connect like that. Okay, so the next step is either we're gonna use the Triplanar or not. So I'm gonna right click and I'm gonna create a static switch parameter. This one, static switch parameter. And this static switch parameter, I'm gonna name use Triplanar. And I'm gonna put in brackets that this operation is expensive. Also for the group, I'm gonna add it under utilities. And right now, if we follow the logic over here, the first lerp has the Triplanar over here working with the texture slot, the near tiling over here. And we also use the cell bombing. So here we have the cell bombing working and the Triplanar connected together with the texture slot and the near tiling. We still didn't work with the far tiling. So right now we're working only on the near tiling. So we have active cell bombing, we have active Triplanar working with our texture slot and working with our near tiling over here. So connect this to true. If this boolean is true, we're gonna use the Triplanar. If it's not, we're just gonna use the texture sampler. And if it's not, we're just gonna use the default texture sampler and we are not going to have the Triplanar fixes. So connect it over here. And this gives you freedom if you want to use it or if it's not needed for your game. Keep in mind that Triplanar is expensive because you are making fixes in real time. And after that, we're gonna lerp, right click linear interpolation, and this one will go into my A, all right? And everything from here will go into the final result. Connected the lerp to the output result. All right, so right now we've created all the logic that we need for the near tiling. Right now, the next step is to work with the far tiling and connect it to the lerp, and also define the alpha to the lerp. Let's pretty quickly define the alpha first. So I'm going to create a function input, And this function input will be named blend mask. Blend mask. This blend mask will be a vector tree. I'm gonna use the preview value as default, and I'm setting the sort priority to 4. I'm gonna connect it to my alpha. And through this variable, we're gonna control how the near and the far tiling will blend together through the alpha and the lerp node. Now for the far tiling, we're gonna separate two ways, the triplanar and the texture sampler, and we're gonna have the same triplanar boolean. So when you enable this boolean to be true, it will work for the near tiling and for the far tiling. So let's start creating it. First, I will need to drop 2 triplanars over here, and let's start working with the triplanars. So in the first triplanar, we are going to need the texture slot, and we're going to need the far tiling this time. And the far tiling goes to the texture size and the texture slot to the texture object 2D. We will do the same for the second one, far tiling and texture slot. Texture slot goes here. The far tiling goes here into the texture size. And then for the second one, we're gonna do the same. We're gonna use the cell bombing. And let me drop the cell bombing here. Cell bombing. So this cell bombing right here, I'm gonna connect it from my multiply because we are dividing here the far tiling. We are multiplying it through this value, and I'm gonna connect it over here to the cell bombing. And we're multiplying this through this value because we want to have the far tiling to look a little bit different. And then we're gonna connect the additional UVs to the second triplanar. And I'm just gonna fix the connections to look way better. And again, from the previous one, we lerped them together. So we're gonna do here the same lerp. And we're gonna connect the first triplanar to A, the second to B. Move it like that. And the alpha will come from the cell bombing. So I'm connecting the alpha over here. And I'm just gonna fix the connection, not to overlap. The next one is we need to create the same here, world position divide. I'm just gonna copy and paste those here and align them together. And here for the B, rather than getting the near tiling, we're gonna get the far tiling. So far tiling, connect it here to the B. And we're gonna do the same as those texture samples. So I'm just gonna copy and paste those two here, align them under the triplanar. And those two will have the same settings: wrapped, automatically view the MIP bias, and sample type color. They're just the same. And now for the texture, we're gonna connect the texture slot. So connect it over here, and here again, texture slot. And after we've connected the texture slot, we need to connect the UVs. The first texture sample will hold the UVs from the divide. And the second one will use an add, and it will use the add from the divide and from the cell bombing, just like here in the near tiling. So I'm gonna copy and paste the add. And I'm gonna connect the add here at the UVs. And for B, I'm gonna get the additional UVs over here from the cell bombing. And for A, I'm just gonna use the divide. And after we've connected the cell bombing to B and the divide to A, we've connected the texture slot here. And what we need to do is the same as here. We will need to lerp those two and use the cell bombing again. So right click, lerp, linear interpolation. Connect the first one to A, the RGB, connect the second one to B. And the alpha will come from the alpha of the cell bombing. Here I have a little connection, so I'm just gonna do it like that. And it's way more cleaner. Now we have those two lerps, the one for the triplanar and the one for not using triplanar. And what we need is like that, use the triplanar as a switch parameter. So I'm just gonna copy this switch parameter, paste it over here, because it will be exactly the same. And I'm gonna connect the first one. If use triplanar, we're gonna use the triplanar, and if doesn't, If it's false, we are not going to use the Triplanar. And now this should go into B, like that. And let me just fix this like that and just clean a little bit the connections because they're way too curvy. Let's make this one like that and move the input blend mask like that. Now we have clean connections. This is always a must, guys. You always must, have clean connections, have readability in it, and don't make a spaghetti connections. This is one of the golden rules when you're creating material functions. All right, so we've created this complex distance-based tiling, and right now the tiling will work at a distance. So let's save this and move to the next function. The material function texture object represents the slots here that we're gonna plug all the textures. So per each layer, we're gonna have albedo, normal, ORM, height. We also gonna have an option to use an ORD. And if we enable the ORD, we're just gonna use those three textures where ORD stands for occlusion, roughness, and displacement. But if we want to use the ORM workflow, which is the occlusion, roughness, and metallic, you just need to disable the ORD. So right now we choose to use ORM plus Heightmap. So we also have the option not to use ORM. So if I disable this, I have separate channels for ambient occlusion and roughness if you want to have separate textures for those, but usually we combine those three textures in one, which is occlusion, roughness, and metallic. But for any reason, if you want to use ambient occlusion, roughness, and height map, you have the ability to use separate ambient occlusion and roughness. And if you turn on the ORM plus height, the ambient occlusion and roughness will combine into ORM texture, and we also have the ability to use metallic. So let's start creating this material function texture object. So let's continue with the next material function, which will be our texture object. This material function will help us work with the distance-based tiling into all our textures, into the albedo, normal, ORD, specular, etc. And this will take in consideration the distance-based tiling. So let's create this function pretty quickly. Right-click, and we search for material function. And name this material function MF, and it will be texture object. Let's double click on it. And the first thing that we need to create is we need to create our variable nodes like the near tiling, far tiling, and blend mask, and the UVs, and reroute them so we can use them per each texture for normal, for albedo, specular, etc. So right click, function input, and this function input should be vector2. And for the input name, I'm gonna put UVs. Set priority will be 0, and let's reroute this. So reroute, again, named reroute declaration node, and I'm gonna name this RR UVs. So right now we're rerouting the first thing, which will be our control over the UVs. Then I'm gonna copy and paste this one and make this as a scour parameter. And this scour will control our near tiling. Near tiling. I'm just gonna close this one, and I'm gonna reroute, and I'm gonna name this RR near tiling. And I'm just gonna copy everything here, and this will be for our far tiling. So far tiling, and make the reroute RR far tiling. And I'm gonna do one more copy, but this time this will be a vector3 because we're gonna control the blend mask, how the near and the far tiling are blending together. So select the fourth one, and we're gonna choose a vector3. Sort priority will be 1 this time, and this will be my blend mask. We need to rename the reroute blend mask. The next step is to select everything, press C on your keyboard, and let's name this as variable nodes rerouted. And select show bubble when zoomed. Now let's start controlling the first thing, which will be our albedo. So I'm gonna go and select my result and name this as albedo. And here what we need to drag is the function that we've created, distance-based tiling. So we want to take account each texture that we hook up into our material, onto the layer. Let's say this is our sand layer. We need to account for the near and far tiling and the blend mask, the texture itself. So let's create a function input. And this time this will be a texture 2D because we're gonna hook up into this slot a 2D texture. Let me close this, connect it to the texture slot and give it a sort priority of 2. So right now in this block we have the near, far, tiling and blend mask. And if I go inside it, we don't have any UVs over here. Previously I controlled the UVs, but I get rid of them. So right now what we are going to connect here is the near tiling, the far tiling and the blend mask. So right click, far tiling, right click, near tiling, and the blend mask. And let's connect each other to the responsive connection. Far, this is near, move it like that, Shift A. So right now we've made the logic for our albedo texture. We're gonna hook up our albedo texture into the distance-based tiling. We are going to control the near, the far, and the blend mask, and this will affect only the albedo texture, all right? This function is helping us to control the near, far, and blend mask, and we hook up here the texture that you want, for example, sand, snow, mossy ground, etc. The next output that we need to do is for our normal map, so copy and paste this, and here I'm just gonna name this normal and set the priority of 1. I'm gonna select this and comment it and do albedo and select show bubble when zoomed, because I will know that this is for my albedo. Let's select this and also when it's zoomed. This one will be for my normal. So again, I'm just gonna drag and drop a distance base tiling. I'm gonna connect it to my normal. And we're gonna do the same logic as we did here in the albedo. I'm gonna control and paste this one, connect it to my texture slot, name this normal texture. So here we're gonna hook up our normal texture, and then we're gonna connect the near, the far, and the blend mask. So right click, near, far, and blend mask. So I'm just gonna do the same, near, far, and blend mask. And as you can see here, when we use reroutes, everything looks so clean and so readable. That's why I always work like that using reroutes. Name this as normal, show bubble when zoomed. The next one that we want to do is our specular texture. So I'm gonna copy this one, paste it, and let's create our specular texture. And this one will hold 3. And we're gonna do the same logic as in our normal. So drag and drop this here, connect it to my specular. Let's move it below this. Let's align this, move it a little bit down. And I'm gonna copy the normal texture. And I'm gonna paste this like that, connect it to my texture slot. And this one will be my specular texture. Again, it will be texture 2D, but keep in mind that the sort priority right now will be 9 because we're gonna do logic for our RD texture and we're gonna use a lot of function inputs there, and we're gonna use the sort priority there. Right now, what we need to finalize is near tiling, far, and blend mask. So let's connect this, far, near, and blend mask. So blend mask go here, near tiling will go here, and the far tiling will go here. I'm gonna align this, move it like that so we can align with the others. And this one will be specular. Again, show the bubble. So right now we have here the specular, we have here the normal, and we have the albedo, right? And the next one, which will be a little bit more complex, is the ORD texture. So let's go. For the ORD texture, we're gonna do the same, but we're gonna do some switches and append. So I'm gonna minimize here. I'm gonna put 2 of those, all right? And we're gonna start with our ORD texture. So the first thing that we need to do is we need to create a texture. So copy this one, the specular, paste it over here. And I'm gonna use, first one will be ORD texture. And this one will hold a sort priority of 4. It will still be a texture 2D. I'm gonna connect it here at my distance. And we're gonna connect the near, far, and blend again. So near, far, and blend mask. Blending goes here. Near must go here, far go here. All right. And for this one, I'm gonna copy the ORD, paste it. And this one will be my ORM texture. So the difference here is we're gonna create a choice for the developer. Either you're gonna use the ORD texture or you're gonna use the ORM workflow, which stands for Occlusion, Roughness, and Displacement. This stands for Occlusion, Roughness, and Metallic. So depending on your needs, you'll be able to switch between the different workflows. So connect this to the texture slot, and we're gonna copy those, paste those, and just connect them near, far, and blend. All right, so right now what we need to do is we're gonna mask the R and G channel from the ORM texture. So component mask, we are masking the R and G channel. Then I'm gonna use an append, and this one, append vector, and we're gonna append with the height texture later on. After that, I'm gonna use a static switch. This under functions, static switch, not a parameter, just a switch. And in this switch, if we are using the ORM, this will be true. And if it will be false, we're gonna use the other, the ORD, all right? And right now for the value, I'm just gonna create another function input. And this function input, we have also the ability to say that this function input is a Boolean. So this will stands for use ORM. And if this Boolean is true, we're gonna use the ORM workflow. If it's false, we're gonna use the other one, the ORD. And now this will have 11 as sort priority, and we're gonna connect it to the value here. So we can dictate either this is true or false. And after that, I'm just gonna create another switch parameter here and connect here to the false. All right, and we're gonna create one more Boolean, Control+C, Control+V, and connect it here to the value. And this will be use ORD, and the sort priority will be 10, and we're gonna connect the result to true. So what is happening here? Here we've created the ORM texture workflow. We're gonna finish the append and switch in just a second, but just to explain, if this is true, we're gonna use this workflow. And by defining here in the switch, we also here define is ORD true. If ORD is true, we're just gonna straight use the ORD workflow. But if the ORD Boolean is false, we're gonna use the ORM workflow. In our ORM workflow, we need additional textures like the Heightmap, the Roughness, and the Ambient Occlusion. So what we need to do is we're gonna need to add 3 more of those. Those 3 will work for my ambient occlusion, height, and roughness. Let me just arrange them like that, Shift A. And we're gonna create a texture inputs. So I'm just gonna select the ORM, Control+C, Control+V. And this one will be my height texture. So when we choose the ORM workflow, we're going to need to hook up other textures like height, roughness, ambient occlusion. So this will have the sort priority of 6, and it will connect to my texture slot over here. I'm just gonna copy those, paste them, because I'm gonna need the near, far, and blend mask for my height texture. For my height texture, I'm gonna expose only the red channel as we are using only the white and blacks. So I'm gonna use the component mask, and I'm gonna expose just the right channel, which will be the red one. And I'm gonna append here with my ORM. So here we are exporting the red and green channel, and we are appending the red channel with our height map information. Then the next one will be my roughness. So I'm gonna copy this, paste it. This will hold sort priority of 7. It will be again a texture that we're gonna hook up, and this will be my roughness texture. Connect the roughness texture to the texture slot, copy and paste the near, far, and blend, and connect them respectfully. And finally, for my ambient occlusion, I'm just gonna copy the roughness, paste it, and this will be my AO texture, and it will hold a sort priority of 8. I'm gonna connect it to my texture slot, copy the near, far, and blend mask, paste them, connect them again respectfully to the slots. And those two, again, we will mask only the red channel in order for us to append. So copy this mask, connect it over here to the roughness. Let's connect it to the ambient occlusion. Then I'm gonna create a float tree, make float tree. And with this float tree, we are creating a vector tree, which will be representing the R, G, and B channels. So here from my input height, it will go into the Z. My roughness will go into Y. Let me just align this to the roughness. And my ambient occlusion will go to the X. And from there, we're just gonna connect to the foes. All right. So we've recreated the vector, and we are using a lot of textures here in the ORM workflow. We are using the height, the roughness, and the ambient occlusion. We are deconstructing them over here, and we are reconstructing them through the red channel and creating a new vector tree in order for us, when this is false and we're not using the ORM, we are just using the height, the roughness, and the ambient occlusion textures. And finally, this switch should go to the output. So just copy the specular, paste it over here, and name this ORD, and set the priority of 2, and connect the switch to the ORD. I'm just gonna select the entire block, comment it, and name ORD or ORM workflow. All right, I'm gonna show the bubble when zoomed. And for the ORM texture, I just forgot to set the sort priority, so set it to 5. All right, so making this fix for the ORM, we are ready with the texture object. So save everything, and let's continue with the next material function. The next function that we're going to create will control how the layers will blend together based on the height onto the landscape. So right now I have, for example, drawn this grass, and if I start drawing here these rocks, you can see they're going on top of the grass, but here the grass is on top of those small pebbles. And this is what the next material function will do. It will arrange the blending between all the layers that we're gonna paint onto our landscape over here. So let's start and create the height blend attribute. So right click and let's create a new material function, and I'm gonna name this MF height blend attribute. So double click on your MF height blend attribute, and let's create the first input, which will be our input A, and this will be a function input. So right click, create a function input, and this function input we're gonna call A. And here it is a little bit different. From the function input, you can create an input which gets material attributes, and this is what we want. So for A, we're gonna get material attributes. Then I'm gonna Control C, Control V, and name this as a B. Also, the B will have a sort priority of 1. All right, I'm gonna minimize those. As this is a material attribute, we can get attributes from there. So right click, get material attributes. And here I'm just gonna connect this one to the get material attribute. And the material attribute that we want to get in order for us to blend between the layers is the opacity. So I'm gonna hit add element, and I'm gonna search for opacity. Not opacity mask, opacity. And we're getting this for the input A, and I'm gonna Control and C, Control and V. So we're gonna get this for the input B. And the other thing that we need in the opacity is alpha, how they will blend together. So I'm gonna copy this one, paste it, and I'm gonna name this alpha. And this one will be a scour parameter, and we're gonna determine through a scour how they blend together. So let's put here 2. And let's create some logic. Here I want the alpha to be reversed, so I'm gonna use 1 minus, 1 minus. And this will be one case. I'm gonna connect it to 1 minus. And then I'm gonna use a multiply node, and I'm gonna multiply the opacity from the first one, and I'm gonna use the reverse of the alpha over here to the multiply. I'm gonna create one more multiply, and here under this multiply in A, I'm gonna use the opacity, and I'm not going to use the reverse here. I'm gonna use the normal scour parameter. And after that, I'm gonna use a node blend material attributes. So right here, we are blending all the material attributes together, like reconstructing it and outputting it to the result. And in the blending, I'm gonna connect the first material attribute over here, which is from A, and the second one will be connected to B. And the important part is the alpha, how they will blend together. So let's start working on the alpha. The first thing that we need to do is by multiplying the A opacity and the B opacity with reversed and straightforward alpha scalar, we're gonna subtract. So we're gonna subtract the first one will go to B and the second one will go to A. So we are subtracting the normal with the reversed multiplied. Then what works for me as a good blending is I'm gonna divide right here, divide. And here I'm just gonna divide by 0.03. Those are values that I tested out. Then I'm gonna add, and here I'm just gonna add a little bit, which will be around 1. And then I'm gonna divide again. And this time I'm gonna divide by 2. And in order to get it crisp and clear, I'm just gonna saturate right now. Saturate. And all the divisions and the adding and the subtracting will be saturated, and this will go into my alpha. So this little block will control the height blending attribute for the layers, and in the next materials functions, I'm going to show you how this will blend together with the layers and how it will work. Okay, so we are ready with the height blend attribute. Let's save this up and continue with the next material function. The next function that we're going to create is a function that will control how the snow will apply to mountains. And we have world height. This world height controls how high the snow will be in your landscape and into your game. So right now I've calculated that my landscape is way beyond sea level. So right now it's minus 22,000. But if I do something like this, I'm just going to put 2 here, you can see that everything is covered in snow except this little patch. So if you want to control the height of the snow, where it should appear, etc., you just control it through the world height. So if I add here only a little number, 3, you can see how the snow is applying to bigger area. You also can control the height variation scale. So right now it's 2000. If I do 1000, we just change the scale of the height into the variation. So if I do 500, 100, you can see that we have here a very sharp line, all right, which is not good. And that's how we break up the snow. We do, let's say 1000. You see, we start breaking up here the snow and it falls more natural. This was a problem in AutoMaterial version 1. And right now with the next version, which is this one, the AM2, we fixed that, and it's way more natural via this control height variation scale. See how natural it is. The next thing that you can control is the fall off distance. So right now, when we zoom in here, you can see how it's falling off. But when we start controlling the fall off distance, let's say 500, let's go radical with 10,000. You can see that we add some small fall off patches over here. Let's do like 2000. So it looks way more natural. Let's try 4000. Yeah, 4000 looks better. And you can see that we have here patches of snow breaking up this extra, cutting the edge and adding more of a fall off distance. So you can play with those settings in order for you to get, realistic snow fall off into your landscape. So let's start and create the material function for the snow. So let's right click and search for material function and create a new material function, which I'm going to call snow mask. Open the material function. And for a start, we need to get the world position because we're going to spawn this snow texture based on the world position. So right click, world position. And this time we're going to use the absolute world position, including the material offset. For a start, I'm just going to divide this world position, the X and Y, and I'm just going to divide it by 10,000. And this is for a start to get the calculation correctly. And then after that, you can tweak through the world height, controlling where the snow will be spawned. The next one will be a texture sampler, which will control the height variation scale. So I'm gonna add texture sample. And I'm just gonna use the noise mask that we have in this project. If you want to get the textures, just download them. They're in the description of this video for free. Then just connect the divide to the UVs over here. And right now we're controlling the UVs by getting the absolute world position and dividing it by 10,000. Then what I want to do is I want to multiply. And I'm just going to multiply the red channel from it because I'm just extracting from this texture just the red channel pattern. You can extract the green or the blue, it doesn't matter. They have different kind of cloud noise patterns. And then I want to create a function input. And this function input will control the height variation scale. So we're going to control the scale of this texture and we're going to add this snow variation. So I'm going to name this snow height variation scale. And this one won't be a vector tree, it should be a scalar parameter and it will hold a sort priority of 4. Now let's connect to B. The next thing is I need to subtract this from the snow height. So I'm just going to copy and paste the scalar parameter. And this new scalar parameter will be my snow height. How high you want the snow to be spawned. Again, it will be a scalar. I'm going to put for the sort priority 0. And then right click, subtract. And I'm going to subtract the noise variation with the height. So I'm having the height and I'm subtracting the noise variation from it. And this will break the details in the snow. The next thing that we want to add is the snow fall distance, how the snow will fall as I showed you before. So let's create a function input and I'm gonna name this function input snow fall off distance. This one again will be a scalar parameter. Sort priority will go to 1 and I'm gonna put in the preview values 15 on X. This will be for my preview values. Then I'm just gonna divide and I'm gonna divide by 2 over here. I'm dividing the entire fall of distance by 2 and I'm just gonna multiply this by -1. All right, so I'm just gonna multiply by -1. And right now what we want to do is from the subtracted, we want to add. So I'm gonna right click, search for add. So I'm just gonna add the subtracted value based on the snow height and considering the multiplication of the snow height variation. And for the B, I'm just gonna connect my fall off distance. So right now we're adding the fall off distance to the snow height mixed with the height variation. And I'm just gonna create another add because right now we're adding it to the multiply, which is reversed, but I want to create an add with the simple one without reversing it. So I'm just gonna put this one like that, move it like this so you see the connections. And this time I'm gonna just connect the B section from the divide here. So we have 2 add blocks with different settings. And those add blocks, I'm just gonna smooth step. So I'm just smoothing out everything. So smooth step, this is a math operation. And right now I'm just gonna connect the min here and the maximum over here. And for the value of the smooth step, we're gonna use the world position. And from the world position, we're gonna use the Z, which is the up axis, the Z axis. So right now it will smooth up based on the Z axis, which is going upwards. And just everything from here, I'm gonna feed to the output result. And the final thing we need in the texture sample to set this to wrap and just save it. And we are ready with the MF snow mask. And here in the shader itself, you can see how the edges are smoothing up over here. And this will represent falling the snow on based on the z-axis, and we will have a soft edge which will blend naturally with the rest of our landscape. Alright, so let's continue on with the next material function. The next function that we're going to create is going to control the slopes. And right now, let me just show you how the grass will affect the slopes. Right now, I've selected the slope power to be 5, the contrast breakup to be 1, and the tiling to be 1000. If I start tweaking up the contrast breakup, so if I try 3, you can see that we're just breaking up here some little elements. All right, but let's control the power of the slope. Right now it's 5. If I put 1, you can see that the grass will overtake the slopes, and we are telling that the grass can go up on the slopes. But if I do like, let's say 8, you can see that the grass right now is considering the slopes as an area that the grass should not be there. So if I put 10 or 30, less grass is popping out on the slopes, and we're just eating up on the flat surface. The idea here is that the slopes are working based on an angle. So if I put, let's say 5, and let's control the tiling size, I can also break up the tiling using a noise texture. So if I put 1000, you can see how the tiling is different. 3000, completely different. So by using the slopes per texture, so this is for the grass texture, we can control each texture how it can affect the slopes. Here we have different settings for the slopes, and this is very useful because maybe you want some of the layers to be on top of the slopes or getting in some areas of the slopes. And another function that we have for the slopes is how we can break them up. Right now, if you can see here, we have lighter rock and we have a little bit darker rock. And if I start multiplying this, let's try with 1. You see right now we have 2 repetitive same color. But if you want to break this up, we have here under this utility slopes 0. Let's try with 1.05. And you can see that we start breaking up the entire silhouette of the slopes. And the idea here is that when you're far away and you want to see at the slopes, if we don't have this breakup, everything will look kind of the same, but adding this breakup, let's say 1.1, we are darkening some of the spots and it's getting better, better realism in it. And you can also control how it will soft up the edges, what is the slope power. So for example, how high you want to be. So let's say we want 0, we want everything to be darkened. But if we do 50, we have lighter spots here and darker over here. So this is additional tweak that will add pretty much a lot of realism when you're seeing your landscape from far. And when you get even closer, it will add more realism to it. So let's start and create those material functions. So let's right click and search for material function. And this material function will be my MF slopes. Let's open it. And slopes are pretty easy to make. So we're going to get the vertex normals. So I'm going to search for vertex normal VS. So we're getting the normal of the vertices from the landscape. And we're going to mask the B channel. So component mask. And we're going to mask the B channel. So the B channel from the vertex normal is the Z axis, which is upwards, So we're just masking the Z axis. Then we're going to saturate in order for me to get a clear saturation on the component mask. And the next thing is to create the scour parameters for the multiply, power, and edge soft. So right click, search for scour parameter. And this scour parameter will be slopes multiplier. And here we need to define some settings. First, the default value will be 1.1. The slider maximum will be 1.8. And we're going to group this under slopes. So we have another separate category where we can control this. And the sort priority will be 1. And next we need to connect the saturation and the multiplier to a multiply node. So let's do a multiply node. And let's connect the saturation to A and the multiplier to B. The next parameter that we need is the slopes power. So I'm going to select it, Control C, Control V, in order for us to control the power of the slopes. Slopes, power. And the slopes power, we have a default value of 15. The slider maximum will be 100. It will be again under group slopes. Sort priority will be 2. And for us to give slopes power, the function itself, we need to add a power. So I'm going to add a power and I'm going to connect the base. So the base will be the base multiplier and the vertex normals. And we are going to give the exposure, the power value that we're going to set up here at this parameter. Then again, I'm going to saturate node. And finally, for the edge soften, we need to have a cheap contrast, which is already created in Unreal. So we search for cheap contrast. And for the in, we're going to add everything that we've created so far, the power and the multiplier. And for the contrast, we're going to add slopes edge soften. So I'm just going to copy the power right here, paste it. And this one will be my slopes edge soften. For the default value, I'm going to put 1. For the slider max, I'm going to put 1. For the slopes, I'm going to put 2. And right now, for the contrast, we will need to reverse it. So the reverse function 1 minus. And this 1 minus will go to the contrast. So our slopes are pretty much done. And the result should go to the output result. And this function, slopes, is ready. So let's save it and continue on with the next one. So the next function is the slope mask. So let's create a material function. And this will be my MF slope mask. All right, so let's create the mask to add this extra detail. So we're going to start again with the vertex normal VS. And the next one that we need is a constant vector 3, because we will need to define the vector that we are operating with the slope mask. So search for constant 3 vector. All right, and in this 3 vector, we will need to open the constant and set the b value to 1. And right now, this constant vector, as the b value is 1, imagine that this is a coordinate system, x, y, and z. We are working with the z-axis in the positive range. And the next thing that we will need is slopes power and a contrast. So let's create a function input. And let's control the slopes power. So this will be slope power. And this should be a scalar parameter. So select the scalar parameter. Check the use preview values as default. And the sort priority will be 0. We will need another scalar parameter which will control the contrast. So Control C, Control V. And this one will be my slope contrast. The settings will be the same. We need a new node, which is slope mask node. This is created in Unreal Engine, so we will use it straight out of the box. So right click, slope mask under MISC. And we have tangent normal, which is going to use our vertex normal. We have a slope angle, which is a vector 3. And as I told you, we define the z-axis. And from here, we're going to connect the RGB. For the fall-off power and the cheap contrast, we're just going to connect the slopes power to the fall-off power and the contrast to the cheap contrast. Then the next node that we're going to use is called height lerp. So this will lerp based on height. So right click, search for height lerp. And here the height lerp will take into account A and B, start and transition fade, have a height texture and a contrast. But right now we are going to use only the transition phase and the height texture. So I'm going to connect the transition phase to the slopes that we have connected over here. Let me just close this one and rearrange everything. And for the height texture, we will need to get the absolute world position X and Y. So search for world position. The absolute world position will include the material shader offset, and here we will try to break it up a little bit. So let's select the scour, Control C and Control V, and we will create another parameter which will be tiling breakup. And this one will also be a scour parameter. And we're gonna divide the X and Y by the breakup of the tiling that we want to create. After that, we want to add a texture object which will start this breakup. And we're gonna use our noise mask for that. So right click, texture object. And this texture object, we're gonna choose our noise mask. All right. And from this noise mask, we're gonna add this noise mask to a texture 2D, so we can put any noise mask into the inspector of the material, not going back here into the material function. So I'm just gonna copy this scour, paste it. And in order for us to create this function input, I'm gonna choose a texture 2D. Because this is hard coded and we want to be able to drop any textures into our material. So I'm just gonna name this mask texture. So in the future, if you want just to change the mask texture, no needs to go here in the material function and change this one. We expose this into this function input. Now connect it over here. And this will work as our default placeholder. Now we need to apply this to a texture sampler. And this texture sample and the UVs will be directed from the absolute world position. We're gonna break up the UVs by adding this tiling scour parameter and dividing them together. So this will go into the UVs and the texture will go into the texture slot. The next one is we need a static mask component parameter. So search for static mask under parameter static component mask parameter and add this one. We're gonna name this slope mask channel breakup. Slope mask channel / breakup. And by default, we're gonna use the red channel. And I'm gonna connect the RGBA over here. The idea is that this parameter will open those RGBNA slots. And for example, this noise mask texture holds different pattern of noise in each channel, as I showed you in this video. And you can switch by selecting these checkers. Let's say you want to use the mask from the R channel, you're just gonna select the R channel. If you want to use the mask from the B channel, you're gonna select the B channel. So in general, this is what this does. It will expose the channels and you can choose which kind of breakup from your texture you want to use as a channel. Then the next thing that we want to add is we want to add a little bit of contrast. So I'm going to add a cheap contrast. Those settings with the cheap contrast is just adding a little bit more detail to bump up the texture itself. And I'm going to hook up a contrast here function input. So copy and paste it. This should be a scour parameter. And I'm going to name this contrast slopes breakup. And this will boost up the cheap contrast. So the default value of the cheap contrast, won't change the mask channel that we've selected here. But if we start boosting up the contrast, we're going to have brighter values in the texture or darker values in the texture. And just as a reminder, those are the texture channels. And by tweaking the contrast, we're going to control the contrast between black and white. And you're going to end up with different kind of textures. And this is created in order for us to automate everything, not to go into Photoshop and, select contrast, then import the texture again. And once we are finished with this one, we're going to connect it to height texture. Before we output the result, we want to clamp, not to go in any crazy values. So the alpha clamp usually is between 1 and 0, which means either it's black or either it's white, and it's anything between those values, like little gray, more gray, and going into full white when you reach 1. And that's why we want to clamp, because we don't want to get into extreme values. So I'm just going to connect the alpha to the clamp, and I'm going to connect to the output result. And by clamping it, we define the alpha that alpha works from 0 to 1, which is the normal behavior of an alpha channel. All right, so we're pretty much done with MF Slope Mask. Save it And let's continue on with the next function. So the next function will be a lot more complex, but we are getting there. So right now we're going to combine all the functions. And for example, here we have layer 01, ambient occlusion, everything that you can control for ambient occlusion. Everything that you can control in color correction over here, like the displacement, the normal settings, the roughness and specular, the slopes, the texture itself that you can load up, the switch between ORD and ORM, the tiling, etc. We'll create this entire section of a block with parameters that you can expose. And those parameters will work per layer. So we're just going to define all the parameters and then we're going to create the layers. So let's get started. So let's create a new material function. And this one will be my MF default layer. This will direct all the layers that we're going to create in the game and we're going to derive from this one. So the first thing that we need to do is we need to create a lot of parameters in order for us to expose them and then control them. And we need to connect those parameters to the material functions that we've created so far. So let's get started. The first parameter that I'm going to create is the albedo texture. So I'm going to create function input. And this function input, I'm going to name albedo texture. And this will be a texture 2D because we're going to hook up here our albedo texture. So texture 2D. And for the set priority, I'm going to put 2. Then I'm going to reroute. And I'm going to name this reroute as reroute albedo texture. After the albedo texture, I'm just going to copy everything, paste it. And here we're going to have our specular texture. Again, our specular texture will be texture 2D because we're going to hook up our specular. And this will be named as reroute specular texture. The next one is we need to create the input for our UVs. So I'm just going to copy and paste this function input. And then I'm going to name this UVs. For the UVs, as UV is working in two coordinate system with X and Y, we're going to use a vector 2. And set the priority to 0. After we set the priority to 0, I'm just going to copy this reroute, paste it over here, connect it, and name this reroute UVs. Moving further, we're going to create the blend mask, which will be a vector 3. So copy and paste this vector 2. And this will be vector 3. I'm going to name blend mask. And I'm going to copy the reroute, paste it, and this will be reroute blend mask. And then I'm going to connect the blend mask over here. And the blend mask will hold the priority of 1. So far so good, but we have a lot more to create. Let's move on with the next one, which is the normal texture. This will be a texture 2D. So I'm just going to copy and paste this one. And I'm going to name this as normal texture. The normal texture will have the sort priority of 3. And also it will be a 2D texture that we're going to hook up. And it will be reroute normal texture. All right, moving further, it is coming our ORD texture and ORM texture. So I'm going to copy this one, paste it. We need to expose all the parameters. So ORD texture. This will be texture 2D. The sort priority will be 4. And the reroute will be r.R.ORD texture. All right. Then we need to hook up our ORM texture. Copy and paste. Name this ORM texture. And then the reroute should be ORM texture. And let me check again the sort priority. So this should be 2. And this should be also 2 as we are grouping them together. The UVs should be 1. The blend mask should be 1. The normal texture should be 3. The ORD should be 4. And the ORM texture should also be 4. Let me just align this and align those. The next one is the height texture. So I'm going to copy this one, paste it. You see the workflow, but we need to do this manually for every texture and every, function input and parameter. So this will be height texture. Again, this will be texture 2D. I'm going to keep the sort priority of 4, and the reroute will be reroute height texture. Moving further, the roughness. Let me just copy this one. Roughness texture. It will be again input texture 2D, and the reroute will be reroute roughness texture. The next texture that is following is ambient occlusion. So this will be my AO texture. It will be again 2D, sort priority of 4, and here we're gonna reroute AO texture. Then we start with the scour parameters, with the vectors, etc. The first one will be the desaturation. Do we want to desaturate or not? So I'm just gonna copy and paste this one, move it a little bit down like that, so we separate the textures. And this one, we're gonna choose a scour parameter, and this will be desaturation. And now the reroute will be reroute desaturation. Again, it will hold a priority of 4. Then we start with the color correction. So the next one is correction. It will be a vector tree because this will work like a tint on our texture. And the reroute will be reroute color correction. And I'm gonna fix this one as color correction. The next one is our contrast. So I'm just copying the desaturation, contrast. It will be again scour 4, and it will be reroute contrast. So right now we have the saturation, color correction. This is vector tree because we're gonna apply a tint color onto the texture as an effect and, visual color correction. Here we have the contrast. Then we will need to have the brightness. So copy and paste it. Here we will need the brightness. Again, the same scour, sort priority of 4, and here the reroute will be brightness. Following up is the black power, white power, levels, gamma, etc. So we're gonna start with the black power. So black power. This is for our levels like in Photoshop. And this time the reroute I'm gonna call the saturation shadows. So this reroute is desaturating the shadow when we try to control the black power. This is a little bit more descriptive, and it is better written like that for later when we start to connect it to the material functions. The next one after black power is the white power. So I'm gonna connect this white power. Same input type as color, sort priority of 4, reroute white power. Following up is the level gamma. So this one will be my levels gamma. And the reroute levels gamma. It will be the same, a scalar parameter, sort priority of 4. The next one is the levels input white. So copy and paste it, move it a little bit down, levels input white. Same scour, sort priority of 4, r levels input white. Then we have the levels input black, so copy and paste it. Levels input black. Just gonna copy this name and just paste it here. Input, or just substitute the white with black. So right now we have the levels input white and we have the levels input black. But right now we have the inputs, and what we need to do is we need to have also the outputs. So I'm just gonna copy this one, paste it. So this will be my level output white. can just copy this. It is the same scour 4, but here in the RR levels, output white. This is a little bit frustrating to create all those function inputs, but it is super important to arrange everything and to have it clean like that. After level output white, we're gonna have a levels output black. So copy and paste it. Level output black. I'm just gonna copy this. I'm just gonna change this to black. And the scour sort priority of 4 is the same. Then we continue on with the roughness intensity. So copy and paste it. Again, it will be a scour. So here we're going to control the roughness intensity. Roughness intensity. Same scour, sort priority of 4. And here reroute roughness intensity. After the roughness intensity, we have roughness power. So roughness power. Reroute will be roughness power. We move on with the specular. So the first one will be specular intensity. And the reroute should be specular intensity. Then the next one will be the Fresnel. So Fresnel intensity. And for the reroute, I'm gonna do Fresnel intensity. After that, we need to create the normal intensity, which will be again a scour. So normal intensity. And the reroute, I'm just gonna change here from Fresnel to normal and just delete the 1 at the end. We also have a normal power, so copy and paste this, normal power. Keep the same scour and 4, so normal power. Those parameters are a lot, but in the end, you have huge control over the landscape and you're gonna have micro control over each of the details on your landscape, and all this is worth a million times, so keep it going. The next is we need to create the ambient occlusion for the black, so control and paste, and this will be again scour. So I'm gonna name this AO black. This will control the black spot of the ambient occlusion, and I'm gonna name this reroute AO black. Then we need to control the black intensity, so copy and paste it. This will be my AO black intensity. And the reroute will be AO black intensity. Following up is the black power, so copy and paste it. AO black power. And the reroute black power, all right? We did this for the blacks. We need to do that for the gray and for the white. So let's keep it going. Copy and paste this. And this one will be my AO gray. So this will control my AO gray. Same guys, scour 4 as a priority. Then we do AO gray intensity. I'm just gonna copy this one, the black. So I'm just gonna change black to gray. And I'm just gonna remove the numbers, and here black will go to gray, and I'm just gonna remove this because it's a little bit faster. So right now we have also the gray intensity, and the next is to do the gray power. So I'm just gonna copy and paste this. Maybe this has one interval more. All right, so gray power, and this will be my gray power. All right, we've added also the ambient occlusion for the gray power. And then we need to do that for the white. So I'm gonna copy the gray. This is the last one for the ambient occlusion. So we do white and select AO gray. Here will be white. Then we need to do the intensity for the white. Copy and paste this one. Gray, I'm gonna change to white. delete this one. Gray changing to white here. White. And I'm just gonna delete the one over here. And finally, we need to do the white power. So gray power here should be white. Moving the one. Gray should be white. White. Removing this one. So we finish up with the ambient occlusion, then we need to do the tiling near and the tiling far. So I'm just gonna copy this one, paste it, and move it a little bit down so we can separate them. So I'm gonna do this tiling near, and this will hold a priority of 5, and it will be a scour parameter, and the reroute will be r_tiling near. And I'm just gonna copy this, paste it, and this will be my tiling far. This will be tiling far, and it will hold again the sort priority of 5. We have a couple of more, so we need to control the displacement, scale min, medium, and maximum. Then we need to create booleans for the use of ORD or ORM plus Heightmap. So let's do the displacement first. Copy and paste this, and this one will be called displacement scale min. All right, this will hold a priority of 6, and it will be a scour parameter. For the reroute, I'm gonna name this displacement scale min, and I'm just gonna copy this one, paste it, and this will be the displacement scale mid. So this will be my mid values. It will still be sort priority of 6 scour, and just min I'm gonna replace with mid. And then one more for the maximum values of the displacement. Mid will go to max, and scale mid will be max. All right. I'm just gonna select everything and align them with Shift A. And the next one is the booleans for ORD and ORM, which will be the final one, and we are done with this block. So I'm just gonna copy this, paste it, put a sorting priority of 2, and name this use ORD. And this will be a static bool. So go here and select static bool. All right. And here on the reroute, use ORD. Okay. I'm gonna copy and paste this one, align it, and this will be reroute use ORM plus height. And for the input function, I'm gonna name this use ORM plus height, and this will be a static bool with sorting priority of 2. Now I'm gonna select everything on the left, Shift and A, everything on the right, Shift and A. Now select all the things that we've created, click C on your keyboard, and let's zoom in and comment that. So here I'm gonna put parameters reroutes, and I'm gonna click show bubble when zoomed. All right, so we've defined our parameters, and let's start creating the logic. This was the hard part, the long part, and now it is the easy part, and let's go straight to it. So the first block that we need to define is we need to plug in our textures. Let me just put this a little bit wider, right? So it can cover all the nodes over here. So the first one is MF texture object. So let's go and start using the functions that we've created. I'm gonna select this MF texture object and drag and drop it here. And we need to plug all the textures that we're going to use in our material. And this is per layer based. So, okay, right here. And I'm just gonna first create the reroutes. So I'm gonna reroute here, and I'm gonna name this albedo textures. All right, so here I'm gonna expose the albedo. I'm gonna copy and paste this, connect the normal, and name it normal textures. Keep in mind that here we doesn't have RR, which was specifically designed to use RR here at the base for my parameter reroutes. And here, after we do some calculations and export the albedo, normal, ORD, and specular texture, I'm just going to use the normal definition for the texture, like normal, albedo texture, etc. Then from here, we're going to have the ORD and the specular. Let me do this, ORD texture. and here Specular texture, and connect them together. So here and here. So our reroutes from the textures is ready. And the idea is that we're going to connect those parameters, and those parameters we can control into the material instance and into the master material. And here we do all the calculations that we have in our texture object, all the things that we've created here as functions, and we output them as a result here. And then from this result, we still keep making some corrections in the material. Right now, it will kick out those reroutes and everything won't look as spaghetti, because otherwise we need to connect it like that. For example, this one here. And imagine when we have a lot of blocks, what spaghetti it will happen here. So the first we need near tiling. So I'm going to search for r tiling near this one. So I'm going to connect the near here, r tiling far. I'm going to connect the far over here to this one. And it is pretty easy because we need just to connect our reroutes. The next one is our reroute for the UVs. So r UVs, connect it over here. Then we need to connect our blend mask. So r blend mask. Pretty straightforward, just a lot of manual work, but this is worth the time because everything will be structured. Then we need r albedo texture. This one, connected here to the albedo texture. I'm just moving them upwards so all the connections are visible and not overlapping each other. The next one is the normal texture, r normal texture. Be careful not to connect something else, normal texture. Then we need the ORD and ORM. So r OR. I'm gonna copy this. I'm gonna connect the ORD first and ORM second. Let me just move them like that. Shift A and make them like that. A little bit backwards so everything can be seen. Then we need the height texture. So r height texture. Connected. The roughness texture. r roughness, not power, not intensity. Careful, just the texture. Connect the texture. Then r.AO texture. If you misclicked it and connect something else, it will give you wrong results. So be careful about that, or just type the entire name of what you're looking for. And then the specular texture. Let me connect it. And then we need the reroute for use ORM and use ORD. Reroute, then use. I'm gonna copy this, ORD, right click, reroute, ORM. So the first one is ORD, the second one is ORM. We connect it here. Move this a little bit down and this a little further. And I'm gonna select this block, move it like that. I'm gonna select everything here, comment, and call these textures. Now I'm gonna click show bubble when zoomed, and this is inputting the texture that we define here. So all the textures that you downloaded through Quixel or you have your own will be inputted here, go to the texture object, and then we expose the final results. Now let's start and modify the normal. First we need the normal function that we've created. So mf normal, this one, all right? And everything goes through the function that we've created and we expose the results. So this is pretty cool because everything is super modular, everything is separated and is structured how it should be for a AAA game and big studios. Here what we need is we need to get the normal texture from here. So search for normal texture, this kind of reroute, then we connect it to the normal vector tree. Then we need the normal intensity and normal power. So r normal intensity and r normal power. I'm going to connect the intensity here. I'm going to connect the power over here. Let me shift A. Let me move them like that. And here from the result, I'm going to drag and I'm going to reroute decoration node. And this I'm going to name final normal. And this will be my final outputs that we're going to connect to the final material output. And I'm just going to use for finals, maybe this color. So every final node will have this color. So I'm just going to comment this and name this as normal. Here we modify the normal. Let me just move it like that. So it aligned with the other one. And right now we have our textures and normals connected. Let's move to the base color controls. So I'm gonna minimize here, and we need the color variation node. So MF color variation. We put the node here, zoom in, and we need to connect everything here in order for us to control it. The first one is the albedo texture. So we search for albedo texture and we connect it here. This albedo texture is the one that we have from here, that we expose here from the textures. Then we start with the reroutes. The first reroute that we need to search is for contrast. So reroute contrast and start connecting it. So reroute contrast. So the next one is the brightness, and let me search where the brightness was. So here we have the brightness, but I want to define that this brightness is for color. So here I'm gonna put color brightness. And let's go back here. And just to know that this is for the color. So R color brightness. All right. Okay, so we have the color brightness here and connected to brightness over here. Let's move it like that. The next one is our reroute from the color correction, which works like a tint. So RR color correction, this one. And we need to connect to the color correction. Moving further, the desaturation, RR desaturation, connected here. All right, great. Then for the black power, we will need to use the reroute desaturation shadows. So reroute desaturation shadows. This is desaturating the shadows. This goes to the black power. Then for the white power, we're going to use the white power, RR white power. Maybe if this is too confusing, just rename this as black power. So white power. Then we have the levels input white. So RR levels input white, this one. Then we have the levels input black. So levels input black, connect to this one. So levels gamma is the next one. So we search for RR levels gamma. And I'm going to connect here to the levels gamma. Then we have the levels output black, and we have the levels output white. So search for RR levels output black, and I'm going to add the white one too. So the black goes into the black connector and the white goes into the white one. So right now what we have here is our color variation, but here I'm going to add a multiply node because I want to add an extra ambient occlusion layer. The result will go into the multiply, and once we create the ambient occlusion, we're going to connect it here. And I'm going to copy this final normal and paste this over here, connect it, and name this final base color. So this is our base color control so far, and we're going to go back and connect the multiply B in a few minutes after we create the ambient occlusion. So I'm going to select this, comment this as base color controls, and I'm going to show the bubble when zoomed out and move this just like that. Okay. So the next one will be the ambient occlusion. So I'm going to select my ambient occlusion and drop it over here. And we have all those ambient occlusion connections that we need to make. We need to hook up the ORD texture. So I'm going to search for my ORD texture. This is the ORD texture that we expose from here. And why we are doing that, we need to separate the red channel because in my ORD texture, the red channel is holding the occlusion, then the green channel is holding the roughness, and the blue channel is holding the displacement. And we need to separate this. How to do that? With component mask. I hope you already know how to separate channels like this. We covered this multiple times. So right now I'm just splitting and getting the mask from the red channel, or there is another way to do that, which is like split component. And this also works. So right now we have the RG and B, and you can just connect the red over here. So use split component for this one. Then we need to hook up the AO blacks, black intensity, black power, etc. All the settings for the AO. So let's start. The first one is r.AO black. All right, I'm gonna connect the black here. AO black intensity is the second one. Then the black power. Pretty easy, black power here. Just remember to split the components so we expose the occlusion channel and connect to the ambient occlusion modifier over here. Then we go for ambient occlusion gray. So ambient occlusion gray, gray intensity, and gray power. So let me just connect first the gray here, the gray intensity over here, and the gray power. Oh, come on. And the gray power over here. And finally, we have the AO white. So white, white intensity, and white power. So let's start connecting those together. White, white intensity over here, and white power over here. And let's arrange this, right? Shift A, move this like that so it's readable. And from here, we need to expose the result. So I'm just gonna copy this, as this will be final ambient occlusion, and expose this like that and name it final ambient occlusion. Then the next, what you need to do, select everything, comment ambient occlusion, show bubble when zoomed, move it like that, and our ambient occlusion block is ready. Now we need to go back to our color variation and add the ambient occlusion also to the color variation. So here I'm gonna search for final ambient occlusion, and we're gonna multiply with the final ambient occlusion. This will add extra ambient occlusion onto our color variation, and it will add additional shadows, and it will be way more realistic in the end result on your landscape. And I'm just gonna comment this one as adding extra layer of AO. All right. If you find out that this is too much, you can always turn it off. But I think this is a good addition in order to give more realism to your color variation and mixed it with ambient occlusion. Let's move with the specular. So the first thing that we need to have is specular texture. So I'm just gonna get the specular texture, and we will need the albedo texture. All right. And after those two, we need to create a static switch parameter. So static switch parameter. And we're going to be switching between specular and albedo texture. Do we want to have specular or not? So this I'm going to call use specular texture. If you don't want to use specular texture, we're going to use just the albedo and the roughness, etc. But if you want to use a specular texture, it will fire it up. In the group, I'm going to name it like that, lyr/01/roughness and specular. So LYR stands for layer, and the sort priority here will be 4. So this will show up, this boolean, under layer 01, roughness and specular. Then we need our specular. So let's find it out where it is. Specular, here it is. So I'm just gonna drag and drop it. And here under specular texture, we're gonna hook up, either we're gonna use the specular texture or the albedo texture. It depends on this static switch parameter, is it on or off, okay? By default, everything I put on off, okay? So the next is specular intensity and Fresnel intensity, so RR, specular intensity, and let's connect it here, and then RR, Fresnel intensity, and connect it over here. We're getting there. All right, arrange them to look good. And after that, we just expose the final result. So copy from here, paste from here, connect it, and this will be my final specular, okay? Again, I'm gonna comment this Specular, and I'm gonna click show the bubble, right? I'm just gonna move this here. So we are grouping everything. See how everything is so clean that even if you make some mistakes, connect something to the wrong, connection over here, you can go back, trace it pretty easily and fix it. Next, let's do the height. So from the ORD texture, I'm just gonna mask the blue channel, as the blue channel is for the displacement. So component mask, and I'm just masking the blue channel, and we are exposing the height. This is because we packed 3 types of textures in just one. We packed the ambient occlusion into the red, the roughness into the green, and the displacement into the blue channel, and we are just extracting only the blue channel. And here I'm just gonna make a final height map. All right, and I'm just gonna connect it over here. And I'm gonna name this height. Of course, if you want here to make any modification, feel free to do. But this will be responsible for my height. Move it like that. And we have specular and height. The next one is the roughness. So let me just get the roughness where it is. Let me just find it. MF roughness. Here it is. And here we need, again, a texture, roughness intensity, and roughness power. So I'm going to search for roughness power, roughness intensity. And I'm going to connect to roughness intensity and roughness power here. And again, from the ORD texture, so ORD texture, the roughness is in our green channel. So we're going to split the component, and from here, from the green channel, we're gonna add it to the roughness. You can do it through mask, but I think split component works better in this way to get only the red, green, and blue channel. And here I'm gonna copy and paste this and make this as a final roughness. Queue everything, select it, comment it, roughness. It's a little bit repetitive task here to do, but it's kind of way more clean, and I like the way to work like that, because if everything is modular and everything is exposed like that, it is pretty easy to debug and to fix any issues that you have in the future, or just you want to create some logic over here onto the final nodes, you can pretty easily do that. And the final thing that we need to do is the displacement. So I'm gonna get my ORD texture again, and here I'm gonna use component mask, and I'm gonna get the blue channel as the displacement is the blue channel. What we will create here into the displacement, right now when you create displacement, when you add displacement and tessellation to your landscape, what you can control is magnitude and center. And the magnitude says how the displacement is powering up. Is it too much? Is it less? Etc. But you don't have any control over this attribute. And what I figured out that it can work, you can work with the gamma between black and whites, and you can boost them up or tune them down. And let me show you how I did this. So I used a node 3-point levels, and this controls the values of a texture. Right now we're exporting the displacement texture, and let's say we tune up the magnitude to be 0.5, and you have a lot of displacement. And the correct way to fix that, if you don't have control in Unreal Engine, is to go into Photoshop and tweak your displacement texture to be darker or whiter. But I figured out that you can do this inside Unreal. So just connect the displacement texture to texture here, and we're gonna create RR displacement. And so max, mid, and min. And what we can do through those is we can control the displacement texture inside Unreal Engine. So I'm gonna connect the min values to the new black values. The mid values will go to the mid, and the scale max will go to the white values. So in general, what we've done here, let me demonstrate in Photoshop. What you will do is, this is like a levels. You can do something like this, boost up the whites, and those will pop out a lot more, or just, saturate everything and make everything not to stand out so much. Like everything could be like that, or just desaturate this. So the idea is to have those controls in Unreal Engine, and this is the way that I found out that you can control. And it's pretty good that you can control the displacement inside your material and not just use the default functions in the material, which is the magnitude and the offset. By doing this, you can control the entire texture, and on top of the magnitude and offset, you can tweak up your displacement and get very nice results with it. And finally, what we need to do, of course, do a final node reroute. I'm just gonna align everything with Q, and this will be my final displacement. I'm gonna comment this as displacement, right? Move this like that, and show the bows when zoomed in. Then for our final result, we have created different kind of textures, but we need to set the material attributes. So set material attributes. Imagine that we've created, all those textures, but they're separated. They're not connected to a material. They're deconstructed like a Lego. And what we need here to do is just add all the layers. So we need base color. We need roughness, which will be the second one. We need specular. So specular. The next one that we need is normal, not bent normal, just normal. Then we need the ambient occlusion. Here it is. After that, we need displacement. And finally, we need opacity. So this one will be opacity, not opacity mask, but opacity. And this one will be connected to my output result. And let's start connecting the final nodes. So in the material attributes, we are not going to connect anything because we are setting the material attributes and we're, constructing the material. So I'm going to search for final. I'm going to need specular, roughness, normal. I'm going to need the height. I'm going to need the displacement. I'm going to need the base color, and I'm going to need the ambient occlusion. So first we need to connect the base color over here. Let's move those a little bit down. Okay. Then we need to connect the roughness. Next one is the specular. So let's connect the specular, connect the normal, move them like that. Then the next one is ambient occlusion. We do the displacement. And for the opacity, we're going to use the height. Right now I'm going to move this in the middle. And I'm going to select everything, comment, and name it final material output. Right? Show bubble when zoomed out. Move it like that. And let's save everything. So we are ready with the default layer. It looks pretty complex, but it's not so that complex. So let's save this up and continue on. The next material function that we want to create is the RVT Blend. And let me quickly explain what RVT stands for. It's Runtime Virtual Texturing. And the idea is that when you place objects into your scene, you can see that they have sharp edges. They're not blending with the material itself from the landscape. But by enabling RVT and creating the RVT function, it will be enabling the blending between the landscape and all your 3D models that you place onto the landscape. See here how the landscape is blending together with the rocks, and everything looks way more natural than having those hard edges here and not having any blending. So the RVT is for that, and let's start creating this function. The first thing that you need to do is you need to have enabled RVT. So go to Edit, Project Settings, search for Virtual Texture, and here enable virtual texture support. So enable it if you didn't and restart Unreal Engine. Now let's proceed with the function. So I'm going to right click and search for material function. And I'm going to click on the material function and I'm going to name it MF RVT Blend. All right, let's open it. So the first block that we need is material attributes, which will be our in function. So function input, And this should be material attributes. So this one, function input material attributes. All right, so this is our first step. This we will run with the blend material attributes. So I'm gonna right click and search for blend material attributes. What this will do, it will blend different kind of material attributes. So I'm just gonna have a basic one over here and connect it to A. In the B and alpha, we're gonna make the RVT to work. Then just connect the blend material attributes to the output result. So we have the first initial setup. The next is we need to get the runtime virtual texture sample. So I'm just gonna move this a little bit back and search for runtime virtual texture sample. So what we are doing here is we are sampling the landscape with the runtime virtual texture. So I'm gonna select here the RVT base that we've created, and the rest will stay the same. The next thing is we need to make material attributes. So we are creating and sampling the landscape with a virtual texture. Then we need to make, then select this make material attributes, all right? So here we will sample the base color. So we are getting virtual texture for the base color. We are doing this for the specular, same for the roughness, but for the normal we need a transform vector. So I'm gonna right click and I'm gonna transform vector. And I'm gonna choose under vector ops the transform. Right now the transform vector is in tangent space. We need to work in world space. So the source should be world space and the destination should be in tangent space. The source is the landscape and the destination is the meshes that we are putting onto the landscape. And this is how it should start blending the normal map. So I'm gonna connect my normal up here and connect the transform vector to the normal over here. And then these material attributes that we are constructing will go to B. So far so good, but we still need to blend between those two. And to start blending, we will need first the vertex normal VS. So I'm gonna search for vertex normal VS. So I'm gonna choose vertex normal VS. And the next is we need to define which vector are we using. So we're gonna use the constant 3 vector, constant 3 vector. And as I mentioned before, with constant 3 vector, we can direct the vector that we are using by setting up 1. So imagine that this is X, Y, and Z. And in Unreal, Z axis is the up axis. So we're gonna operate with the up axis. And we are operating with the up axis because we want to blend the landscape and all the meshes that are placed onto the landscape based on the Z axis, which is the up axis. Now we're going to use another function which is called dot product. So the dot product usually computes the length of one vector projected onto the other. The calculation is used by many techniques for computing fall-offs. So this is usually for falling off and for good blending. So I'm going to use dot product and I'm going to use the vertex normal as A and the Z that we've defined as B. Then from this dot product result, we will remap the value range, remap value range. And here we're going to set up a few settings that we can control. So I'm just going to connect this to the input. And I'm going to create a scalar parameter. Scalar parameter. And the first one will be my blend angle limit. Blend angle limit. And this will dictate the limit of the blending. So here the group will be RVT blending. And I'm going to connect this to the input low. Then I'm just going to create a value. So hold 1 on your keyboard and connect it to target low. And this will be hard coded as 0.3. All right. Then after that, when we remap, we will need to saturate just to get a better result from the remap. So we are saturating. And then I'm just going to use a multiply node, connect the saturate to B. And I'm going to copy and paste the blend angle limit. Something like this. And I'm going to name this blend height. Blend height. This will define the height of the blend and the default value will be 10. So how high into the 3D mesh you want to blend the landscape texture to. And then connect it to A. All right, the next step, let me just move this block a little bit down, something like this, because we need some space for others. Then we need to create a runtime virtual texture sample, and we need to sample the world height. So runtime virtual texture sample. And now we're gonna sample the height of the world because we will need to know the height of the actual world in order for us to start blending. Then I'm gonna search for world position. And to determine height, we will use the z-axis. And I'm just gonna subtract. And I'm gonna subtract the world height with the world height from the runtime virtual texture sample. And then I'm gonna add. So I'm gonna add here. So just add a value here. We're gonna add 3. After that, we're gonna divide this multiply node with the height. So I'm just gonna place it here. I'm gonna divide. So we're dividing the world height, which will go into A, and the settings that we've made here, the blend angle, the blend height, which will go into B. So that way it will work based on the world height, and those blend height and blend angle limit will set up based on the world height. Then I'm gonna do a power, and I'm just gonna power it by 1, just to give it a little bit of power in order for clean up the fall off. Then I'm gonna saturate, which will give a better fall off effect. And then I'm gonna 1 minus, reverse everything. So the idea here for the reverse is because the fall off will start from top to the bottom of each object, and we want to start from the bottom to the top, and that's why I'm reversing it. And everything here, I'm just gonna feed in my alpha. So I'm just gonna move this something like this to be more clean. I'm gonna feed with the alpha. So this will be my blending over here. And we're pretty much ready with the material function RVT Blend. I'm just gonna save everything and let's continue on with the next stuff. So the next thing that we need to create is we need to start creating the material layers. And the material layers are those that we need to paint onto the landscape. Right now into the landscape we have 4 different material layers. We have a layer for the slopes, a layer for the snow. We have automatic blend with no foliage. We have automatic blend, layer 3, layer 2, layer 4, and layer 1. So those are the layers that we are going to create right now. So let's get started. So under material, let's create a new folder. So I'm going to right click, new folder, and I'm going to call this material layers. So those I call material layers, but those are material functions. So if you go to material, you can see that there is material layer, but we are going to use material function because we want to represent our material function inside this one and create this like a layer. So I'm going to select this and I'm going to call this ML for material layer. And this will be my layer 01. So let's start creating it. To create a layer, we've already created a default layer function. So let's go back to material function. And we need to drag and drop the MF default layer. And here in the MF default layer, we have all the parameters for this kind of layer. And guess what? We need to connect them all. So this will be a long process. So let's start. The first one is the UVs. So I'm going to right click, function input. And this function input will use a vector tool. And I'm going to name this as landscape size /UVs. And sort priority will be 40. Now this I'm going to connect to UVs, which requires vector 3. And I'm ready with the first one. The second one will be another function input. So I'm going to create function input. This one will be a vector 3 as blend mask requires vector 3. And I'm going to name this distance fade. Those are the settings that will be exposed in the material that you're going to work with. So I'm going to set the sort priority of 41 and I'm going to connect to the blend mask over here. So as we can see, the next one is the specular texture. So I'm going to search for texture parameter and I'm going to select texture object parameter. So this parameter will be my layer /01/specular. And this will go under the group layer layer/01/textures. So I will know that those are the textures. I'm going to select the sort priority of 2, and I'm going to give the default texture my albedo mocap, just to use this placeholder as a start. So layer 01, specular, layer 01, textures. So all the textures will be under the group textures, and I'm going to connect this to the specular textures. Then the next one is ORD. But for ORD, this is a boolean. So what we need is a static bool parameter. So I'm going to search for static bool parameter, this one. And this I'm going to name layer/01/use ORD. So when this value is true, we will use the ORD texture. Let me connect it to the ORD. And from the groups, I'm going to select textures because this is also responsible for textures. Sort priority will be 6. The next one is the albedo texture. So the next one we will need a texture. So I'm going to copy this one, the specular, paste it. And here I'm going to name albedo. And the layer will be the same. I'm going to use textures, and sort priority will be 0 as my albedo will be the first one. And I'm going to use the albedo mocap also. Then let's connect this to the albedo texture. Then the next parameter is use ORM plus height. And I'm just going to copy this static bool parameter, paste it over here. And I'm going to connect to use ORM plus height. And I'm going to change the name, use ORM plus height. It will be again under textures, sort priority of 7. And I'm going to set those parameters to true by default. Moving further, we have the normal texture. So I'm just going to move those up. And I'm going to copy this one, paste it, connect to the normal, and let's modify it. So this will be my layer 01 normal. It will be under textures, sort priority of 1. And here I'm going to use my water normal map. This is just for the placeholders. And the next one is the roughness texture. So I'm going to move this a little bit up, something like that. And I'm going to copy the normal. I'm going to paste it. And this will be responsible for my roughness. So this I'm going to name roughness. Also will be under layer 01 textures. I'm going to put 4, and I'm going to choose my r.Nanite.AllowTessellation mocap because we are using this, this mocap for the roughness. And I'm going to connect to my roughness texture. Let's go to the next one, which is the ambient occlusion. You know the drill, copy and paste this one. So this will be my AO. It will be under textures, sort priority of 3. And I'm going to keep the r.Nanite.AllowTessellation mocap, and I'm going to connect to the AO. Moving further is the desaturation. And for this, I'm going to use scour parameter. And I'm going to name this layer/01/desaturation. And this will go into another group, which will be layer/01/cover correction. So I'm starting a new group, which will hold all my cover correction stuff, and the sort priority will be 3. And a default value of -0.7. So -0.7, those are the default values that will keep your texture the same as you imported it. And I'm just going to connect to the desaturation. So I've experimented with different values to see when you import a texture, our cover correction settings to be exactly the same as the texture values. So it doesn't alternate the texture when you enable the cover corrections. So the next one is cover correction, and we're going to search for vector parameter, and I'm going to use this vector parameter. This will be again layer/01/cover correction. And we're going to choose the cover correction group, sort priority of 0. So with this one, we're going to change the tint of the texture, and I'm just going to give it white color. And I'm going to connect the RGB to the cover correction. Now let's move this a little bit up. We're not even halfway there. The next one, the ORD texture, copy and paste this one. So this is ORD. And for the ORD, I'm gonna set the sort priority again to 3. And I'm gonna connect the ORD texture here. Then we have the brightness. So for the brightness, I'm gonna need also this scalar parameter. So copy and paste it. And this will be my layer 1 brightness. And the default value will be 1. And this will be under color correction. And I'm gonna put the sort priority to 1. And let's connect the brightness. Then we move to the black power. So I'm gonna copy and paste this. And this will be my layer 1 black power. For the black power, the default parameter will be 0. Under color correction, sort priority 4. Connect the black power. And then we need the white power. So I'm just gonna copy this one, paste it. This will be my white power. Under color correction, sort priority of 5. And connect it here to the white power. Let's tweak up the next, which is a level gamma. So copy and paste this one, move it like that, connect it, and let's rename it to levels gamma. For the levels gamma, everything will be 0, sort priority of 6, color correction will stay as a default group. The next one is levels input white, copy and paste this one. Will be levels input white. Again, everything zeroed out and sort priority of 7. Connect it here. And let's move this a little bit up because we are taking too much space. After that, we have the ORM texture. And let's copy the texture here, the ORD, paste it. This will be my ORM. I'm going to keep the sort priority to 3 because we are switching between ORD and ORM texture. So that's why I'm keeping it like that. It will use the MoCap and will be under the textures layer and connect to ORM. Then we have the levels output white. So input white, copy and paste it. Just gonna change to output white. And for the default value here, I'm gonna put 0.5, so 0.5, and the sort priority will be 9. Also, I'm gonna keep this under color correction, so 0.5, under color correction, sort priority of 9, level output white. Moving further is the height texture, so I'm gonna copy this one. The process is long, but be careful in it because when you set the sort priority and the groups, you can mess up something. You need everything to be in the exact group and the sort priority to be correct. If something is missing, then your sort priority is overlapping with something else. Keep that in mind. So for layer 01, I'm gonna name this height, and this will hold sort priority of 5, and I'm gonna connect to the height texture. The next one is the contrast, so I'm just gonna copy this one, paste it. This will be contrast. The default value for the contrast is 0.23, and this value works not to alternate your texture when you're importing it. So 0.23, I experiment a lot, and this is the value that is correct. Sort priority of 2, and I'm gonna connect the contrast here. Then we have the levels output black. So I'm gonna copy this one. Output, I'm gonna change here just to black. And here the default value should be 0, 0, 0. Color correction, sort priority of 10. And I'm gonna connect it here to the levels output black. Next one is roughness power. Let me just move those a little bit up. It's pretty easy, but it takes time to do them. So copy and paste this. And I'm gonna name here roughness power. And everything will be 0 out. And I'm gonna create a new layer, which will be layer 01, roughness, and specular. So this layer will hold my roughness and specular, and this will be with index number 1. And I'm gonna connect this to the roughness power. Then the next one is the specular intensity. So I'm gonna copy and paste this and call this specular intensity. Again, it will be under roughness and specular. This will hold sort priority of 2, connect to the specular intensity. Then moving further, for now intensity, copy and paste this for now intensity, again under roughness and specular. Number 3, connect this. Then we have the normal intensity. So I'm just going to copy this one, paste it, call it normal intensity, and connect it here. And I'm going to create a new group, which will be normal. And here I'm going to stack everything about the normals. After that is the normal power. Copy and paste this one. Normal power. It will stay under normal. I'm going to put 1 and connect it over here. Then we start with the ambient occlusions. Let me just move those a little bit up like that. And let's start with the ambient occlusion, which is the first one, the black one. So AO black. This will be my AO black. And I'm going to create, of course, a new group, which I'm going to stack the ambient occlusion. So here, layer 01, ambient occlusion. And for the AO black, I'm going to set the sort priority of 0. I'm going to put it over here. Then let's start creating the other ones. So this will be my AO black intensity. Again, under ambient occlusion, sort priority of 1. Default value will be 1 for this one. And also I missed for the AO black, the default value will also be 1. Let's connect this one to the intensity. Then we move to the black power. So I'm going to copy and paste this one. Black power. Let's connect the black power and set the sort priority to 2. Moving further, AO gray, gray intensity, and gray power. I'm just going to copy this 3 times, 2, 3 times, just to make it a little bit faster. AO black, but this is gray. And the next one will be gray power. And the third one will be gray intensity. Let's start with the first one. 1, 0, 0. This will be under ambient occlusion. Sort priority of 3, connected to the gray. Then the next one is the gray intensity. So the gray intensity will hold again 1, 0, 0. Ambient occlusion, and this will be 4, connect to the gray intensity. And the AO gray power, connect to the gray power. It will be 1, 0, 0, and sort priority of 5. Now we have AO white, white intensity, and white power. I'm just going to copy those, paste those 3. AO white, this will be white. I'm just going to copy white and just paste it here over gray, just paste it here over gray. And what I need here to do is just set the sort priority. So this one will be 6. The white intensity will be 7, and the white power will be 8. And let's start connecting it. So 1, 0, 0, again, ambient occlusion. The sort priority for AO white is 6, connected here, white intensity, and white power. So 6, 7, 8. So we have levels input black. And let me just copy the white power, paste it, and do this levels input black. And I'm going to have 0 here, and I'm going to have power correction. And for the sort priority, I'm going to have 8. And let's connect to the levels input black. If you want to reorder this, you need to go into the default layer. Let me just save it and show it to you. You need to go to the default layer and start sorting this out. And this will fix the sorter order here. So for example, if roughness power is 4 over here, and if we change it to 1, it will go up. So you can tweak it like that if this is too messy for you. Moving to the next, which is a scour. So I'm just going to copy this one. And this one will be my roughness intensity. And the roughness intensity should go under roughness and specular, and the sort priority will be 0, as this will be the first thing to tweak and connect it over here. And we have the tiling far and the tiling near. So I'm just going to copy the roughness, paste it, and name this as near tiling size, and I'm gonna connect it to the near over here. And I'm gonna create a new layer, new group, sorry, which is tiling. And the near size will be with sort priority of 0, and I'm gonna give a default value of 200, because just to start with something as a default value for the tiling. Then I'm gonna copy this one, paste this one, connect to the far. Let's change it to far. And I'm gonna give a default value for the far of 1000, and I'm gonna put sort priority of 1. Then what's left for us is the displacements. So I'm gonna copy and paste this one and name this as a displacement scale max. And for the maximum scale, I'm gonna put the default value of 1. This is the maximum that displacement can go. And I'm gonna create a new group, displacement. And the maximum value will be under sort priority of 0. Let's copy and paste this one 2 more times. So this is scale max. I'm gonna do a scale mid, and I'm gonna do a scale min. And let's change the values. The mid should be 0.5 and the min should be 0. And let's change the sort priority. So this will be maximum 0, medium 1, and minimum 2. And let's connect this out. Max, mid, and min. So right now we have a problem here. If we zoom here, it says cannot cast from static bow to bow. So we need to fix that. And we made a mistake on the road. So I'm just gonna open this. And here under use ORD and ORM height, we selected bow, but it should be a static bow. So change it to static bow and change this one also to static bow. All right, save this one. And we need to change on one more place. If we go here under MF texture object, here we are using bow. We need also to use a static bow for ORD and ORM. So I'm just going to open this. And here where we need to switch between using the ORD or using the ORM, we selected bows. And here we need to change it to static bow. So change this to static bow. And then save again this, save the default layer, go to this one. And here right now, we can see that the layer is working. So this was the fix, and this was the thing that we missed. So this ML layer 01 is ready. Let's continue on with the next layers. So in order to create 3 more layers, what I suggest you to do is just copy and paste this one. And this is my ML layer 2. So I'm just going to open it. And what you need to change here is you need to change everywhere where it says layer 01. You just change it to layer 02. And the groups also layer 02. And keep everything the same. Like the sort priority, everything should be the same. Just go through all the layers and just paste here 02, 02, go here 02, 02, etc. So every block over here, you need to change to 02, and you'll have exact same copy of the layer, but another layer that you can use onto your landscape. It's a little bit of manual work, but you already have the base, and this should be easy. Just change everything here, and don't forget to change the name and the group, but that's pretty straightforward. After you make all the 4 materials, duplicates, they should look like this. So everything here is 0202. If you scroll down, everything is 0202. I just created them and changed all the naming. Then when we go to the 03, you can see 03, 03 group, and everything is 03. Let's go up here, 03. Everything else is the same. I'm just changing the group name and the parameter name. And let's go and check out 04. Here it is 0404. Let's scroll down 0404 and go here 0404, 0404. So that's how your 4 material layers should look like in the end. Then the next one, what we need to create is we need to create a material layer for the slopes. And we also need to create a material layer for the snow. So let's create the slopes. So I'm just gonna copy and paste this one. And I'm gonna name this ML layer slopes. And I'm just gonna open it. And here I'm just gonna use a different naming. Everything will be the same. I'm just gonna change the naming. So here I'm gonna use layer, and then I'm gonna name this layer as slopes. So slopes, and I'm gonna use this name for the group. And I'm gonna do this for all the parameters here that we define. So the MF slopes are ready. Let's save this and proceed with the layer snow. I'm just gonna do the same as the layer slope. So I'm gonna copy and paste this, and this will be my ML layers snow, layer snow. I'm just gonna name it. Then I'm gonna open it. And here I'm gonna start changing the name from slopes to snow, like that. I'm gonna put snow to the group, and I'm gonna make this for all the parameters here. So we're ready with the layer snow. Just save it, and let's continue on with the next material functions. Now, as we've created the layers already, what's next is to create the material function that will blend the layers. So right click and search for material, and let's create the next material function, mf layers blending. All right. And in this function, we're going to start blending all the layers together. So I'm just going to open it. And first we need the mf distance fade. So let me find the mf distance fade, this one, drag and drop it over here. And we need to reroute the distance fade. So reroute, and I'm going to find the reroute node, and I'm going to name it r distance fade node. And the next is we need to get the landscape coordinates. So landscape coordinates. And this one is the value of your landscape size. So for the default, I'm going to put the mapping scale of 4096. And in the comment bubble, let's place, a description. The value is your landscape size. So when you have your landscape size, you just need to go here and put it manually into the mapping scale. And then we will reroute. I'm just going to copy this reroute. And this reroute will be my landscape coordinates, landscape coords. All right. And those I'm going to align here, and I'm going to put here a comment reroute distance, fade, and landscape size. And let's show the bubble here. All right. Now let's start blending together the layers. First, what I need to do is go to my material layers and start dragging the layers. So this one, the slopes, the first layer, the second, the third, the fourth, and the snow. All right. Can open this, and we're gonna start with the slopes. Let me just move this so I can have some space. So here in the slopes, we have the distance fade and the landscape size. And what we need to do is just get the reroutes. So I'm gonna get this reroute and this reroute. And I'm gonna hook up the landscape coordinate in the landscape size and the distance fade in the distance fade vector tree. Now from the result, I'm gonna reroute again. And this reroute, I'm gonna name reroute ML for material layer slopes. All right, so this will be my reroute for the slopes. The next one is the layer 1. So I'm just gonna put here the layer 1, and I'm gonna add the 2 reroutes that we have. So distance fade goes into the distance fade and landscape coordinate here. And I'm gonna copy and paste this one. And this will be my reroute material layer 01. And I'm gonna do the same for the 2, 3, and 4. So let me get this here. Let's do it for the second material layer. Copy this, paste it, connect it over here. Copy this, paste it. And let's name this layer 02. All right, I'm gonna align everything to look better. And let's do layer 3. Copy and paste it, connect it, connect it. Let's do here layer 3. I'm just making it a little bit fast, but it's kind of the same. Shift A to align them. Then we continue with the layer 4 and the snow. So the snow will go to the last. So let's here do the layer 4. Let me just align everything again. Something like this, to have a little space between the elements, just to be more readable. So this will be my layer 4. Let me connect it. Q. Layer 4. And so I'm going to copy those nodes, connect them over here, and give it a little space. Something like this. Shift A, Shift A. And the final one will be my snow. It will be exactly the same. Landscape coordinates, and the distance fade goes here. And let's copy the reroute, connect it, and this will be material layer snow. All right. Then I'm gonna Shift A, Shift A, Shift A, and align everything. Now let's start blending together the layers. So what we need is the material function height blend attribute. So let me just go to material functions and drag and drop this one, height blend attribute. All right. So with this one, we're gonna blend the materials based on the height. So the first one that we need is layer slopes, RR material layer, so layer slopes, and layer slopes will be going into A. Then we're gonna have the layer 1, which will go into the B, and we're gonna create a function input, which is a scalar, and this will drive the alpha. So let's select it to be a scalar. Let's call it layer 01 slope and put sort priority of 1 and connect this scalar here in the alpha. Then we continue on with the blend attribute. Let's do it like that. And we start mixing with the other layers. So here we're gonna add the next layer, which is RRML layer number 2. And we're gonna hook this up into B. And I'm gonna copy this scalar, paste it, and I'm gonna name this layer 02/mask. So this will be controlling the blending of the mask of layer 2. And I'm gonna put here 2, and I'm gonna connect it here to the alpha. Let's move to the next one. So I'm just gonna copy and paste this one, connect it here. Now we do layer 3. So RRML layer number 3. I'm gonna connect it here. And I'm gonna copy this one, paste it, and this will be my layer 3 mask. And it will hold sort priority of 3, connected to my alpha. We're gonna do the same for layer 4 and for the snow. So here, let me just align them again. RRML layer 4, connected here at the B, copy and paste this one. Let me just move it like that, connected to alpha. This will be my layer 4 mask. And it will hold a sort priority of number 4. And then we're going to do one more for the snow. So let me blend right now the snow, RRML layer snow, connect it here and create one more scalar input. This one will be called layer snow mask, layer snow/mask, and it will hold the priority of number 5. And let's connect to the alpha. And then from the result, we will reroute and call this a final layer snow. All right, and let's align everything. So we start by blending the slopes and layer 1, and after that we go to layer 2, layer 3, layer 4, and layer snow. Imagine that we started from the ground up, all right? And right now we have our final snow, which will start blending from the top to the bottom with all the layers and with the slope. And we need again to blend it and get the landscape layer sample in order for us to create the layers that we can paint on. So I'm just gonna copy this height blend here. And here I'm gonna find my final layer snow and start blending my final layer snow with RML with the first layer. And right now we start creating the layers that we can pick up into the landscape paint mode. And then for the alpha, we're going to use the landscape layer sample in order for us to create the layer that we paint on. So right now we're creating those layers to be exposed and giving us the ability to start painting. So search for landscape layer sample, landscape layer sample. All right. And I'm going to name this layer/01. I'm going to move it like that. The preview weight will be 0 and I'm going to connect it to alpha. Let's do this for the second layer. So I'm going to connect this RRML, and this will be for my layer 2. I'm going to connect to the B, and I'm going to copy and paste this one to the alpha. It will be layer number 2. So we are giving the abilities to paint the layers through this. So I'm just going to move this a little bit like that to be more readable. Let's continue with the third one. So layer blend. Let's search for RML, layer number 3, connect it to B, copy and paste this one. This one should be 3, connect it to alpha, and connect this like that. Let me move it to look a little bit better. Let's move everything over here. And then we need to create the layer 4. And as we've already mixed the slopes and the snow over here, we are getting the snow, and we also mix the slopes. This will be our last layer, ML layer 4, connected to B, connected here, layer number 04, and connected to alpha. And finally, the result should go into the output result, connected. Let me align everything. And with the preview, we see that the blending is working and everything is good. So right now, let's just save it, and we have our layers blending material function. The next step that we need to take is to create 2 more folders. One will hold the landscape layers and the other will hold the layer foliage types. So I'm going to right click, new folder, and I'm going to name this landscape layers. And I'm going to create one more folder, which will be my layer foliage type, layer foliage types. And here under layer foliage types, I'm going to create 4 landscape grass. So I'm going to search for landscape grass. I'm going to create this one and I'm going to name it Foliages layer 01. I'm going to copy this one more time. This will be my layer 02, layer 03, and layer 04. I'm going to save everything. And here under the indexes, you can add any kind of 3D meshes that you want to spawn onto the landscape itself. So under grass varieties, you can add different kind of arrays. And here you can set up grass density, using of the grid, code distance, etc. I'm going to deep dive in those settings a little bit later. But in general, those 4 will hold the vegetation, the foliages into our landscape that we're going to spawn procedurally. So in order to do that, to spawn, assets procedurally, it doesn't matter if it's a foliage, maybe you want to spawn rocks or something else, we need to create a material function which we're gonna call AutoFoliages. So right click, go to material, and create a new material function, which will be mf AutoFoliages. I'm just gonna open this one, and let's start creating it. So the first thing that we want to have is a landscape layer sample. So landscape layer sample. And this one will be the layer that will automatically blend with no foliages. So this will be automatic blend no foliages, which means that all the textures that we feed into our material will blend together and they won't have any foliages on them. And I'm just going to reverse this 1 minus. So we're going to exclude the foliages. The next step is we need to create the layers as a scour so we can control the min and max on the layers. So create a function input. And I'm going to name this layer 01 slope. This will be a scour and it will hold a sort priority of 1. Then I'm going to copy and paste this scour and I'm going to create a layer 02 for the mask. So layer 02 mask, this will be the mask. For the second layer, let me just shift A. And for this, I'm going to set the sort priority of 2. The next one is the mask for layer 3. So here, layer 3 mask, shift A, and the sort priority will be 3. And finally, we want to mask the foliages on layer 4. So copy and paste this, layer 4, mask, and sort priority of 4. Then we need to max between the landscape layer sample and the slopes and the masks. What we're going to use is the max expression, which takes in 2 inputs, then takes the maximum of the 2. The node is similar to Photoshop Lighten. So I'm going to right click and use max. And what I'm going to do is I'm going to add this slope as A. And I'm going to search for landscape layer sample, landscape layer sample. So we are sampling the layer, which is the layer 01. And we're gonna max between the slope and the layer 01. I'm gonna copy and paste this one, move it like that, connect it here, and this will be my layer 02. And I'm gonna do this for the third one, and this will be my layer 03. And for the fourth one, and this will be my layer 04. Put it like that. Then let's align everything here so it looks clean. Let me move this like that and align everything. So the next what we do is we multiply our automatic blend no foliage with the slopes. So let's multiply, and the reverse will go into B, and we're going to use the slopes into A. So we are multiplying between the blend with no foliages and the slopes and layer 01 maxed. Then we need 3 more multiplication, 1, 2, 3, shift A, and we're going to start with the first one. So the first multiply, I'm just going to connect the multiply over here to this multiply. And we're going to multiply with the second layer and start cleaning up the connections like that. After that, I'm going to multiply here. I'm going to multiply with the third layer, clean the connection. And I'm also going to multiply and multiply with the fourth layer and also clean the connection here. Then what we're going to do is we're going to subtract, and we're going to subtract here from the multiply, which will go into A, and clean this spaghetti. So something like this. And we're going to subtract with the multiply node over here. Then we're going to do again a subtract, and we're going to subtract with the second one, and we're going to subtract with the third one. So we're just subtracting the foliages that we're going to spawn, and just do it like that. And then I'm going to reroute from here, reroute, and I'm going to name this as layer 02. I'm going to copy and paste this 2 more times, rerouting here, layer 03, and here layer 04, and connect it here. All right. Then from this subtract, we're going to create a static switch parameter, static switch parameter, this one, the static switch parameter, and I'm going to name this auto foliages on and off. So auto foliage on, off. From this parameter, we can turn it on or turn it off, and I'm going to give it a group auto foliage and the sort priority of 0. Now let's connect the subtract to true. And for the false, I'm just gonna hold 1 on my keyboard and give it a value of 0. So the false means there will be no foliages spawning, all right? And we're gonna output the result here. And I'm gonna name this auto foliage layer 01. Auto foliage slash layer 01. So, and why we did the reroutes here? Because we need to have this toggle per layer. So for example, if on layer 1 you don't want to have foliages, you will have the default value as false. But if it's true, it will start spawning the foliages based on the layers, all right? On layer 1, layer 2, layer 3, layer 4, blend with no foliages, etc. But if you don't want on layer 1, just don't use it. Now, I'm just gonna copy and paste the end result. And this output will be my auto foliage layer 02. Do we want foliages on layer 02? I'm gonna put 1 and I'm gonna copy this auto foliage, paste it over here, connect it, and I'm gonna copy also this value and I'm gonna connect to the false. Keep the sort priority and the parameters the same because this is per layer. And as we here reroute, we're gonna use the reroutes. So I'm gonna reroute layer 2, move it like that. And I'm gonna do the same for layer 3 and layer 4. All right. So this will be my layer 3. It will hold a priority of 2. And this will be my layer 4. It will hold a priority of 3. Now let's copy the auto foliage with the value. So copy it like that. Connect it. Maybe align them. Again, copy. Connect it. Align them. And we're going to use here layer 3. And here we're going to use layer 4. So layer 4 if we want foliages, layer 3 if we don't want foliages. Let me align everything and align those two. So this is pretty much the logic of auto foliage spawning, and later on in our master material we'll define what we want to spawn as we've already created the foliage grass types. So just save this one and we are ready with this material function. Now we need to create a few materials. The first will be my master RVT Blend material. So I'm gonna right click and create a material and I'm gonna name this m_RVT Blend. So I'm just gonna open it. And here what we need to do is we need to connect the runtime virtual texture sample to the m_RVT Blend. So let's find this node, runtime virtual. This one, the runtime virtual texture sample. And here we're gonna select the RVT base. And we're gonna connect the base color to the base color, the specular to the specular, roughness to the roughness, and normal to the normal. And this is for our RVT blend. I'm gonna save this and close it. The next material that we need to create is the master RVT. So I'm gonna right click, new material. I'm gonna name this MS RVT. I'm gonna open it. The first thing is I'm gonna use the material attributes. So just click in an empty area and click use material attributes. So what we export here into the output, this is what will be in the end material. So the first that we need to use is we need to use the MF tiling. So I'm just gonna use the MF tiling. And this tiling comes with Unreal Engine that will tile a texture. Then we search for texture sample parameter 2D. And the first parameter will be albedo. And I'm gonna put a group of 07/texture map, texture maps. For the sample source, I'm gonna use RUP. and sort priority will be 0. And here for the texture, I'm just going to use the default diffuse as a placeholder. But don't use the VT texture, just use the simple one, the color one, the default diffuse color one. Then what I'm going to do is I'm going to copy and place this one. And I'm going to name this metalness. And this will hold sort priority of 1. It still will be wrap. And I'm just going to use the black placeholder, not the VT, but the simple one with linear color. Then I'm going to copy and paste this one. And I'm going to create a new texture, which is DRF. DRF is displacement, roughness, and fuzziness. And I'm going to put sort priority of 2. The description will be DRF. And here for the sample source, I'm going to use from the texture asset. And here for the placeholder, I'm going to use white placeholder. The color will be linear. And the last one will be my normal. So I'm going to copy and paste this one. I'm going to name this parameter as normal. It will be again in texture maps. This will be 3. I'm going to delete the description. And I'm going to change the sample source to wrap. And I'm going to use here the placeholder normal. Again, not the RVT, but the normal one. And the sample type should be normal. Now I'm just going to group this and call it textures. I'm going to show the bubble. I'm going to move this a little bit like that just to cover them. All right, so those are the textures placeholders. And this block is for the tiling. So I'm just going to name here tiling just as an information. For the tiling, we need to connect the result in the UVs because we're going to tile the UVs. Tile here, and tile over here in the normal. Then what we need is another block, which will be our adjustments. So I'm going to search for MF map adjustments. This is also provided with Unreal Engine. So I'm not going to adjust the ambient occlusion. So I'm going to hold 1 on my keyboard and just put a dummy value, which is 0 inside here. So move it like that. And I'm going to start connecting. My albedo will go here. Let me just clean up the connection. My metalness will go into the metallic, of course. From the DRF, the roughness is the green channel, so roughness goes here. And for the tangent normal, we use the normal map RGB and clean it up again like that. For the tangent normal rotation angle, we're going to use this rotation angle. So I'm going to connect it over here. And right now it's a little bit of a spaghetti. So I'm just going to move it like that and clean it like that. So you can definitely see how the connections are doing and where they are going exactly. And I'm just gonna select this and call this adjustments. I'm gonna open it, maybe move it a little bit like that, just to free some space. Show bubble and zoom out. Move this final node over here. The next what we want to export is the fuzziness from here, from the blue channel. So there is also a function mffuzzy, and this will provide the fuzziness into our RVT. So I'm just going to connect the result over here. And the fuzzy map will go from the blue channel and connect here at the fuzzy map. And finally, we need the function that we've created. So I'm going to minimize here and I'm going to drag and drop our RVT blend function. And let's connect the result here and connect it over here at the final output. And one mistake that I've made is the metalness should go from the red channel over here. So just disconnect and connect it over here to the metallic. All right, so this is pretty much for our master RVT material. So save it up and let's continue on. Now let's create the final step. Let's create the master material. We are ready to create the master material, and after that to start placing everything in the scene and tweaking up the values and see is everything all right, and if we need, we'll go back and fix something. So let's create our master material. So landscape auto material. All right, I'm gonna open this. So the first thing that we need to create is we need to create a slope mask, which we're going to use. So I'm going to right click and search for texture object parameter. So this one under textures, texture object parameter. I'm going to name this slope mask texture. I'm going to hit enter, and this group will be under slopes, and the sort priority will be 0. And I'm going to use my noise mask, this one, and it will be masks. So from here, I'm going to reroute, and I'm going to name this slope mask texture. And this will represent my slope mask. Now for the slopes, I'm going to right click and search for slope mask under MISC. And this is out of the box in Unreal. And then I'm going to add a constant 3 vector. And I'm going to use again the Z axis. We've already talked about this. And this will be for my slope angle. All right. Then I want to control the fall off. So I'm going to create a scalar parameter, this one. And this one I'm going to name layer slopes slash fall off power. How it will fall off onto the layer. The default value will be 5. And I'm going to group this under layer slash slopes slash slopes. And I'm going to put a sort priority of 5. And let's connect the layer slopes fall off to the fall off power over here. Then I'm going to lerp. So I'm going to lerp the result into B. And in A, I'm going to use the MF slopes. So drag and drop MF slopes here. And we're going to use the slopes function over here. For the alpha, I'm going to give a 0 hard-coded. And here I'm going to use a static switch parameter. And this will say, are we going to use layer 01? By creating this, we are turning on and off layers. For example, if you want in your landscape only to have 3 layers, you can turn some of the layers off. Okay, so I'm going to connect if true, and I'm going to connect here is false. So right now, by default, I want to use this layer. By default, I'm going to select that all the layers are available. But if this is false, we're not going to use this layer. So the layer 1 will use the slope mask. And let's move to the layer number 2. So I'm going to search for MF slope mask, this one. And I'm going to move it a little bit down. So here under mask texture, we're going to need our slope mask texture. So slope mask under mask texture. For the tiling breakup, I'm going to copy and paste this one. And under the tiling breakup, we're going to use layer 01 slope styling size. So I'm going to name this layer 01 slash slopes slash tiling size. And I'm going to put this under layer slash 01 slash slopes. The sort priority of this one will be 6, and I'm going to connect it to the tiling breakup. The next one is the contrast slopes breakup. So I'm going to copy and paste this one. And I'm going to name it layer 01 slopes slash contrast breakup. And this will have a default value of 1. And for the tiling size, I forgot to put 1000 as a default value. Okay. And this one will hold sort priority of 7. And it will be also under slopes. So let's connect it over here to the contrast slopes breakup. I'm going to copy and paste this one as we need to connect the slope power. So I'm going to change this to power. It still be under layer 01 slopes and sort priority will be 8. I'm just going to give a default power value of 200 and connect it to the slope power here. Then I'm going to use the same layer 01 switch, but this time this will be layer 02. So let me just align it like that. Layer 02. And I'm gonna put this as a group layer switch. And here I'm just gonna select again the layer switch group. So Shift A to align it. And we are ready with the layer number 2. The next one is layer number 3. So let's do it. What I need to have is the same parameters as here. So I'm just gonna copy everything here and paste it. And I'm just gonna start changing. So this is the tiling size. And here I'm gonna change it to layer number 2, slopes tiling size. And here layer number 2. And for this, I'm gonna give a 9 of priority. For the contrast and breakup, I'm gonna put 2 over here. And I'm gonna give a priority of 10. I'm gonna put here the layer number 2. And for the slopes power, I'm just gonna rename this as 2, 2, and here I'll hold 11. And let's change the use layer 2 to use layer 3. And we are ready with the usage of layer number 3. Let's move this a little bit like that. And let's create another one. So I'm just gonna copy and paste this one, which will be my layer number 4. So here I'm gonna put layer number 4. I'm gonna go into the tiling size. This will be 12. It will be 0.3. Here will be 0.3 spacebar. This one, the contrast breakup will be 0.3, 0.3, and here I'm just gonna put 13. And for the power, I'm just gonna do the same, 0.3, 0.3, and this will be 14. And my use layer 4 will use layer switch. So everything here is okay for layer 4. And finally the snow one. So I'm just gonna copy and paste this one. And here I'm just gonna delete the slopes mask because we will need the snow mask. I'm gonna minimize here, MF snow mask, open it. And the first parameter that we need to create is layer snow world height. And the height will be 1000. And I'm just gonna create a new layer, layer/snow. And this will have priority of 0. I'm gonna connect it here at the snow height. And the next one is the fall off distance. So layer snow/fall off distance. And here I'm gonna use by default 500. It will be under my layer snow. I'm gonna use sort priority of 1 and connect it to snow fall off distance. Then what we have is the snow height variation. So here I'm gonna add layer snow/height variation scale. And I'm gonna here have again 500. And it will be under layer snow. And this was 1, so this will be under 2. And I'm gonna connect it here at the snow variation scale. And of course here in the static switch, we will define, do we need to use snow? So this time I'm gonna say use snow layer. It will be under layer switch. I'm gonna connect it under true. Move it like that. And I'm gonna align everything. So now we defined the usage of the layers. Let me just align those here and align those like that and queue on those. So what I'm going to do is I'm going to reroute again because the next step will create a little spaghetti if I don't do that. So I'm going to reroute here and I'm going to name it RR use layer 01. And I'm going to copy and paste this reroute layer 02. Copy and paste this layer 03. Copy and paste this layer 04. And copy and paste this. And I'm going to name this use snow layer. All right. I'm going to shift A and I'm going to align those together. Those two, those, and those. This is an important step to align everything because later on when you need to make some modification, this will help you out. The next thing that we need to do is we need to use the layer blending function. So layer blending, MF layer blending, and we need to have the MF auto foliage also. So let's start with the layer blending, then move with the auto foliage. So here in the layer blending, the first that we need to have is the snow mask. So I'm going to connect it here. Then we're going to start connecting the materials. So material 1, 2, 3, and material 4. So material 1, material 2, material 3, and material 4. And that's why I'm rerouting, because the other connections will be too much and it will get too messy pretty quickly. And the MF blending layer is ready. We're going to do the same for the foliages, except that we don't spawn foliages onto our snow. So I'm just going to make everything here. And I'm going to collect layer 1, layer 2, layer 3, and layer 4. Once we work modular like that with material functions, it is super easy to create the final material in the end. And here, from this out foliage, what we need to search is landscape grass output. All right. And here in the landscape grass output, we've already created 4 outputs here. So if we go to the foliage types, we have those 4 outputs, and we will add those 4 outputs here. So let me add one more index, one more index, and one more index. So I'm going to name the first one layer 01/foliages. And I'm going to connect layer 01 over here. And the grass type will be my layer 01. So we are going to spawn grass onto this layer. Let me do the next one. I'm just going to copy this layer 02 foliages, select the grass type number 2, layer 03 foliages, select grass number type 3, select 04 foliages, and select the grass number 4. And let's do the connections. And our foliages will spawn. And finally, from here, from the layer blending, we need to get material attributes in order for us to work with the RVT. So get material attributes. I'm going to queue this. And the attributes that we need is a base color. We need the specular. So I'm going to search for specular. And after that, we need the roughness, normal, roughness. Then we need to add the normal. And that's pretty much it. So what we need to do next is we need to expose the runtime virtual texture output, this one. And we need to expose and connect the textures that will use the RVT and normal. So we connect those. But for the normal, we need to transform the vector. So transform vector. And I'm going to use this transform. And we need to transform the vector from the source tangent space, and the destination should be the world space. So we are transforming the RVT and connect it here at the normal. And for the world height, we need to get the world position. And we get the Y vector over here and connect it here. Because the height of the world will be determined by absolute world position of the Z, which is the up vector. And finally, from the material attributes, we need to add the distance variation. So I'm gonna go to my material functions and find my MF distance variation. To add the variation in the distance, I'm gonna put it like that, and I'm gonna connect it like here. Maybe move this a little bit down, something like this. And this MF distance will add this slope mask to the distance variation. So here, I'm just gonna add the slope mask texture. All right, like that. And my master material, I'm gonna use material attributes. So whatever is here in the material attributes will be fed to my master landscape material. And the final step is just to connect the result over here. And we are ready with our master material. Now go and save it. And we are pretty much ready to start working with our landscape and showing you how to set up everything with the textures and parameters. All right, so we are ready with the master material, and what we will do next is create material instance. When you create a material instance from the master material, you're creating different kinds of instances from this material. And a material instance can be a desert landscape that you can place onto your landscape. You can place, of course, for example, a green forest or a sci-fi landscape, etc. So right click on this one and click create master material. I'm gonna name it MI for material instance, landscape AutoMaterial 2. All right. So once I open it, you're gonna see all the settings that we've created so far. All the tweaks are over here, and by tweaking up sliders and checkboxes, we can define everything in our landscape. You can see that we have auto foliages, distance variation, distance blending. We have the global static component mask. This is an error that we need to fix. We have the layer switches. From here you can turn on and off layers and all the parameters per layer. So for layer 1, for layer 2, here is the parameters for layer 3, for layer 4, we have the slopes, we have the snow, here we have the utilities, and we have the slopes. But before we deep dive into the settings and show you how you can set up a game-ready landscape, I want to address few fixes that I found out that we've made some mistakes during the process. So the first fix will be to add the slope mask channel to the slopes over here, because right now, let me just scroll down to the slopes over here, because right now it is not defined. So how to do this? We need to open the material function. We need to click on the slope mask. Let's open it. And this one, the slopes mask channel breakup. Here, the group we should set up as slopes. And let's save it. Let's close it. And let's check if this fixes our problem. Open the material instance. Let me see. Here we don't have the slopes. And under slopes down there, we have the slopes mask channel breakup. Perfect, we fixed that. The next one is when I open my material instance, and let's go to layer number 2. So scroll all the way down to layer number 2. And here in layer number 2, we can see that we have contrast break, power, 2 times styling, again contrast break and power. So when I open layer 3, you can see that right here, the missing part is slope. So we need to fix that. And in order to fix that, we need to open the master material. So I'm just going to open the master material, expand it, and see what error we did. So here at slope 2, we have the group as slope 2. Perfect. All right, here we have slopes 1, slopes 1, slopes 1. So I think slopes 3. Yeah, here we have a mistake. So this should be 3. This should be 3. We're just rearranging everything to go to the correct order. So this is no 3, 3, 3. All right, let's save it and check it out if this fixes our problem. So open again the material instance. Scroll all the way to layer number 3. We have the slopes, styling, contrast, and power. Let's check if layer 2 contrast, power, tiling. All right, great. We fixed that too. The next fix that we need to do is in the distance variation. So open the distance variation and let me see. Here we've connected wrongly the RGB to the B over here. And right now what we are going to end up with the distance variation, we're going to have this color into this noise mask. But we don't want to have a colorful noise mask breaking up our landscape. We want just to extract a white and black mask. So extracting white and black, I'm just going to use the red channel. We also have a white and black mask to break up the channel in the green and the blue. Let me just open this one to show you. Here is this mask, which will break up the landscape, showing darker and lighter spots on the landscape. This is another mask, and this is another mask. And when we combine them, we're gonna break up the landscape with this colorful image, which is something that we don't want. So we're just getting the red channel over here. So this is another fix that you need to do in the MF distance variation. Connect the red channel or green or blue, whatever you want, to the B in the multiply. Save it. And another fix that we need to do is in the cell bombing, because in the cell bombing right now we've made 2 mistakes. So open the cell bombing. And the first mistake is that from the alpha we need to saturate in order for us to make the cell bombing a little bit clean. So saturate, and I'm going to connect saturate here and here. This is the first fix in cell bombing. The other fix in the cell bombing is we need to define this texture as a clamp. Right now, the sample source is from texture asset. And right now what you will end up is when we export the alpha, you're going to see those black lines across your entire landscape. And in order to bypass this and don't see any lines onto your landscape, we need to set this to clamp. So set this to clamp, save it, and we've done the fix for the cell bombing too. The next thing that we need to do for the landscape in order for us to get a real colors from the texture, we need to equalize the lightning. So how I do this is I add a post-process volume to my level, and under post-process I search for infinite and click infinite extended unbound. This is the first step. The next search that I want to do is for exposure, and here under exposure I want to have the min and the max exposure at the same value. This will put my color values of the texture in 1 gamma, and I can easily control the colors on the landscape. So I put 1 and 1 over here. And the next thing, as we've created here under textures RVT for the base and for the height, we need to add RVT to our landscape. So go here and search for runtime virtual texture volume. I'm gonna drag once, and this will be my RVT base. And here under RVT base, what you need to do is under bound align actor, I'm going to select the drop over here and select the landscape. Then from the virtual texture, I'm going to select the RVT base and I'm going to set the bound, click set bound. And right now it sets the bound across my entire landscape. You can see here the orange line. And the next RVT that I want to add, so let's add one more, runtime. We'll define the height, so drag and drop it. This will be my RVT height. And I'm just going to do the same. The eye drop, select the landscape, then select the RVT height and set the bounds. All right. I'm just going to save everything. And to move further, we need to select our landscape, then move a little bit down. And here under landscape material, just drag and drop your material instance landscape. So this is how the landscape looks by default. It is not something impressive, but after we start plugging in textures and start tweaking everything on the landscape, you're going to see how drastically this will change. All right, everybody, so we got to the last part when we applied the material to our landscape over here, the material instance, we've applied it. And right now we need to make this beautiful. And in this last part, I'm going to show you how you can turn this into a beautiful landscape. So in order to be ready, I've downloaded a few assets from Quixel. Here I have different kinds of bush foliages. So let me open one. Let me show it. This is a little foliage that I'm going to use onto my landscape. I also downloaded a few grass patches. Let me just zoom it out so you can see this sample grass. So you can find the exact code if you want to download them in the description of this video. Or you can just freely download any kind of foliage from Quixel just for your landscape. So let's start. After we have our foliages, we need to connect them to the layer foliage types. So I'm just going to open my foliages layer 01, and here under the grass variety, I'm going to hit plus. So I'm just going to go to the static mesh and just select the bush variation E and drag and drop it into the grass mesh. From here, you can control the density. So let's do a density of 150. And also you have a lot of different parameters. Do you want to scale them uniformly or you want to randomize them? So the idea here right now is that the minimum scale of this foliage will be 1 and the maximum will be 1. But if you want to have variety, I'm just going to place 0.5, 1.1. And between those two values, it will start spawning this grass mesh and it will have different kind of scale. Also from here, you can control the start culling distance, the end culling distance. This is for optimization. When do you want this grass to be cut and not to be rendered? So after we've added this, click Save, and let's proceed with the next one. I'm going to open layer number 2. And here under layer number 2, I'm just going to search for grass variation F. And I'm going to add this one. I'm going to save it. And I'll select the grass density over here to be 50 because 400 it's way too much. And for the start culling distance, I'm going to put 3000. And for the end culling distance, I'm going to put 4000. Those are the settings that worked great for me. And then the next thing is I'm going to have this randomized variety in scale. So I'm going to put 0.5, and for the maximum, I'm going to put 3. All right, that's it. And I'm going to save. The next one is the layer Foliages tree. And here I'm going to add another foliage, and I'm going to search for ground cover, and this will be variation H. All right. And the other option is here you can add as many as you want in this group, and this is for layer number 3. Let's say your layer number 3 want to have more variety in the foliages, you can add as many as you want over here. I'm just adding one just for the sake of showing you how this works. Then I'm gonna put for the grass density 20 because I don't want to be way too dense. Start culling again 3000 and end culling 4000. For the minimum, I'm going to put 0.5, and for the maximum, I'm going to put 2. Then I'm going to save, and let's continue with the layer 04. I'm going to double click, I'm going to add a new foliage, I'm going to open it, and from here, I'm going to search for grass, variation A. I'm going to use this one. Then for the grass density, again, I'm going to put 50. For the start culling distance, 3000. For the end culling distance, 4000. For the variation, I'm going to put 0.9, and the maximum will be 3.9, something like this. Works great. Then I'm going to save. So right now our layer foliage types are ready. And let me show you how this works. Then we're going to go into our material instance, and we're going to open our material instance. And here, when we zoom, we can see that we have all in the placeholders. Then from the auto foliage, I'm going to enable it, and I'm going to click this checkbox to enable the foliages. And as you can see, the foliages are spawning. Let me just tune down a little bit the camera speed. Let me try to play it just to show you. And now we have foliages spawned onto each of the layers that we've selected. You can see that we have the variety into the scale, and you can play a lot more with the density and scale depending on how dense you want them to be on your landscape, or how the scale should be affecting each of the foliage. So the next step is to handle and set up the distance variation. Right now, I'm going to skip the distance blending because the distance blending, those values by default are working great. But if you want to change them, you can just enable them and start changing the distance blending. So for the distance variation, I'm just going to select the color intensity and the normal intensity, and I'm just going to put 0.2. And for the normal intensity, again, 0.2. Moving further is we need to enable the layer switch. So right now we are not enabling any of the layers, and I'm going to use all of the layers inside my Unreal Engine and inside this material instance. Okay, so after you enable all the layers, I'm just going to start with layer 01. In here under the textures, I'm going to plug the textures that I want. So I'm going to enable all of them. And in this specific case, I'm going to use the ORM workflow. So I don't want to use the ORD. So I'm going to disable it, and I'm going to enable the ORM. So the next step is to connect all the textures into the slots. So I'm just going to drag and drop this texture. This is the height map going over here. This is the normal map going over here. And we are working with the ORM. So ORM go over here. Right? So the first layer is ready. And if we move our scene, let me just speed up a little bit the camera. We start having our first layer working. And of course, the tiling is not correct. From here, it looks okayish, and we're going to fix that in just a second. So this check needs to be enabled here in order to work. So as the tiling right now looks broken, here under the tiling section, I'm going to start tweaking the tiling. The first is the near tiling size. When we are near our texture, how it will be tiled up. So I'm just going to put 1000, and this already looks pretty good. And let me just try to play it just to see how it feels as a scale. It feels solid. It feels pretty good. All right, so here will be 1000. And if I start moving, right now it looks ugly because it's too repetitive. I'm gonna do 1500, and the blending here works just fine. So the tiling here works great, at least with those values that I've set up. Looks good. The next is I'm just gonna tweak the slope. And here for the slopes, I already have a value in mind that I tested. So I'm just gonna put 15, and you can see how it starts working with the slopes. It starts, eating up from here, and the slope says like this is the angle that we can spawn this. You can try with 20 or 30. Maybe 30 looks better for you. Something like this, that you still have rocks here. And the idea is everywhere that you have slopes under this degree, you're gonna have those rocks spawned, and they will mixed up with the other textures. But maybe 25 works better for me. All right, 25 will be the value for the slopes. And of course, you can start tweaking here the contrast and the tiling size, how you want the slopes to work. But I'm just gonna work with the default and just set up here 25. In the section of normal map, right now, if we play our game, you can see that it's a little bit flat. We don't apply any normal adjustments. It still looks good, but we can make it better. So in the section of normal map, I'm just gonna boost up a little bit the normal map. So I'm gonna put 0.1 or 0.05, let's try. And here 0.15, 0.2, 0.3. So those values, you can work with them until you get the result that you need. Maybe something like that, 0.08. I think 0.8 is good, and here we can put 25. And if I start playing it right now, we can see that the normal map is shaping up. Let me just move this away. You can see that the normal map right now is giving us extra detail. So in the foliage layer 01, right now we're spawning these foliages, and they don't look natural because, yeah, you can spawn some between the rocks, but that's too dense and it doesn't look good. The other way is to spawn some small rocks, and if I select rocks, you can see that we have so much rocks, but we're gonna work with the density. Let's try a density of 10. All right, density of 10, not too bad. Let's try with 5. Okay, and start working with the minimum and maximum scale in order for us to have little rocks over there. Let's try 0.1. And you can see that you have those little rocks. Of course, you can fix their material and shading inside of the rock model and material. But this is the way that you can spawn different meshes, different kind of meshes, not only foliages, and fill up your texture. And in our case, this is a rock texture, and it has some logic to spawn some small rocks. And of course, you can make them like that, even smaller, just adding a little bit of detail. But I'm just gonna get rid of them. I just show you how you can add them. And you can also add, let's say, 3 or 4 different types of rocks here under the foliage layer 01, and they are going to spawn on random onto your texture, and you can instantly have this believability in your environment. I'm just gonna get rid of them and save because I want this rock to be clean. The next thing that I want to touch on the layer 01 is the color correction, and I'm just going to work with the brightness and contrast. I'm going to put for brightness 0.6 and for the contrast 25. So I'm just tuning up a little bit, and we can also play with ambient occlusion. Let's test the ambient occlusion here, enable it, and let's start by tweaking here some values. Maybe I'm going to go into 0.2. You can see here in this area of the rock, when we start tweaking this, we are giving more details. So I'm gonna stay with 0.2 because I'm popping out those rocks. Let me try the other values. So pretty much setting up this material is, testing values and seeing what will work for you. All right, let's try if it has gray zones. Yeah, it has grays. So let's try with 0.5 to see how this will look. Right now it's not too natural, so I'm gonna put 0.8. Let me see how the shading is affected. It's a little affected, but that looks better. Okay, let's go with the gray intensity. If we do 2, let's do 0.5. They're getting too dark right now. 0.7, I think it's good. Let me just test it. So it's forward and backward process, and you need to find the good middle ground that you like the textures. So I think that looks good, but I'm just gonna tweak a little bit less of those. Let me try the gray power. 3, 1.2, 0.3. So I'm gonna put 1.5 here just to darken them a little bit more. Let's try with the white power. Do I want my white sections to pop out a little bit more? Maybe not that much. 1.1 will be good. Let's see the intensity. You can tune down the intensity if you want to have a darker, more, blending. But I'm just gonna tune down a little bit and have this, brighter sections in my rocks. And from the power, just gonna put like 2 for them. So from here, we've changed completely our rocks. We give them a lot more details. And those are the things that I want to tweak here, but you can go crazy here and work with the other settings. After we've created this texture and set up some of the settings, the next thing that we need to do in order this to pop out a lot more is to enable the displacement. And right now I'm going to show you how to do that. Go to Edit, go to Project Settings, and search here for Nanite. And Nanite should be enabled. Enable it and restart your Unreal Engine. The next step is to select your landscape, search for Nanite, and here under Enable Nanite, click in the checkbox to enable it. After you enable Nanite, click on Build Data, and after the data is built, you still don't see any displacement. And this is because we didn't include the tessellation in our DefaultEngine.ini file. What you need to do is open your DefaultEngine.ini file. You can open it with Notepad, and here under Static Lightning Falls, this is under Scripts/Engine Rendering Settings. I'm just gonna add 2 new rows. I'm gonna put r.Nanite.Allow.Tessellation equals to 1. I'm gonna put 2 enters, and then I'm gonna put r.Nanite.Tessellation equal to 1. So those 2 commands are in the description of this video. If you don't want to manually type them or something, if not working, just copy and paste it from the description. But those will enable tessellation and displacement to work inside your project. After that, you need to save this DefaultEngine.ini file and restart Unreal Engine. So right now we don't see any tessellation. We enabled the Nanite on the landscape. We enabled the Nanite into DefaultEngine.ini, and this was working in the previous version of Unreal 5.2, 5.3. But in the newer version, you need to open the master material. And here you need to search for displacement. So you have here under Nanite, you have displacement and displacement fade. And here you have this section under Nanite, enable tessellation. So I'm just gonna check it. You also have the ability to enable the displacement fade. This was previously not, included in Unreal Engine, but this is very useful function because it will save a lot of performance because it will fade out at the distance, and you can set up at what kind of distance. So I'm just gonna enable this too. And the start fade size in the pixels will be 4, and the end fade size in the pixels will be 1. So I think the defaults are working just great. And now I'm gonna save and everything will just break up. So we enabled the displacement and you can see that everything is so hard, right? So I'm just gonna fix this. And how we fix it, open the displacement, and here under magnitude, I'm gonna put something like 0.8 and I'm gonna save it. And remember that those magnitudes we can tweak in the textures. And right now, if we go into our MI landscape here, let me just resize this a little bit. You can see how many details right now we have. The details by mixing up the displacement and the normal maps are giving so much detail. Let me just play it pretty quickly so you can see it. And this is all fake. This is all with a texture, just displacement and normal maps combined. Again, it is too hard right now. We're going to soften it a little bit, tweak it up so we can have still details, but not so sharp. Because when you go over here, you can see that it is a little bit stretched. But if we turn on the Triplanar, this won't be stretched and it will look good. It depends on what you need, but I'm just going to tune down a little bit. And if we start working with our displacement settings, let's see 3 here, you can see that we are popping out some sections, or we can soften them out, 0.5. Let's do the middles, 0.2. Sometimes the shadows are buggy and you just need to refresh. So here 0.2 is a little bit going down, so 0.5, 0.6, 0.5, 0.4, 0.5 is good here. And if I play it, the shadows will be fixed, as you can see. All right, here, let's try for the scale. I think it's 0.5 good. And here, I'm just gonna raise up a little bit more over here, just not to have these sharp edges, but 0.5 is too much because it will make everything flat. So I'm just gonna use 0.2. Let's test this out. And we have nice details, and we don't have this like a buggy edges over here. Yeah, you can still see them, but it's not something too obvious, and that works great. So from here you can tune up everything that you want, you know, to pop it out. And we are working here on a texture level. We are working with the exact texture, and we are not touching this magnitude. And from here, if you want more to soften them out, just put 0.5. Or if you want to make them stand out more, just put a magnitude of 1, for example. But this is a global, and this will work on every texture. That's why I expose those parameters, so you can have control per texture, which is very important. Then I'm gonna save, and let's proceed to the next material. Right now, we've set up our rocks here. We have good details in them. They're popping out. So I'm just gonna scroll. Let me just minimize this. So I've worked with this. It is already set up. If you want to make some adjustments in layer 1, just go ahead and make some more adjustments. And right now we're gonna work with layer 2. So for layer 2, under here, under my textures, I'm gonna select layer 2, and I've already prepared my textures. So I'm just gonna enable those layers, and I'm just gonna enable the ORD, because I'm gonna use the ORD workflow. And I'm gonna plug ORD here, I'm gonna plug the normal here, and I'm gonna plug the albedo here. And right now it starts working over here, but of course we need to tweak it up in order for us to work properly. The first thing is to work with the slopes, so I'm gonna enable the slopes, and here I'm gonna put 450, and for the slopes power I'm gonna put something like 2500, something like this, so we can see that the slopes are taking over a little bit of the rocks. Then moving forward, I'm gonna tweak up the normal map. I'm gonna select it, and here 0.01, adding details 0.2, 0.1, something like this. So I'm just adding micro details to the normal map. We're gonna fix the displacement. So right now everything is, you know, so spiky here, and we are going to fix that by tweaking up the displacement. So I'm gonna enable the displacement and put 0.6. Here will be 0.5, and here I'm gonna do 0.6, and it's still not looking very good. If I play it, you can see that you have these edges like a patch, and this we are going to fix by tweaking up the tiling, and I'm just going to use 1000 and 2000. Let me try 150 by 2000. You also can tweak up the displacement in height for the rocks, but right now it looks way better. Yep. Right now it looks good. So you have this detail also in this layer 02. And the next thing that I want to do is I want to color correct it. So right now this is not looking like a mossy grass. It looks like a sand or something like a mud. And I will color correct it with a defined green color. And you can see that it's way brighter. Let me just select a cover like that. All right, way better. I'm just playing up here with the green values, and also you can tweak up the alpha. So I'm going to put 0.5. This is like the tint that we are adding onto our texture. And right now it's getting better and better. Let me see. Way better blending, like the colors are matching, like this is dark and this is dark. Okay, and I'm just gonna do a little bit of brightness, 0.28, 0.2, and for the desaturation, I'm just gonna put 0, not to desaturate too much, but that's too much. Let's try minus 0.2, 0.3. I want to have this green color inside it, so yep, this looks good right now. And you also can tweak the ambient occlusion. Let's try with the ambient occlusion a little bit to give more details to this. Let's see what this will do. So the AO blacks are not working. Let me try like this. Oh, so this is the AO blacks. Let's try with some negative numbers. Let's try 5, 1, minus 5. Always try with some extremes to see what this will do to the texture itself. So let's try with the grays. All right, the grays are working great. If you want to have more dark colors in it, 0.2. Let's try with 0. Here, let's try with 3. Here, 0 is too much, so 0.2, 0.3, something like this, but this is too much. The dark spots, you see the yellow dots. Let's try with -1. You can see here we're adding micro dark details. -5. I'm gonna go with -1. Let's try with the grays. And we are getting a little bit more details here into the grass. And let's try with the white ones. This is giving us too much white. 1.5, 1.3. All right. And we just change a little bit the ambient occlusion to get more details on the ground. All right. Pretty cool. So we are done with layer number 2. Of course, you can go here, play with the levels, play with the roughness, play with the tiling, play with the displacements to match with your rocks. You can go back into your rocks and just play it again with the displacement, not to have this, big gap over here. It's up to you. And if you want to tune down the displacement, like how hard it is, go into your master material and under displacement, you can play with the magnitudes. If I put 0.6 and just save it, we're going to have less visibility here and it will be way better blended. All right. So we are ready with layer number 2. I'm just going to save. And now I'm just going to close here everything. Before we continue on with layer number 3, we need to set up here a few things at the slopes. So here under slopes multiply, I'm going to put 1.56. And for the slope power, I'm going to put 24.7. For the slope edge soften, I'm going to keep it to 1. And here in the slope mask channel, I'm going to use the red. And here I'm going to use this slope mask. Now, before we make layer number 3, let's do the snow first. So I'm going to open the snow here. And the first thing that we're going to do is go to snow, enable the textures. So we are going to put them into work. And I'm gonna use height texture. So I'm gonna plug the albedo here, the normal over here. We are using the ORM workflow. So here ORM, and here I'm gonna put the height texture. The next is to work with the black and power with the slopes. So go under color correction. I'm just gonna open this a little bit. And we're going to use the desaturation, the black power, and the white power. For the saturation, I'm going to use 1. For the black power, I'm going to use -1. And for the white power, I'm going to use 2. And the final touch that we need to do is we need to scroll all the way up here under layer snow. And from here, we say how the snow will spawn based on our world. Let me just boost up the speed. So right now, the snow should be spawning here at the mountain. So I'm gonna enable world height, fall off distance, and the height variation scale. And for the height variation scale, I'm gonna put minus 22,000. And right now you can see how the snow is going here. For the fall off distance, I'm gonna put 2000. And for the world height, I'm gonna put 500. So right now we have this snow across our land, and you can start tweaking up the tiling. Let me go all the way down to the layer near and far tiling. Let's try with 1000. Let me just play it because the shadows will be fixed that way. And now you can see we have some spiky snow here. This is from the displacement. And let's try something like something more far, 150. So it looks like that, and when we zoom it's like that, but that's too much. So let's try 800. So it's a little bit more dense. Let me play it. And the next step is to start color correcting and fixing this. So I've set up the snow because it's way too much tweaking, and I'm just gonna show you the final result. Here you have the snow looking pretty good. You have this highlight like the snow is iced and it's like in the end or maybe the start of the spring in the mountain, but the snow looks pretty good. You have this very nice detail here with the displacement and with the normal map. Also here you can see the dark spots where it's blending with the rocks itself. You have some foliages here starting up. And let me show you the settings of this kind of setup for the snow. So here is my AO black. So I've used the AO gray 0.3, the rest is 1. For the color correction, I used this linear hex, which is 599 FFF80 with alpha of 0.5. Then the brightness to 1, contrast is 0.1, black power 3, the saturation 1, and the white power is 1, displacement 1, the scale of the displacement 0.5, and the other is 0.5. The normal intensity, to get this little nice detail, I've used 0.01, and for the normal power 0.08. Roughness is 0.1, the roughness power 0.5, and specular intensity is all the way up to 1. For the snow near tiling size, I've used 700, so I have this repetitiveness in it, and I have this good details here blending with the rest of my environment. I like how it blends with the rocks and with the displacement. And for the far tiling size, we have 2000. So this pretty much sums up our snow setup. And let's go back to the slopes, and then we go back to the layer 4 and layer 3. Now let's finish up layer number 4. I'm gonna go here and I'm gonna enable all the textures like that. And I'm just gonna use the same Heightmap and RM workflow. And let's start plugging the textures. So I'm gonna plug this here. This is my height, this is my normal map, and this is my ORM. And if I zoom at this section, this is our layer number 4. Let me just tune down a little bit the camera speed, something like 1, so we can set it up. So I've set up the layer number 4 because there are a lot of settings. So I played around with every settings and I came up with this result. Let me show you how it looks. When we spawn our character, we have these nice details in the rocks. You can see here. And we also have the specularity in the rocks and the shininess. Like this is a little mud patch in our grass and it blends perfectly with our grass. You can see that. Let me just move like that to see the displacement. You have these details onto the pebbles, but when you're playing your game, every little detail of those will show you how great this looks. See how when we move our camera, we have the specularity here only in the mud and on the wet sides of the rocks, and it looks pretty good. Let me show you my settings. So those are my settings for AO. So AO Black 2, those are ones, AO gray 0.4, gray intensity 0.5, AO white 0.9, white intensity 1.3, white power 1.2. For the cover, I use this hex linear 25 1B 10FF with alpha of 1. Then for my brightness 1, for my contrast 0.22, black power 0.05, white power 0.5, the levels gamma 0.45. We have the level outputs black 0.48. Then the displacement 0.5, the medium is 0.6, the minimum 0.5, normal intensity 0.01, normal power 0.1, roughness 0.3, roughness power 1, specular 1, and for the near and the far I use 400, and for the far I use 1500, and this is how I think it blends good. But if you want to have more, more pebbles here, you can use lower, like 200. Maybe it looks good for you. You want those small pebbles and they look pretty good, to be honest. 200 is very good and it blends good with the grass. So those are the settings for layer number 4. Let's proceed with layer number 3. The next layer that I want to tweak is the slopes, and I'm just gonna reuse the layer 03 texture. So here under layer slopes, I'm gonna enable everything, and I'm gonna use also the RM workflow. And here at the mountain, you can see that here we need to substitute with slope. So I'm just gonna plug those textures here and work with the RM. So right now under the slopes, I've set up everything because it's some time to tweak, and those are my settings. So I've put for AO white 0.9 and for AO gray 0.4. My color correction is 050402 FF with alpha of 1, brightness 1, contrast 0.2. The desaturation is 0.7. The desaturation is minus 0.7. Slopes is 0.02. Under the black power, the white power is 0, and the levels gamma is 0.088. We have displacement of 0.8, 0.5, and 0. Normal intensity, 00 with 1, with normal power 0.1. For the fall off power for the slopes, I have 2186. And for the near and far tiling size, I have 1K to 3K, something like this. Of course, you can tweak them up, refine them a lot more. Right now, what I see as a problem, you can see here the stretching at the snow. And that's why we've created the Triplanar. And when I enable the Triplanar, you can see that all the stretching is gone and everything looks great. So right now we are ready with our slopes. You can see how good it is looking, the mountain. Of course, you can tweak the snow, you can tweak the fall off of the snow. How do you want to fall off, at what range, etc. But everything is tweakable. You can see the highlight here on the snow when you move, telling you that this is an icy area. You can use this in your gameplay, etc. So let's continue on by setting up the final layer, which is layer 03. So for texture number 3, I've put here under texture 3, and I have those settings. Let me just walk you through them. So the first setting is my color correction, which use 5A4734FF as a color. I have brightness of 2, contrast 0.23, the desaturation is 0, the black power is 0.136, for the displacement 0.8, 0.60, normal intensity 001, and normal power 0.1. For the slope, styling size of 11K, almost 12K. Let's do it 12K. For the contrast, breakup 1. For the slope, power 51. Under near tiling, 500, and tiling size 4000. And let me play this just to show how it feels. So you have those rocks, you have the mountain over there, and I'm just going to show you how you can start blending together the layer 3. You can see how much details we have here. And at the far, the mountains, you can see the snow, etc. And by using the slopes here, I can start telling how each layer will blend out. So if I start using the power, you can see that we're giving more power to this layer. So we have more grass, or less power to this layer. So we have more of those rocks. If you want not to be so repetitive, you need to tweak up the tiling. to be bigger, and you can see it like that. And when I start doing this, you can see that we are feeding the ground with grass. So I hit play and we have more grass over here. So you can see how we turn this environment into a beautiful scene. And this is just a couple of minutes tweaking up. Imagine if you get the right texture, work with the sliders, blend everything how it should be together, have these nice details, fix the snow layers, etc. But in no time, we've created something very beautiful. So the other thing that I want to show you is when you go to the landscape and you go to paint mode, here you have the layers, but you don't have any assigned layer. So you need to click here, create layers from assigned materials. Click it once and you're gonna have those materials pop out. Then you need to assign weight blended layer per each of the layers here. So I'm just gonna create this for layer 4. So now after we created all the layers, what we have here is layer 1, 2, 3, and 4. And we can select one layer and start painting over our auto landscape material. So if I paint over here, wait a little bit to refresh the shader. So when you select layer 4, you can start drawing here this layer onto the landscape. Let me just move the camera a little bit. And let's say you want to paint some of those. You can paint those. You can paint some green here. And you can always control the brush fall off so it can be way softer and blend with the others. Or you can select layer 1 and start painting over the others. So there is an option to hand paint your terrain if you want to. And also if we select automatic blend no foliages, meaning that it will automatically blend everything beneath and will remove the foliage where you want. So right here, it is making automatic blending and we're just removing foliages from this kind of land over here. And if you want just to apply the automatic blend, you need to add a new layer and select this layer, press F2 and call it automatic blend. And assign for this layer a weight blended layer information. I'm just gonna assign it here. And for example, we've painted some areas here, but we want to get rid of them and we want to use just the automatic blend with included foliages. So for example, I've removed some foliages over here like that. And I want to get them back. So automatic blend layer that we've created, right click, fill layer. And once you fill it, you'll get your foliages back. So there is a lot of control that you can use from here, paint manually layers, remove foliages, or just automatic blend. So this is one very useful feature that you can use in the creation of your landscape for your game. So this pretty much summarizes everything about the auto landscape. Now you know how to create it, you know how to manage and adjust every parameter of it. If you want to support me and my work so I can keep producing those videos, you can go to my Patreon page and subscribe. Also, you can subscribe to my YouTube channel in order not to miss another great tutorials that I'm going to make in the upcoming future. Thank you guys for staying with me so long. I hope you enjoyed the tutorial. I hope you learned a lot about material creation. See ya in my next videos.